React.js for Beginners, a 7-hour-long course where you will learn the ins and outs of React starting from zero. So this means to you that you don't need to know anything about React, you don't need to have any prior React knowledge, any prior knowledge on JavaScript classes or on JavaScript functional components, MapReduce and filter. These will all be explained in the course, and we will build an app in React. So it's not just reiterating the main concepts, but also about getting the hands-on practice. I encourage you to even code along with me, so that this will be a transformative experience for you. So let's jump into the topic itself. So the contents of the course. First of all, you will get a 20-25 minute long teaser about what you're gonna do. There is a chance that you won't understand everything. It's not a problem. It's designed this way. This just gives you an experience on seeing why it's important to learn React, why React is so powerful, and how you can get things done fast without understanding basically anything about React.js. So afterwards you will learn the basics. So we will get a JavaScript refresher. I'll use some of my materials that I have on my blog, joltnoy.eu, or on this YouTube channel, so you will be able to get started. It's not a repetition, so you will find some links in the description below if you would like to refresh your JavaScript knowledge for it, but there is a chance that there will be no need for that. I encourage you to jump into writing code just by following what I'm doing, and if you're lost, then you can see my other materials because they will help you for sure. We will deal with modern React, so no 2015, no 2014, no React.create class. We will use class-based components and functional components as well. You will learn what they are, and we will use the latest 2020, or later techniques that are there in the latest React 16, and we're moving with the latest advancements in React. So we're gonna use React hooks, for instance, which is a new addition since 16.7 or 16.8, depending on what kind of version you used. But this is a relatively new angle to learning React. Most of the tutorials use older React, by the way, and this means that your knowledge might be a bit outdated, because if they say that, for example, a functional component cannot have state, it's not true anymore. We can have state, whatever it means, of course. We will figure this out in a few hours. So you will build an app from scratch. What does this mean to you? We will not just learn concepts. So this is something new as well on this channel, because I was explaining concepts about JavaScript promises, JavaScript, whatever else. This time we're going to build an app from scratch. And you'll be able to host it on GitHub pages, you'll be able to work with it. There is going to be absolutely no copy pasting in here, so it's not like the typical tutorial experience that, let me paste this 200 lines of code in here. This is basically doing what the application is supposed to do. No, there is going to be nothing like this. I will code everything from scratch. I might copy paste my own code if it's needed from one file to another, but the source will be written by me and you will see me on screen typing it. And then at the end, there is gonna be hosting for free. I will teach you how to host a React application on GitHub pages using the GHpages npm package. And this will mean to you that you can write a React application. All you need is just a few applications or even one to be employable, to be hireable, to demonstrate that yes, I can do this too, and hire me. Here is my app, I'm hosting it on GitHub pages, here is the source code, and then some people will appreciate it and they might be able to, or they might hire you even if you stand your ground in the interview, which is another topic. So React interviewing might be an interesting future video topic as well, because not many people have interviewed software developers for React. I've conducted about 500 interviews in the past, so why not deal with this topic as well, because there are a lot of nuances that you need to know what to do in a 1 hour long interview, for instance. Alright, everything is gonna be explained because the target audience of this video is beginners. If you're a bit more advanced, use the table of contents in the description, because I provided you with a table of contents with links, and you can click the time that you're interested in or the topic, and then you will be able to refresh your memory on it. So it's also user-friendly for advanced people. Let's see the concept. This is going to be a very long list because there is a lot of quality information in this 7-hour-long course, and it's practice-based once again. So we're building an application. So we will create our application using create React app. This will save us from configuring, using Webpack, and making sure that we can use, let's say, a preprocessor, styling preprocessor, and a lot of other things. So we will be able to import all our files, bundle our JavaScript, and even deploy and host it on GitHub pages, thanks to Create React Apps configuration, default configuration. We will develop using Visual Studio Code. So it's basically the best integrated development environment that you can have, right? So it's in the State of JS survey, it's in the Stack Overflow survey, it's everywhere. So or Visual Studio Code is the editor of our choice. And if you don't know, for example, some of the concepts that React developers often use, for example, MapReduce filter, functional programming, no problem, we will cover that. If you don't know what JSX is, this extended JavaScript syntax for React components, no problem, we'll cover that too. There is going to be nothing mystified. And then we will write our first React component from the perspective of what app we want to build. So no foo, no bar. If you see a foo or a bar in my videos, well, you haven't seen this before either, but now I'm doubling down on creating useful projects. So no foo, no bar. And then we'll write some React components, React fragments, which will help you group React components. This boils down to, writing valid JSX. So sometimes you need to use React fragments for that. Then we will nest components inside. So we will use components that we write as if they were just diffs or headings or anything else, or paragraphs, for instance. Then we will add props to components. These are like HTML attributes, but we will be able to work with them inside our code. Then we will render lists as well, and we'll learn why the key property is very important in rendering lists. We'll handle events, for example, clicks and form submissions, and then we will also write some class components. So we not only have functional components with hooks, but also class-based React components. And for that, it might come handy on what you need to know about JavaScript classes in practice, right? So I have quite a few JavaScript books that have been around since 2015, the new version of JavaScript. And this means to you that you'll be able to learn classes just from the perspective of what you need for these React components. That's all. Now that after we know classes, we will also get to know lifecycle methods and also state, both in class-based components and functional components. But then also not only for classes, oh, there is an ambulance in the background, but live recording is live recording, not a problem. So not only for classes, but also for functional components, there is gonna be a very good Chrome extension called React Developer Tools that you'll be able to use to check out what's going on inside your components. So we'll install it and we'll use it inside this course. Then we will create forms, and we will learn these concepts of prop drilling when passing state down the component chain and lifting states up. We will also start styling components. These are not the styled components approach, by the way. So if you have heard anything about styled components, we're not gonna do that. We'll just use simple CSS. So don't think that it's styled components. It will be some more advanced topic or a different video. But if you prefer styled components, use it. So you will know how to use it anyway, because I'm only using classes in my CSS files, right? So you can simply create your styled components as well. And this could be a deviation with respect to what I'm using in the class. Then we will apply destructuring and the spread operator as well in this course properly in React. But don't worry, you will learn everything inside the course, so you don't even need to have prior knowledge of that. Then at the end, we'll bundle our application. We'll create a JavaScript file that will host at the end on GitHub Pages. And you can host it even if you already have a GitHub Pages page. So you can have a repository, like you rename your repository to your username.github.io, and it has to be public, then it's hosted on github.io, right? And then with the GHPages npm package, you can upload a second application as well to GitHub Pages, and this is gonna be the hosted React application that you will have online quite soon, after finishing this tutorial. So there are a lot of things that we're gonna cover. I hope that it's gonna be a good experience for you. Let's see how this course should be used. So imagine that there are 3 levels. First, we just watch and learn. So this is level 1, and I don't encourage you to watch all the 7 hours because I'm not Netflix in terms of entertainment, although I could maybe you will hear some stories that are kind of shocking or funny and so on, but it's still not Netflix, right? So this means that that it's better if you learn. So if you create something useful while watching, so just watch enough so that you can get started coding and then code along with me. That's the best use of your time. And then if you deviate from the course, so for example by replacing your styles with something that you know, either Sass or styled components or anything else, you can do that. It's very simple. Or you start fiddling around with the functionality, you can do that too. And this way you will take the most out of this course. Then a React course is coming. Not everything is free, like this is beginner information that I'm sharing on this channel. But if you sign up on joltnight.eu, link in the description below, then I will notify you once this React course is out. And if you watch this video far in the future, then it might mean that the course is already out and you will be able to learn advanced React components. So this will mean that I will take you from 0 to solid in terms of React knowledge, basics, so that you can do a lot of things with React. And then we will go from this state to advanced in the other course. So this is what's gonna happen. But this is not like a 20-hour long webinar where we have 0 content, so it's rather action-packed. So once again, the 3 levels or phases: jumpstart, 20-25 minutes. This is what's gonna come very, very soon. And once again, if you don't understand the first 20 minutes, no problem. This is just an illustration of what React is capable of. I've tried to make it as understandable as possible, but not everyone will understand it, no problem. As soon as you give up, just watch it or skip it with the table of contents, and then we will cover the basics afterwards. So this is just a teaser. Watching it still makes sense because right now, if React is fully alien to you, your brain, your neurons will start aligning in such a way that you will hear some concepts, and these concepts are going to be very interesting to you, very important, because even if you don't understand them, you will hear them. And then once we explain things in details, you will hear that, oh, I have heard this already, and this is going to be something important to you. Because then you will make the connection that, yes, we did something with it before, I forgot what it was, but it seemed to be important, so I will pay more attention. This is called priming, by the way. Darren Brown is doing the same thing, by the way, in his TV show or whatever. So it's this is the effect of phase 1. It's not meant for you to understand everything. It's meant so that we start this priming process so that you will learn afterwards in the step-by-step manner. And then we will cover the JavaScript and React basics, but we already start building the application with the examples. We just don't realize it yet. And then we will build the app. Well, phase 2 and phase 3 are kind of mixed this way. So these are the 3 phases. And you see that there is soon going to be a congratulations in about 7 hours, 6-7 hours. But so far we are here. So let's jump into the jumpstart part. So the first 20-25 minutes, enjoy that, and afterwards we're gonna come back and I'll take you through the React basics. Let's go to codesandbox.io. This is where we're gonna experiment with the latest React updates, and we're gonna just create a simple flashcards app. You might have used flashcards when you studied a language or studied math or something else. It's like, you know, on one side there is the question, and on the other side, when you flip it, there is the answer. And this is very good for memorization. We're gonna build a React app that will do exactly that. So let me explain what's going on. We're going to codesandbox.io. We're clicking the Create as Sandbox, it's free button. Then select the React as a template. React has this atom as the icon. You will recognize it everywhere from the solid light blue color and the atom symbol. So we have a React application in here. Don't worry about all the details. I said you don't really need to know programming to start following what I'm doing. So let's see. We have this import React from React line. And afterwards there is this import styles.css. The first one just imports the React library for us, and we're gonna be able to use the React library inside the code as React with capital R. With the style.css, we will just have some styling so that our flashcards are not gonna look like simple text, but they will be somewhat good looking cards. And then we have this app function, and there is a chance that you understand it. If you have learned some HTML, then you know that we have a div, a heading 1 and a heading 2 element. So you have this hello code sandbox, for example, that's our main title on the right, you see? And then we have the start editing to see some magic happen. That's also on the right with heading 2, which is somewhat smaller than heading 1. And of course we group all these inside a div with the class name app, which is gonna be important once you will see the styles. So that's all the code. Whenever you see code like this, it's important to always fiddle with it. So explore what if scenarios, explore what happens if you change something. For example, it's not too risky to change the titles. So we're gonna start writing some proper titles, flashcards, and the other one is click on a card to reveal the secret solution. So this is what we're gonna do. We're gonna build flashcards, right? So far it's easy. You see that whenever you make changes, the changes appear on the right immediately. Next up is the card component. Let's just imitate what we just saw. You see that there is this function. Now we're not gonna export it, so this export and default are not gonna be in there, but the function will be. We're gonna create a function card, and we're just gonna return a simple div with class name flashcard and just the front side, so it's just gonna be simple text. Once you save changes, you see that this code sandbox just auto formats everything for you. So even my parentheses are gone. I know if you have experience with React, normally these components go to their separate files. We'll do that later. Let's not confuse ourselves with some more difficulties. Now comes the real beauty. All we need to do to create card components is just after the H1 and the H2, we can start adding these card elements. Cards are with capital C, it's the same as the function name. And as I add all the cards, they display their front side below each other. It's that easy. Next up, let's add some styles. We're gonna write some style sheets. These style sheets are in styles.css. You already see the main app style, and we're gonna add some styles for the flashcard, so that they look like flashcards and not something else. This is technically not React material, so you either know basic CSS or not. Don't sweat it at this point. We're just describing some basic properties. So for example, flashcard, the font size is gonna be 24 pixels. The line height is gonna be 3 times that, so 72 pixels. This means that we're gonna have some text, some space at the top and some space at the bottom. The width could be like 3 times the line height, so we'll have 216 pixels. The border is gonna be black and solid, just very narrow border. And now you can see the 3 cards aligning. That's good about CSS, by the way. What you see is what you get. You make a change and it immediately appears on the right. Now you see that the cards don't look that good, that they are just below each other. So let's add some margin, let it be 18 pixels. Let's add some background color to the card. For example, this 200, 200, 200, red, green, blue color. This is gonna be good. And notice that once we hover over the card, the cursor is not correct. So it needs to be a pointer. And there is a last problem, that if you have some text on the card, it's selectable right now. Let's prevent that with user select none. This is just some CSS. You can just copy what's on screen. We would like to reveal the back side of the card once we click the card. So we just go to the card component and we're going to display some other text whenever we have the front side or the back side changing. This is going to be some new React element. That's going to be one of the surprises I promised not too long ago. So let's start with const. This holds for constant. So in every function we have either constants or variables. We'll just create some handles through which we can access some values. And here we're going to add a bracket, text, and set text. So this is going to be a structure that React is going to return for us. We need a React concept to be able to determine if we're showing the front side or the back side. This is called state. Every single card has a state. It's either on the front or on the back, right? So this is what we display in there. Let's model the state just by grasping the front side and the back side text. We're going to do this with react.useState. Notice React is already imported for us, so we have access to this useState. And then we're just going to initialize it with some initial value. That's going to be the front side. And this react.useState returns a structure that we can describe as text and set text. And then we'll just add the const JavaScript keyword in front of it to symbolize that this structure, this list or array is a constant. This first value text returns the current value of the state at any point in time, and the set text is responsible for changing the text. If we can access the current value of text, then why not just replace the front side with this text? We can do this in React by putting braces around the variable. So far so good. So the only thing we need now is handling the click. So let's create a click handler function. We can just write function handle click. It's just a JavaScript function. And inside this function, let's call set text. And let's set the text to backside for simplicity. We have access to this set text because it's in the same card functional component. The only thing we need now is to add this handle click in the onClick property of the div. So whenever we click on our card, the handle click function is executed and it changes the state from front side to back side. Notice that the rendered code doesn't change at all. I can click on any of the cards, they are flipped to their backside. And we didn't ask React to re-render anything for us. We just changed the state. React is written in such a convenient way that it finds out on its own that the card has to be re-rendered because our component changed. Just imagine how easy is that. So you don't really need to add any rendering logic, changing classes. You don't even touch the DOM, you don't even touch the document at all. You just manipulate the state and let React do its magic. Now, this is all great, but it's not enough because think about it. These flashcards are quite useless. They just have a front side text and a back side text. What if we could just add the front side and the back side of the flashcards from the outside? So you have these card components, and what if I just added this front side property and I add the question like 9 times 6, and the back side, which is the answer, it's 54. And then the next one, 2 to the power of 8, you know, the double asterisk is a JavaScript operation. It's the power. 2 to the power of 8, it's like 2 times 2 times 2 times 2 and so on 8 times. And the answer is 256. The third one, let the front side be rabbit times 8. And well, what is rabbit times 8? Well, it's obvious, it's rabbyte. You know, 1 byte has 8 bits. This is gonna be the content of the third card. We just need to make the app accept our text. This text is called props. Inside the function card, we can just create a props. In other frameworks, this could be a lot more painful. Notice in React, it's just a piece of cake. We just pass the props, and inside the props, we have access to all these properties like front side and back side. So the initial value changes to props.frontside. Inside the handle click, the set text is gonna be props.backside. So whenever we click, we reveal the backside, and that's it. You see that now we have proper questions and answers. Maybe it's time to do the promised cleanup. So let's move the card component to its own file. Copy pasting the card, and don't forget to import React. Here we don't have to import the CSS because it was already imported in the app. Later it maybe worth separating styles for each and every component, maybe even putting them in their own folder, but here we're just playing, we're just experimenting, so let's not worry about this. Also, don't forget to write export default in front of function card. We're just copying what's in the other file. In the app, the card component is deleted, so it's not working anymore. Notice the error. Our code doesn't find the card component. So let's import it. This is something new because we have to import another component from another file. So we write import card. So card is going to be the name through which we're going to refer to the card from the app component. And you need to add the from keyword, and afterwards, instead of writing card, you need to add the dot and the slash in front of the card name to tell JavaScript that card.js is in the same folder as app.js, because we're doing this from app.js and we just need to tell JavaScript how to locate the card. Now the code is working as expected. Let's go back to the card component for a moment. And I'll fill you in a secret. Advanced JavaScript developers don't really like typing that much. There is even this acronym DRY, which stands for don't repeat yourself, and the opposite of it is obviously WET, which is we enjoy typing. And whenever we can save some references or anything that could go wrong, anything that could go wrong will go wrong, we just simplify. So why would we keep on repeating writing this props dot if we don't even need them? It's not a bad thing to write props, it just complicates things a bit. So we can use a great JavaScript feature called JavaScript destructuring. By the way, check out my video on destructuring for more details. It explains everything you need to know about destructuring. It looks like this. Whenever you have props, which has a front side and a back side property, you can dig inside these props and just take out the front side and the back side as variables. You just need to add braces. These braces are different braces than what you can see in the text. So in the text, we're just telling the renderer that here you need to substitute a JavaScript expression. In the card component, instead of the props where you have the front side and the back side, you tell JavaScript that this is an object, this is a JavaScript object, and we are looking for the property front side, and give me its value. Same holds for the back side. So these are completely different braces. And now we can just delete props dot in front side and in back side as well. Similarly, it's the same destructuring assignment. You also have use state. You can take use state out from React just by writing comma after the React, which means that we would like to import a second thing after React, and it's gonna be just the braces and use state. It means give me the use state property of React and make it accessible inside the use state. So now we don't even need to write react.useState, we can just write useState. Let's see what's missing. This app is cool and all, but frankly I would prefer flipping the card back to its original side after the second click. You see, we click once and we just keep on seeing the back side. It's not that good. For this to happen, we'll need to update the state with a function. Because in React, we're not modifying the DOM. We cannot just add classes to the cards, or we cannot just change their colors. It doesn't work like that. It works in a way that when we change the state, we derive what we need to render from the state, and React will decide when it will render the component. This solves a lot of headache for us, and it eliminates a lot of mistakes, so it's very good that we do it like this. So all we need to do is we can change the set text from accepting a simple value, a simple constant, to accepting a function. In this function, we have the old state on the left. It's an input of a function. We can add an arrow, and after the arrow, we can add the body of the function. So this is like an arrow function. The return value of the function body describes what the old state becomes. So if the old state is currently the front side, we can compare old state and front side with, for example, triple equals. This is a typical JavaScript comparison. Then we return the back side. Otherwise, we return the front side. And now you can see that as we click, we can alternate between the front side and the back side. This arrow function is the exact same thing as writing function old state. So if you don't like this arrow function notation, it's alien to you, just use this old function old state This arrow function notation is very similar to writing function old state. In fact, in this context, we don't even observe a difference. So if arrow functions are alien to you, like input, arrow, output, then just use function old state and you're set. By the way, I also have a video on arrow functions in my channel, so if you want to learn more about arrow functions, check out that video too. Alright, now we have front side and back side. We could go on and on. You could add new cards, delete cards, connect with a dictionary service, for instance, to learn a new language, or we could easily transform this app to a memory game even, maybe another time. Let's stop this experiment here, but let's just add one more step. Adding a lighter touch to the card background once it's flipped. Why is this important? Well, because we need to know which guesses we have made already. So whether we're viewing the front side or the back side. When people study, it's kind of important. So let's rethink the CSS. We'll make the background depend on the front and the back class. So we're gonna add the front class and the back class. We're just gonna chain it inside the flashcard. Given we have CSS, this is the way to describe this. And we'll just add the background color to be this light gray and the front, and some other color on the background. So it doesn't really matter what it is, it's just different. It should look somewhat lighter, possibly because it's the answer. But now the situation is that the only state that we have in the card component is this front side, back side text. This text should have nothing to do with what color we have. So let's rethink the state. What if we could just store if you're seeing the front or the back of the card? It would make more sense, right? So let's do that. So if we are seeing the front, we're just going to use isFront as the name. And for the second setter function, we're just going to use changeFace. And then the initial value is going to be true because we're seeing the front of the card. I know you may have 1,000 questions on how React figures out all this state magic, but notice this is a good thing because React is damn smart and it does a lot of work instead of you. Just remember one thing, pay attention to the state changes and don't touch the DOM by manipulating colors, adding classes and so on, because this is not how React works. Just be clever about how you describe your state. So with our last change, the text variable is gone, and this means we need to re-add it as another constant. So we're just gonna write isFront. That's a Boolean expression. If it's true, then the value of this expression is going to be front side after the question mark. So let's use a JavaScript ternary expression, ternary operator. We have a Boolean expression isFront. After the question mark, we have the value when isFront is true, so that's going to be the front side. And after the colon, we have the back side. It's when isFront is false. I could write if-else statements, but why doing this in 5 lines if you could just do it in 1? So it's like, if isFront is true, then text is front side, otherwise text is back side. Let's now address the handler. So there is also the event handler. We can do a lot of simplifications actually, because all we need is, we just need to flip the state. So we have this changeFace function, now it's called changeFace, and we need to flip the old state to not old state. The negation is an exclamation mark in JavaScript. So not old state, if old state was true, it's gonna be false, and if old state was false, it's gonna be true. And that's all. Let's now describe the classes that have to be added to the div. So we have this side class front or back. It also depends on the isFront. And we can add this class to a class list. Here we're gonna use JavaScript template literals. So we have these backticks. It's just below your escape key, by the way. And we have Flashcard, that's the first class. And inside the template literal, we can add the JavaScript variable. Similarly to the text at the bottom, you see this rendered element, but we need to add a dollar in front of it because that's how JavaScript template literals work. Check out my article on template literals, it's on my blog. They are very useful because you can even write text in multiple lines. So here we assemble the class list, and we can just add this value to the class name property of the rendered value. Here you need to use the same symbols, the open brace and the close brace, to tell React that here a JavaScript expression is gonna be evaluated as the class name of the div. And now, as you can see with the clicks, the cards change color as well, and they also reveal their front and their back. Maybe there is just one important detail about React applications that you might want to see about how this application is rendered. So React is separated into two separate parts. One is React that builds the components and everything else, and the other one is called React DOM. And inside React DOM, you can see that it basically has a render method, and this render method renders React components. So that's all we do. You see this react.strict mode. This gives us a development environment where every single error message is strictly specified so that you have a better understanding of what is going on. And inside the React strict mode, if we make some changes to the document, for example, we add this after the app text, then it's rendered by the React DOM.render. And where is it rendered? Well, we have this root element at the top. This const root element equals document.getElement by ID root, and it's inserted into a DOM node in the document. And by the way, if we wanted to make some more changes to the application, for example, by adding an image, remember that this rabbit image flashed once. And the way how I did it was I inserted the code of the image in the document. So this is how React applications are rendered. You need to include both React and React DOM, because obviously without React DOM, you would not be able to render your React components anywhere. By the way, if you used React Native, for example, for mobile development, you would be able to use your React components, and instead of React DOM, you would have another library that takes care of rendering your components. So these are the details of how React is used. Hopefully that's easy enough and it's inspiring enough that you get started first cloning some applications, then building web apps or even mobile apps on your own. Before getting started with writing React code, it is very important to know just enough JavaScript to understand what is going to happen afterwards. So most tutorials, most courses make the huge mistake of introducing too much JavaScript in a sense of, okay, let me introduce destructuring, arrow function, spread operator, rest parameters, default function values, cloning objects, arrays, mapping, class syntax, template literals, promises, async await, context binding, and so on, and maybe the import export syntax, so that you understand how to start writing React code. And then they go on like on a 2-hour long JavaScript course basically embedded in a React course. We're not going there. We're just gonna learn just enough JavaScript so that you will get started. And if you get a sense that you need a bit more review, like JavaScript review, then I recommend quite a lot of things actually. So one of the options are this blog post here, JavaScript tutorial for beginners. If you want more exercises, you can even sign up and you get email exercises. Or I have this bit more advanced JavaScript book, ES6 in practice, or the beginner version, a practical introduction to modern JavaScript. The beginner version is even free at the time of recording. It will not always be free, so grab it as long as you have a chance to. It basically starts with more or less this article, an updated version of this article. So if you get here, you will learn how to start writing JavaScript code. So this is your first JavaScript line, for example. You can press Ctrl+C on Windows and Linux or Command+C on Mac to copy this. Then you go inside here, paste, and there you go, the solution appears. Or if you want to do Hello React, which I didn't think at the time of writing this article, right? So you could write Hello React. There you go, and the solution is already added. If you can even do 5 or 6 times 2, and then the result is going to be 12, already printed in the output. And this is why it's important to learn by doing. So whenever you see some code, for example this console log 5 plus 2, immediately run your code somewhere, either in a field like this, so this clips, this is a great tool for blog posts, Or you can go to, for example, REPL.it or CodePen, and let's say you have some code that you read. For example, you don't believe me that 0 over 0 is not a number, then you go here, REPL.it, and type 0 divided by 0, and there you go, the solution is not a number, NaN. So this just helps you get started with the basics of JavaScript. And it's like we go through, we do some basic things like number parsing, like formulating conditions, if-else statements, iterating on arrays, this is gonna be important as well, and so on. So you just go through this and you will learn arrays, objects, functions. So for example, here you have the add function, and if you change add 5, 3, then the result is gonna be 8 right away. Or you can learn that you can also add values inside. So 2, 4, for example, and then the result is gonna be 5 plus 2 plus 4 equals 11. So you can play with all these. Then we learn the type of operator, control structures, it's also important, like if-else statements, switch statement, and then at the end loops. So you can even experiment with a lot of different alternatives, and here we have the sum array with a while loop, but if you prefer, then you can right away change this to another loop. So for example, my favorite ES6 loop, because it's so easy to use, is the for of loop. So you would write for let value of values, and then we would have, oops, I need to change the keyboard layout in the meantime because I was writing in a different language not too long ago. So now we have value of values instead of this while loop here, and we will just say sum plus equals value, there you go. And this whole thing here is just substituted by these 3 lines. So this is one way of writing these solutions. Now the console log is not gonna be in effect anymore because obviously we don't need an I anymore, and you can see the result is still 145. So you can experiment with any loops in these code examples, and this is gonna be important for you to understand how to write loops, and also what JavaScript does with your variables behind the scenes. So it's some insider information on how an array is stored. So you have this numbers equals 1965 and so on. So basically the cheat code of Sonic 2 from 1993, right? If you wanted the level select, it was like you go to the sound test 19, then 65, then 9, then 17. And then we have these values in the array. And you see what an array looks like and how we move forward with changing the I. And this I is basically the index that you can see on the top left of each box inside. So just this article is very much like a tutorial. It's like a full-fledged tutorial that you don't even see in many paid courses. So I highly recommend taking advantage of this. This is available for you for free to get started with JavaScript, and you really have a lot of content embedded in here. And then you can continue with learning the basics of JavaScript with some important and less important topics. Now, which one will you need for React? Value and reference types definitely, cloning objects definitely, some functional programming like map that too, but don't overdo it, it's not that important. Then, well, which is the next one? These 3 you can ignore for now, although they are interesting for other purposes. And, well, this was the tutorial for beginners that I showed you. Then you might want to check the HTML, CSS, just for the basics, but we will go through this together. And the using strings, so these 2 string articles as well. These are just for the JavaScript basics. So whenever you go to any article that you can see on the blog, on the left sidebar at the top, you see the categories and you go to JavaScript basics. This is where you find it. You also have some ES6 articles inside. You can check those as well. Like we will build on strings and template literals, that's for sure. ES6 promises, arrow functions, and let's see, maybe use the webpack as well, using ES6 modules with webpack. And then if you check out these 4 articles, if you need to refresh anything, then you will be more or less set. So this is instead of a tutorial, so I just give you some written examples and articles and so on. If you want to see the same thing in a video format, then you go to my Front-End Career Accelerator channel, so you're already there, right? So you're watching one of the videos, and well, there are quite a few videos like destructuring, like the webpack, it's also in a video format, the arrow functions, default argument values, spread operator and rest parameters. These are gonna be used in the React course. And also check out the class syntax, that's on the right. And let's see what else. I would recommend promises, that's for sure. And basically that's it so far. So I assume that you know what a variable is, so that might not be that important to you at this stage. This is basically the JavaScript starter, and I will now introduce JavaScript in a relatively fast-paced way for the purpose of creating some markup, some HTML markup that will be usable for us when we will create the Flashcards application. So we are learning in a project-based way. Project-based learning means that you learn just enough to fiddle with the technology and the code to do something meaningful. We'll just learn enough JavaScript so that we'll be able to understand the basics of React. So let's jump into it. We have these flashcards. So technically it's a very interesting idea to represent flashcards in JavaScript, like how this works and so on. It's very easy. We will introduce objects and arrays for that. So an object, for example, if you write let card equal, and then you have an object. You saw that a card has a front side, so front side, colon, and then whatever, 9 times 6, for example, 9 times 6. And then you have a back side. And the back side is gonna be 54, that's the result. So this is just one card. And you see that in JavaScript objects, we have this let keyword, which could also be a const. You can use a const keyword because this const means that this card reference is a constant. This card refers to this structure, and this reference cannot be changed, but whatever is inside can be changed. I'll illustrate it a bit better. So we go to pythontutor.com, and once you're inside Python tutor, don't get me wrong, this is JavaScript, so we can visualize JavaScript code as well. We're visualizing the code, and I'll show you what's going on. So we'll just copy this card, and I'll show you how this card is created in JavaScript. And then we'll see card.frontside equals and changed. So these are gonna be the two JavaScript expressions. Let's visualize it, what it looks like. And you see we have 2 steps. Step number 1, you see the red arrow here. We're gonna run this const card equals whatever. Here you see card, front side 9 times 6, back side 54. And what's the constant? So this constant is really just this arrow. This arrow cannot be changed. This arrow will point at this object forever. So we will never reference anything else but just this object. Whatever is inside the object can be changed. So whenever you see constant, just make sure to remember that it's only about this arrow and nothing else. Then we go to step 2. We change card.frontside to changed. And you see we can do this without a problem. Don't confuse this with, for example, const pi equals 3.14. For example, you know, there is this famous version of pi that you use for circle, perimeter, and also area calculations. Now here, if I say pi equals 2, then let's see what happens. Let's visualize the execution. So step number 1 and 2 are the same, and then we create this pi constant, and as soon as I say pi equals 2, there is an error. You can see type error, assignment to a constant variable. So this is what cannot happen with constants. That if you have a value, for example this 3.14, this should not be changed. Or you have a value that basically points at another object or array, that value, this value inside the blue area, that's what cannot change in case of a constant. So for example, if I say card equals something else, so card equals an other object, we can create an empty object like this, then this is what cannot change. So visualizing the execution is taking some time, but soon hopefully it's gonna appear on screen. Maybe there is an error, so you know, live recording, it's always problematic whenever we have this. So maybe I'll just reload the page and then it's gonna be easier and faster as well. So visualize the execution of this. I'm pasting it, and there you go, we managed to have a shortcut. So first two steps are the same as before, front side, back side, but then card equals empty object. No, this should not work. So we cannot change this pointer. Okay, enough talk. So let's create something that returns some HTML structure. So for that we will create a function get card template. Okay, so we're gonna do get card template, and inside this function parameter, a function argument, we have a card. So this is just one card. This card is just a formal parameter of the function. This card has nothing to do with this card. So we can just change this to first card, just for clarity. So now we have get card template, and this should return some template. And now this is gonna be very, very React-like. So you see that you have this card. For example, div class name equals something, onClick equals something else. Now we're gonna make some changes. So we're gonna make just a bit of change to this, because here we're gonna display both the front side colon and the back side. And let's make this, instead of a div, let's make this an unordered list. You know, in HTML, the UL tag stands for unordered list, and the li stands for list item /li here. Li backside text, whatever it is, /li, and we're gonna do some things about this. So don't yet draw any conclusions. This is incorrect so far. This is gonna be more correct in React. Now this is not yet JavaScript. To make this more JavaScript-like, I'll introduce something that we call template literals. So with template literals, we have a string, so some text equals ABC. Okay, this is, if you write text, then you get ABC. It's that easy. Now we also have a backtick, a template literal. So we'll have double text, and if we write this backtick, the backtick is just below your escape key, by the way. Then we can create, first of all, multi-line strings, which I won't be able to demonstrate here in this right-hand side prompt. But you know, you can create technically multi-line strings, and you can also insert other variables inside. So for example, if you write a $, and braces, then whatever is inside, it's a JavaScript expression and it's evaluated. So you have text twice, for example, that's why it's called a double text, and you also have 5 plus 2 in the middle. And if you evaluate that, then double text is gonna equal to ABC7ABC. Why is that? Because the value of text is ABC, you can see this at the top, and we inserted this text twice. And we also inserted the value of 5 plus 2, which is 7. So later we will do something very similar in React. Right now we're still in JavaScript world. So to make this code work in JavaScript, we'll have to start a backtick here, and we'll have to end our backtick here. You see that the color of all this text changed, which means that this part is interpreted by JavaScript as a string. So instead of text, we're gonna use card.frontside, by the way, as the JavaScript expression, and card.backside here. Notice that the colors didn't change at all here. So the reason why the colors didn't change is that I intentionally forgot adding the dollar sign, you see? Now, if we add the dollar sign, you see that this becomes a JavaScript expression. Let's first not add the dollar sign, and let's see what the result of calling the getCard template with the first card is gonna be. So this is just some JavaScript so that we'll be able to do our work later with React. So this is a template right away. You see that we have this unordered list item, and these things in here are printed straight away without evaluation. But as soon as I change this to a dollar like this, then magic, you see that the 9 times 6 and the 54 appears. Why is this 9 times 6 and not 54 right away? Well, the reason is that this is a string, and the string is not evaluated, the string is just inserted. So, you know, to evaluate a string, you have to type this eval, and then, for example, I think first card is accessible here, first card.frontside, and then you have the 54. Just by getting the value of first card front side, it's like 9 times 6 still in a string. That's why it's green. So let's delete these unnecessary class name and onClick attributes from the UL, and then we'll just have a getCard template here. So that's it so far. You learned how to use functions. If you don't know what functions are in general, think of them as vending machines. You put in some coins, like the card, and then after you put in the coins, you get some results. And these are the results that you can see here. It's very much like, you know, back in the days when there was like, for Europeans it was like 40 degrees, for Americans it was like 110 Fahrenheit degrees, whatever it means. And it was very hot, let's put it this way. And I went to a vending machine. Unfortunately, that vending machine had a discount. And that discount, not discount like some promotion or something, that most of the time you get a cold beverage, like Nuka-Cola or whatever else. And obviously you want to drink, right? So you, in that situation when you're dehydrated, the first thing that you want is a drink. But as a promotion, sometimes you get a high quality t-shirt randomly. So it's like super high quality t-shirt. And now think about it. You get the high quality t-shirt sometimes, and it's, let's say its value is like 10 times the value of the cola. But when you're dehydrated, you just want the cola, right? So that's kind of obvious. And I put in the vending machine and I got the t-shirt, and I didn't have more change with me. So this is why it's important to exactly specify that if we have these inputs, the results should exactly solve what, so the results should describe the results of this getCard template function. You shouldn't do anything else. So you shouldn't start setting like if you're lucky, for example, then return a t-shirt instead. So you shouldn't do anything like this. You should just focus on what this text description does, getCard template, and just return the card template and nothing else. Don't change other variables, don't change the values inside the card, don't do anything else. It's very important in JavaScript and in any other language. So you see that you supply the card, and this supply is here. So it's like we supply the first card here. And we have the front side, back side inside. It takes the front side and back side out from the card. and that's it. That's all you need. And well, this is a very easy type of description. Now, I'm not gonna get into the details right now, but after you watch my arrow functions and destructuring videos, then you will get away with, for example, const get card template equals card arrow and backtick, and well, there you have the same UL and list item, but instead of this card, you can just write a parentheses, an object, front side and back side, and just delete these things. So if you see this function, and I show you that it works just like the other one by commenting this out. So let's run it. Yeah, it's still working, same way. Now, if you see this function, you know that you have understood the basics of destructuring and also arrow functions. Let's see what's going on, like step by step. So here we have this get card template. Instead of this function keyword, first of all, you can do const get card template equals function card. This is still JavaScript. It's still basic good old JavaScript, because you can place an anonymous function like this in the place of a variable like const or whatever else. Now, with this format, we can very easily change this to an arrow function by removing the function keyword and adding an arrow here. This means the following. Supply this input to the vending machine that's selected, the card, and expect this response, whatever is in the return value. So this is all that you need to understand about this get card template. Input, output. And if you just have a return value, then you can also get rid of the braces and just supply the return value. This is basically a correspondence between the input and the output. So we will use that in React quite often, these arrow functions, because they come with another side effect that I will reveal later. It's called context binding. But we will use this syntax, get used to this. And then there is this topic called destructuring as well. So you have a first card. Just accept it for now, and more details are gonna be in the destructuring video. That if you want to create a variable, so for example, a first card or front side variable, so front side variable, then you can put it inside braces and say, dear JavaScript, please give me the value of the front side from the object that I'm writing on the right. And the object is gonna be first card. There you go. And front side is gonna be 9 times 6. Now let me press up twice, and see, instead of the first card, let me supply something like front side is gonna be AAA and back side BBBB. There you go. And this time let's just get the back side out of it. Back side. And then backside is gonna be BBBB, because we're basically matching this backside with this value, and then we're getting the value, well, this key, and we're getting the value out of it. Technically, whenever you see backside, in reality JavaScript interprets it in a way that you write backside colon backside. This is called property shorthand notation, by the way. Okay, so property shorthand object, property shorthand notation, and then you see the two backsides, the keys, and the values are just matched against each other, and whatever is on the right side, whatever value is there, is evaluated and it's put on the backside. This on the left side. So if you want to get both front side and back side, we can do it no problem. Then front side is this, and back side stays BBBB. So this is what's happening here as well. Instead of the card, we can just add front side and back side like this. And then delete the card dot. Because we refer to values inside an object with dot. It's in the beginning blog post. And well, with destructuring we can just get rid of that and write less. So this is the same. If you don't understand this yet, no problem. In fact, I'm gonna use the easier format for now. So you see that we have one card. Now let's have 3 cards this time. So let's add the second card and the third card. I'm just copy pasting. So second card and third card. And we have const cards equals and an array notation with brackets, and first card, second card, third card. And we would like to create all the cards, the markup belonging to all the cards. We can very easily do that actually. So we can just do get card template, first card, second card, third card, and we will have 3 unordered lists like this. So we'll have to add console.log inside, and well, we'll need to add the same console log to the second one and to the third one as well. And now we're gonna get the result like this. So let's run this, and you can see the result here, of course. First, second, third, and obviously you can add the other values. So this is 256, and you have rabbit times 8, and then you have the rab byte, because 1 byte is 8 bits, so I think it works for rabbits too. So now we managed to generate the templates. This is good, but it's not enough, because we never know if we only have 3 cards or 100. And if you have 100 cards, or if you don't know how many cards you have, you're not gonna write 100 lines of code here. That's why we have the iteration, the loops, and also the mapping. So that's what we're gonna continue with. Let's continue with the markup. So as you can see, we already generated 3 unordered lists, and now we have these cards here, and we're gonna now check how to deal with them in an array format. So we don't really want to have this first card, second card, third card after each other. We could also do the following. We could create a loop, a simple loop. So for example, for let card of cards. So like this, card of cards. This for of loop basically gives you everything, every single card from the cards list, one by one. And with these cards, you're gonna be able to print them, you're gonna be able to create call functions and so on. So here we'll just write console.log and get card template and card. So basically that's it. I added some more space here so that you can see what's called where and so on. So you can see that instead of these 3 lines that are gonna be deleted, you can just use an iteration. And then if you run this, then you can see the result, the same 3 card appears. So for example, if we duplicated the third card, so if we add it twice and we run it again, then we would not have to change anything else, and then the 4 items would appear. Great. So now we managed to solve this in a loop format. But this is not how we usually render things in React. Usually what we do is we assemble one element or one component. This works in a way, I'm going to illustrate it with strings. So this works in a way that we have initially an empty component. So for example, let markup. So markup, it's like this code that you can see on the right. This is HTML. equals empty string. And whenever we run this iteration for the cards, so whenever we get a card from the card list, we add markup plus equals this get card template. So it's like we add this get card template to the end of the markup. And then at the end, we just console log the markup. And that's it. There will be slight changes because instead of the 2 lines, you will see a bit less, most likely. Yeah, that's it. We only have 1 line now because the console log would insert a new line character anyway at the end. So that's the only difference, but besides that, there is not much that's changing. So let's continue. There is another operation that could completely erase these new line characters, by the way. It is called trim. So if I added the get card template dot trim, it would remove all the new line characters and spaces from the beginning and from the end of the template. So it would remove this part and it would remove this part as well. So we could call the trim and then we would make things more compact. In fact, we could call this trim elsewhere as well. We could call this trim just after the string too, because this can also be called on strings. You see? Same solution. So whenever you want to get rid of these spaces or you want to control spaces, don't forget to use the trim. Alright, so we have the card of cards, markup, and so on. We have another solution, and this is a more common type of solution. So we have markup as an empty array, and instead of adding this to the string, we can just add it to the end of the array. So if we added markup.push, we will do exactly that. So this is markup.push, and now we would have an array instead of a string. So you can see that this is now an array. This is why the brackets are here. And well, we have these new line characters and unordered list and so on. So it's printed in a bit different way because of the way how this right hand side displays strings. But you can see the array. This is here the first element of the array with the front side, back side. There is a comma, and then this is the second element of the array, and so on. So don't get discouraged that you see this result here. It's just that REPL.it has a hard time displaying these values. I'll show you some proof that actually it's easier to display it in other ways, because you can also run JavaScript and the Chrome Developer Tools console. So you open, right click and inspect on the page, and then you will open the Chrome Developer Tools. Normally it will show at the bottom for you and it will look white. It will also be somewhat smaller like this. Now, if you add all the code in here with the markup, then you will see the results. Like, this is the first value, this is the second, and this is the third. And here you see it in a slightly different way. So you see that you can just take JavaScript code from one place to another, and you can display the solution elsewhere too. Alright. Now, arrays are displayed like this. You can also join these markup elements. So if you add markup.join and, for example, an empty string, let's see what happens. So imagine that you have, for example, 1, 2, and 5, and you add the join afterwards. Then you see that the 1, 2, 5 are joined together as one string. So this is what's gonna happen in JavaScript, and then we get our templates back. So this is how we usually render templates in React as well, except that we're not working with strings, but we're working with React elements. So this is the main different thing with respect to what we're doing here. Now, we're still not done because it's markup and push and join and so on. There is a typical JavaScript way of doing this. And this way is the mapping. So imagine that you have the same 1, 2, 5 array that you can see on the right. And if we map the elements inside the 1, 2, 5 array with, let's say, x to x plus 1, then what's gonna happen in reality is that we're gonna run this x plus 1 function. So the input is, if the input is x, then the output is x plus 1. We're gonna run this function on each and every element of the array, and the result is gonna be 2, 3, and 6. So it's still gonna be an array, but we're just gonna transform each and every element. And we can also use this to create a template literal like this, that for example we have a list item and we place the element inside, so x, and then we place a slash list item, there you go. And then we would have 3 list items inside. And after the mapping we can obviously join. So this is the way how React normally works. So we have some data in the form of an array of objects. We map them to some markup, some React markup, or here HTML markup, and then we join them in the place where we display this HTML. So let's rewrite this with this mapping. And if it's hard for you, just repeat this part and well, experiment a bit more with mapping, because this will come back in the React course as well. We're creating a template that we're gonna use later. So let markup equals empty string, and the for loop, we're gonna rewrite this because we already have the cards. So if we have the cards and the get card template, then it's gonna be very simple, because we have the cards here. You can just write cards.map, and all we need is, if we have a card, then just return this value here, and then we're done. So this is all we need for the markup, and at the end we might decide on joining. So here I'm gonna also add the let markup equals to the beginning of this, and with this we would not even need this function technically. So you see that after running this, it's still working in the same way, it's still the same thing. And it works even without this function. So you see that it works without the function. But don't get me wrong, this function is still important, this getCard template. Because what you see here is exactly the definition of the getCard template function. So if I rewrote it as const getCard template, so const getCard template here equals function and card, then what you see on the right hand side is the same thing as this thing. Because instead of this we could have written just function card and remove this, open a brace, and just write return, and then return the return value, and afterwards close the brace and close everything else. So here you have a full-fledged function. So you have the return value. Here we forgot this parentheses, but they are not mandatory anyway, they are just there. And now you can see that we're talking about the exact same function. So this function card here, until here, is the same as this. So then, if these functions are the same, why not just use this getCard template name? Because if there is an equation sign in between them, whatever is on the right hand side can be substituted or referred to as what you see on the left hand side. So we'll substitute this whole thing by just the name getCard template, and there you go, you're done. Let markup equals cards.map getCard template. And getCard template just takes care of consuming the card and returning the markup. So if If you prefer, we could write it like this too. We don't have to, but we can. And then we get the same result again. There you go. But we don't have to, because the getCard template already has this value inside. So it expects a card. So we just supply it the card and get the markup back for each and every value. So now it's a bit easier. I will do one more modification, because it's kind of weird to have this first card, second card, third card named. Like, there is no point in that. Normally we just enumerate. So this is the first element, we place a comma afterwards. This is the second element. Then we place a comma. By the way, you can press tab and shift tab to move left and right, indentation wise. So formatting options are quite forgiving when you copy and paste. And now we have the third element as well. And we can delete this first card, second card, third card from here and here as well. So this card's data structure is an array of objects. This is the array and these are the objects. And then we create a getCardTemplate function that returns these backticks. Then we have a markup that maps the getCardTemplate, and then we join the values like this. Technically the join can also be here, and then it would be even cleaner, because we can console log and we can do other things as well. Now you see that these are the unordered lists and list items. If you right click and copy, then we can just go to code pen as well. You see that here is an empty pen. I'm just gonna reload the pen because it seems like it didn't really survive the last couple of minutes of recording. So once I add some HTML like this, and once it builds, then you can see front side 9x6, back side 54. Same thing with the second one, same thing with the third one. So this markup is HTML, so it's a valid HTML. We could do some other things, of course. So for example, adding some style sheets, like for ULs, border, 1 pixel, solid red. Let's do that. And then you see that there is some border around it. Actually, black would make more sense. But the issue is that this border takes up the whole line, so this doesn't really make sense. So we could do something like display inline block. Let's see what it looks like. Now we have three separate cards, with the front side and the back side on the front side right now, but this might change a bit later. So now we did quite a lot of things. I would like to generate this code though from JavaScript, because this is what JavaScript usually does. And then the next step is gonna be, by the way, then we'll switch from the JavaScript review, so JavaScript review is about to end. Then the next part is gonna be getting to know what React markup looks like. So we will learn the basics of JSX, the extended JavaScript syntax that allows you to describe React components, and then we will change this markup to React components straight up. And we will use this markup, of course, to build our application. So let's do that. The first step is that we're gonna just copy with Ctrl-C in Windows, Command-C on Mac, and paste with Ctrl-V on Windows and Command-V on Mac. And then we have the markup. If you open this console, you can see that something is printed to the console, so this markup is there. But let's not just rely on the console. We would like to do the following. There should be some container in the markup. Each time you build a React application, you can do something like div class equals js-root and then /div. You know, in HTML, divs are basically meaningless containers. So this is gonna be the container where all the React magic is gonna happen in your document. We're calling this root because this is the root of the document. It's like the top level elements in the document. Now that we have the root, this JS root on the left, we can just do some JavaScript magic to start rendering something. So we have to write document. On the right you see we're writing JavaScript, in the middle we're writing CSS, on the left we're writing HTML. This is the difference. CSS is for styling, it's like the decoration. HTML is for the structure of the document, so it's like what kind of content we have, but it doesn't really take care of the styling. At least it shouldn't. And JavaScript is for dynamic functionality. So these are the three different elements that we learn usually. And React is an extension of JavaScript for the purpose of creating web applications and components and so on. So here we have the div, JS root, that's the root element. We have to select it somehow. If we write document.query selector, then it selects the first element that has the selector .js-root. So this just selects this div that we can see on screen. Actually, not only just the first one, but also the only one, because you don't have other JS root elements. So after this document query selector, we can write, in fact I'm gonna place it here, we can write .inner HTML equals, and then we'll just set it to the markup. That's all. And let's see the magic happen. There you go, we got the cards back. So we managed to generate some proper valid HTML with these get card templates. See, there is the get card templates here, the markup, the document, the everything else. And if I change this from 9 times 6 to 9 times 8 and 72, like this, then it changes quite soon. Yeah, now the backside is 72 as well. So it changes dynamically based on what data we get in the cards array. So this is kind of cool, because now we can not just hard code our data in the code, but we can also approach some online server and get some pairs of words or questions answers, like question database, and put it on our cards. Just saying. So there are quite a lot of different options now. So we have this covered, and if you know just this and nothing more, then you can already get started with JavaScript. So the next step to understand is just the basics of React, how React components are written. You know, React is this very interesting beast that has its own syntax, because there we don't deal with just these unordered lists, list items and so on, but we can start writing some other things as well. And for that, as an illustration, we can just go to babel.js.io, and here we have the try it out. babel.js.io/REPL. REPL, it's like read, eval, print loop. And here you can see that given that in class, in another class, I demonstrated the basics of React not too long ago, I still have something in here. So let me just delete this part. And let me introduce this import-export syntax to you first. So we have this import React from React and import React DOM from React DOM. These things are basically the React library and React DOM library accessed in your source code. So from now on, you can write things like react.createElement, and then inside you can just create an element that is, for example, a div that has no attributes and there is nothing inside it. So this is just an empty div. And you can see that this code on the left is translated to React default create element div. We could just do something like hello React, for example. And we can also render this. So if we added another CodePen, actually I'm gonna do exactly that. So CodePen.io. we're gonna go to codepen.io and we will just run this so that you see that React is working. In order to experiment with React in CodePen, you have to enable it. So super important, on the top right you have this window. I'll make this a bit smaller, the CodePen window. You have to select Babel as the JavaScript preprocessor. This is why we went to babel.js.io for demoing, by the way. And then you have to add React, and then you have to add react-dom. You see that at the time of recording, the current version of 6 is 16.13.1. You may have version 17 by the time you watch it, or even later. It doesn't matter because React is doing a very good job at being backwards compatible. This means that whatever applied 2, 3, 5 years ago, oftentimes is still available in the newest version. It doesn't hold for everything because, for example, there is this thing called the context API, which is not working anymore in the same way how it was originally intended. But it doesn't really matter. What matters is that the basics and the strongest fundamentals don't change. This is where Angular went really bad, and this is when Angular became really unpopular back in the days, because Angular had a lot of breaking changes, especially between Angular.js version 1 and Angular version 2. And then the industry didn't really know what was going on. Here in React we don't have this problem, and maybe this is the reason why React is the most popular framework right now based on Google Trends data and the state of JS data, and every survey I have seen says that React is the most popular framework or most popular library overall. It's a debate of how much React is a full-fledged framework or not. Well, let's not get into this topic, because like how much React helps you basically write the code, or how much you help React work out the details, that's another question. So in a framework we have something we call an inversion of control, which means that if React is in control, then it's a framework. If you're in control and you use React features to do something, then it acts as a library. So framework, library, oftentimes it boils down to whether you have a full-fledged state management, and basically you just help React run the code by describing what you need to do in a way that that you don't provide the nitpicky details. So React, let it be a library, let it be a framework, let it be the V in MVC, which is an old, outdated explanation. Doesn't really matter what it is. What matters from our perspective is that we're gonna start experimenting. So in this babel.js.io, I can do this react.createElement. So var first element, actually first element like this, equals react.createElement. And we will not use this react.createElement at all in the future. We're just using it now for illustration purposes. This is the first element. In the real code base, you will have something like import React from React and import React DOM from React DOM. But you don't need this here, because in CodePen we do the same thing here in the imports. So you don't need these things. In fact, you cannot even add these because CodePen doesn't understand this. So let's do the React DOM.render. And here you add your first element like this. And well, it would be very useful to just copy paste the same element that you have here, this JS root, to the HTML, and copy this document.query selector here. So paste. The second argument is where do you want to render this thing. And then after adding all these, you see that at the bottom this hello React appeared. And if you change this div to h1, then you will see that after re-rendering it changes to a heading, the largest possible heading that you can have. So congratulations, if you followed along with me, you have successfully created your first ever React element. But let's go a bit further than that. Because instead of writing this react.create element, which is kind of long and kind of not too user-friendly, React came up with another solution. So this is like var first equals this, var second equals, and then instead of react.create element, I just write h1 hello react exclamation slash h1 semicolon. And let's see the difference between the first and the second. Well, there is a comment. Who cares about the comment? Underscore react.default.create element. Here, same thing. Then we have h1. Okay, I created single quotes. They created double quotes in Babel. It doesn't matter either. It's like preference. So single quotes, double quotes in JavaScript, they both describe strings. Null, null, same thing. And then we have the hello React, and I think I didn't have an exclamation in here. So maybe it's time to change that. Now we have the exclamation here, and we have the exclamation here as well. So essentially, this is the same code as writing this. And this is the key thing to understand about React. So if you're a complete beginner at React, then you might have been surprised if you read React code, for example, in the official documentation or any code snippet, that it looks like writing HTML. But it's not happening. We're not writing HTML in JavaScript. This is not HTML. This is a syntax called JSX, extended JavaScript. And Babel does the job of translating this JSX into valid JavaScript react.create element calls. And this is all we have to do, nothing more. That's all for React. So when you see this, think of it as react.create element calls. And given that the way to describe these elements is kind of ugly as react.create element, React creators allowed us to describe these create elements as h1s. So this is what we're gonna do in the code pen too. So instead of this react.create element, we're gonna just write first element h1, then we add the hello React inside like this, and then slash h1 semicolon. This is the same thing as the react.create element, and we're gonna remove the react.create element. And as you can see, it's working. It's working without any problems. So this is the first element. This is how the first element is working. So this is gonna be just the heading. So this is the heading. Let's create our card template as well. And now I'm gonna copy paste this unordered list because this is basically valid React. So I'm gonna just take a card, any of the cards, for example the first one. So I'm gonna add this card equals, and then this value, whatever it is. So I'm gonna do the indentation properly, front side and back side. And then we can do something like var card component, or basically this is just a card template. Let's do card template, or rather card data, and then we'll just add card here. And then we're gonna just add the template that's here, this unordered list, but without the backticks. Because if we added backticks, it's just text. Let's try the backticks first and I'll show you what's going on. So card equals this. And then if we added react.dom.render and instead of the heading we added just card, then we would have some problems. Well, first of all, we already have a problem that card, lowercase card is not defined because it's not card but card data now. So we're referencing the front side and the back side of card data. But then if we added this card as a string, then you can see that the markup itself is rendered as a string because this is not React. This is just a JavaScript string. React doesn't do anything with strings, they are just elements. So if we remove these backticks and we replace them by parentheses like this, then you will see the magic happen, the front side and the back side. And so that the display will be uniform, I'll just reuse these UL styles here as well, so that you're gonna get your border around it and so on. So now we got a card and we successfully created it using React. This is an accomplishment because this is a full-fledged React implementation. So you have a heading and you have a card. Now comes the question, how can we render both the heading and the card? So is it an array? Is it something else? So let's try an array, for example. If we added an array, for example, heading and comma card, then you will see the result that both of them got rendered, both the hello React and the other one. This is something nice about React, that whenever you have multiple elements, then they render these multiple elements quite well. But this is not how React was intended to be used. So this is not the way to use React DOM rendering, but it's rather creating first the whole markup, like everything, and then rendering it at once. Because this card, it's like a component. And this card has some data. This data have front side and back side. So let's see what to do. So how to render these elements. What we would like to achieve is to use these elements, so this card and heading and so on, as simple React components. So for example, if we have a heading, we would like to use this heading like this, as if it was a React component. So right now it's not working because this heading doesn't act as a component. This is not a React component. This is just something that this is just a string. The heading is basically just a string. So instead of this, we can make the heading a component if we make it a function. So function, and this function will return this JSX. And now you see that the hello React came back. So now we can create the heading. And in fact, there is an interesting feature of these internal components, because if we wanted to supply the title, title equals new title, then we can just place this inside the argument. So we have props inside. So these are props or properties. And instead of these hello React, you remember the template literals in JavaScript? They look like this, but then we had to have backticks as well. So I'll show you. These are the backticks. But then remember that we're doing strings this way. So props dot what was it, title? Yeah, it was title. Props dot title. If you use props dot title, then we would return this h1 new title slash h1. So this would be just text. But if you remove the backticks, so this is not a string anymore, but JSX, extended JavaScript, then you see that we don't need the dollar anymore. So we can just get rid of it because it just displayed as text. And whatever is inside, in the braces, it's the new title. So inside the props, you can access all these keys and all these values, the title and the new title, both of them, key value. So this is how you pass parameters to components. And if you had the good or bad idea, I'm not even exactly sure if it's a good idea or bad idea to have multiple heading ones. Actually, it's a bad idea because by default you have one main title. Then you could even create multiple headings. So you can render multiple things here. We can do, for example, var markup equals, and then we will do our experimentation here. So we're gonna just render the markup, and we will write our JSX here. So heading, title, and new title. For the sake of experimentation, let's just render another heading. And let's see what kind of error message we're gonna get. So it's trying to do something, and you see that nothing is happening. But the error message is not there in CodePen, unfortunately. So the real problem is that in our markup, we can just have one element and not two. So here, the problem is that we're trying to render two elements at once. This cannot happen. In React, we need to add a wrapping element, for example a div, to be able to render two components at once, because on top level we have to have exactly one element that we render. React DOM can only render one element. It's like, remember, we're inserting something inside the div, and this div can just have one element. It can only contain one and not two and not three. If we added these headings like this in arrays with commas like this, then React would be able to render it. So after waiting a bit, you see that it's rendered. But the proper way of doing this in React is keeping the regular parentheses. The reason why we have the parentheses is that we can start another title in a new line. And if we don't have a comma like this, then we have to add a wrapping element. And this wrapping element is a div and a slash div. And then we have the two titles. You might wonder why it worked with the comma, that new title 2 got executed. It's like, if you add the comma, then it's like you render either the first one or the second one. It's some sort of a JavaScript expression where the first element was thrown away in the original implementation. So don't worry about that. It was basically some glitch that you don't need to focus on. What you need to focus on is that whenever you do this react dom.render, you need to create a markup in JSX. So why not rename this to JSX markup even? So JSX markup, to illustrate that we're talking about JSX code. So this is what you need to make sure that it happens, that we have just one element on top level, and this document.query selector, so that you have a div where you can render everything. So this is a very common problem, that you want to render multiple things and you only have space for one. And for this reason, instead of the div in React, we have these empty elements. These are called React fragments, by the way. And you see that it still works like this. And this is the first realization that, oops, we're not writing just HTML. It looks very much like HTML, but it's not full-fledged HTML. And by the way, for all the React versions, I think you have to write react.fragment like this. So it would work like this as well. And this is basically a React fragment that doesn't create a node in the document. So if we inspect the markup, we can do this quite easily. You see that the two H1s are right inside this JS root that was in the HTML. But if we had a div inside the JS markup and we rendered it, then as soon as we check the markup rendered, then you would see that there is a div inserted. So there you go, you have the JS root, and then you have an unnecessary div. This is not a problem technically in most cases, But if your React element was a list item, for example, and the container was an unordered list, then it would be a problem. I'll show you why. So here, instead of the div, you could just have an unordered list. See, it's kind of convenient that whenever you type something here, it auto replaces the closing tag too. So imagine that this JS root is an unordered list, and your heading is not an h1 but a list item. Then you simply cannot afford to have an extra div based on valid HTML structure. So you see that inside the UL, you should have a list item and not a div. So this is when this React fragment comes into play. Because then you delete this, you symbolize that yes, we still just render one React element, don't worry about this, and the markup is gonna work, it's gonna be valid HTML. Because inside the unordered list, you see that a list item is created. So that's why this React fragment looks really good in React. But let's go back to the divs. So we're going back to div and h1, for example. Now, this is great that we have these titles and we can render two titles. Instead of the two titles, we could just have one title. So, for example, carts as a heading. And we could just add this cart, so the cart component, whatever is inside the cart. Now, this is still a string, a simple string. So we could just add the cart string, and then you see that it renders actually the front side and the back side. Because this cart is also some JSX that is rendered. Var cart equals and some JSX is in here. But this is not the way how React should work. React should work in a way that this cart should also be a component. So we have a function and props. And inside here, I'll change these to braces. And I'm gonna add a return value and add the parentheses so that we can write proper JSX. There you go. So now we have the cards as title, and instead of the card, this is not a string anymore, but a React component. And this is how we should use React normally. That we can have components inside components, and if we wanted to render this card like 5 times, then second, third, fourth, fifth, and now we have 5 cards. It's that easy. So this is the nature of React, that we can have components, and these components can appear anywhere in the markup. Alright, you can see that there is some level of nesting in here. So let's see what's going on with these react.create elements. So I didn't tell you the full story about this react.create element because technically you don't even need it. Now is the time to discover what these values are. So if we have a react.create element like this, then you can also add some more things in here. So we don't have to just have hello React. We could also have multiple. So we could have like hello comma, and we could have React here and some other things, and it will work. And it could also work in a way that we have an unordered list, and inside the unordered list we could have well, a first item and a second item and a third item, even if you wanted to. Third item. So this is gonna be a UL, an unordered list. So in the react.create element, we have first the tag name, second the prop names, and third a variable number of children. So these children go inside the unordered list. And now let's add the items. So var first item equals react.create element list item null first. And then we're gonna do the same with the second and the third item. So second item and third item. And of course we're gonna distinguish between like first, second, and third, like this. So now we have the React DOM, first, second, third item, the UL, the list item, and so on. And this is also something that that we can use in React. So this is another React element. So UL element is just another React element. And in fact, we can also make this a React component. So if we added, for example, a function triple list, and with React components we always capitalize them. So this is gonna be our function. We're gonna indent these values. We delete, we close it, and we return the UL element. Then this is gonna be a proper React description. You see function triple list, first item, second item, third item, the UL element, and we return it. And this whole thing is basically a React description that we can just insert in our code here, triple list, and instead of the cards, so now we just have one card, we can just write triple list, and it's gonna work with our code. See, first, second, third. This is how React works under the hood. We write these react.create elements and place them inside these other react.create elements as children. And given that the return value is always one react.create element call, this is why we need these fragments or container divs, so that whatever we render can be translated to just one react.create element call. Hopefully this sunk in. If not, no problem. Just remember that if your code is not working, always add this container element, either an empty one, or most of the time a div/div will also do, doesn't matter. So now, getting back to this original example with the triple list, let's just make some changes. So the first item could be just an li, a list item, like this, li, first, /li. Same with the second, li, second, /li. And now let's see the difference. React.create element, li null first, li null second, li null third, same thing. So we can just change these values here as well. Li, third, /li. There you go. 3 create elements. And then we have the ul element, where we have a ul, a null, and these 3 items. So the first one, the second, and the third one. So we insert these 3 elements inside as children. So we would have a ul inside. So if I rewrote this, a ul, a /ul, and inside the ul/ul we can just add first item, second item, and third item, this inserts create element calls. So we have the UL element here. Let's see what it's translated to. UL null, and then we have first item, second item, third item. Same thing. This is a variable list of, or a variable number of arguments that describes the children of the UL element. And now we can just replace this with the first item, the list item, second item too, and third item here. And then we're set. So we don't even need this first, second, and third item, but we can just describe the UL with HTML looking markup. And if we are this far, why introduce the UL element variable? It doesn't even add any value. We could just take the markup and return the markup straight away. And then let React just translate this UL, li, whatever else we have here, to react.createElements. It also adds the default, yes, but it's some React under the hood magic. It doesn't really matter. And then you have the li first, li second, li third as arguments after the outer call. So the React create element, UL, null, and then come the children. First element is here, then comes the second element, then comes the third element. So this is React under the hood. If we added some attributes inside, so for example A1, then let's see what the result is gonna be. Here in the second argument, we create a JavaScript object. And here we have the key A and the value 1. So if we have A1, then we could have B equals 2. And then we add an other property inside. This is the props object. And this props object is here as well, this card. So when you have this card template, when you create this card template, then you can just add the front side and the back side to it. We can do the exact same thing as in React. So technically we could get away without this object, without this card data object. Because when we have this front side and back side, we could just supply this to the card as initial values. Don't get me wrong, oftentimes we need data like this JavaScript object. I'm just illustrating the point that we can have props and we can supply these props inside, like props.frontside and props.backside. And I'm quite certain that there was some sort of a property error inside the cards originally when I first introduced it. So it doesn't really matter because originally the front side, back side was not taken from these props, but they were taken from this card data where you had the front side, back side. Now we're gonna make this card component work because here we have the props front side, back side. If we added a card without any properties, then you will see that front side and the dollar is written in here. It's because we have this dollar here. It doesn't serve any purpose. But if we didn't provide them, then the props.frontside, props.backside would be basically the JavaScript undefined value. So, alright, let's see card frontside, backside. We'll do frontside equals and whatever value we have here, 9 times 8. And backside, this also has to have an equation sign to 72. And then we'll have to wait, so front side equals this 9 times 8. And backside equals this 72. I'll just use double quotes because in HTML oftentimes you write that, and I'll remove the comma as well. I think it works with single quotes as well. It should not be a problem. Now you can see that front side and back side was inserted into the template. How did this happen? So we have front side, back side. These appear as props here. So this props is gonna become an object that has a front side key, and the value of that front side key is supplied. It's 9 times 8. And I'll show you how interesting these props are, because you cannot just you can supply strings, no problem, but you can also supply other data. So for example, getting back to Babel, if I wrote b equals and this sign and the 2, then you see that the b here in the translation is gonna be a number 2 and not a string 2 anymore. So the 1 is a string, the 2 is a number. But if I wrote, for example, 2 times 2, then you see that the value supplied is gonna be 2 times 2, which is a JavaScript expression, and its value is gonna be evaluated to 4. So let's see, instead of the 72, I'll just write the answer of 9 times 8. And it should be calculated, there you go, to 72. I'm not kidding, so if I move this back to 9 times 6, it's gonna be 56. No, 54. Yeah, it's important to be able to do basic math as well. But then we have to do 9 times 6 here as well. So you see that this calculation is done by React automatically. So this way we can specify cards, and this is great because we can have our own properties described in React, whatever it is. So 2 to the power of 8, or let's do 16 this time, so that it's gonna be a larger number. You know, 16.7 million, I think. Yeah, or no, so it's just 65,536. The 16.7 million is 2 to the power of 24, I think, because it's like red, green, blue. And you also have to add 2 to the power of 24. It's like 8 bits for red, 8 bits for green, 8 bits for blue. It's like 24 bits. And this is equal to approximately 16.7 million different colors whenever you write different colors in CSS. So this is basically a very good flashcard question and answer. So you see, like, what is 2 to the power of 24? Well, it's approximately 16.7 million. For coders, front-end developers, this number makes sense. I'm referring to this, you know, notation, background, color, and then you have RGB. And if you write 255, 255, 255, then it's gonna be white. And you can modify each component in any way between 0 and 255. And this can be done by giving 8 bits, so 256 values here, 256 values here, 256 values here. But this should go to the li and not to the ul. So it's gonna be here, background color, RGB, and whatever is inside. Actually, this should go to the ul, but something is preventing the colors from showing up. So background, color, hash mark, CCC, for example, or C0, C0, C0. Now it's working. It seems like this RGB, I made a mistake or something, most likely. So RGB can also be used. For some reason here in the code pen it didn't work out. Let's also add some padding because it looks ugly. So padding 10 pixels. To the, or actually margin, I wanted to say margin. Some spacing, some space around the lists. Alright, maybe we should have just added the margin on a container or something else, because it's just the right and the left margin that are influenced, or rather the left margin, and they go. So these margins are beyond the borders, and let's say add padding to 10 pixels and list style type none, because then we're gonna remove the dots. So now we just have the front side and the back side as styling. So this is just something really small so that we can add some more styles to the cards so that they look a bit more like cards and a bit less like unordered lists. Alright, so we managed to understand quite a lot from React. So now we can render basic cards, we can supply properties, and we can also nest things. So let me clean up the code a bit because we don't need this triple list anymore. We just have the JSX markup that we render with react dom.render inside this. So the next job that we would have is to go back to the other code pen and let's just re-render the same thing as what we had in the other code pen by using the cards data. So this is still an introduction to React. I will copy these things over so that the cards look a bit more like what you had in the other one. And now instead of the get card template, we'll use this as a practice to create React components. Alright. So we have this document.querySelector.js root. First of all, we need to enable React. So we add React here, also react-dom, and we select Babel as our JavaScript preprocessor. This JavaScript preprocessor just changes this to this so that the browser can understand what we are doing. So now we have the cards and the get card template. And this is gonna be the interesting part. We have to do just fairly minimal changes to make this work. So get card template is already a React component, more or less. We just change the name to card. And well, we can remove the template literals. We can remove the dollars because here in React we just add these JavaScript expressions inside braces. And now that we have these card components, we can leave this unchanged basically. We don't need this joining because we'll just have a list of React components, but we can leave this mapping unchanged more or less. So instead of cards, I'll just add card data. So card data, and we can just write card data and card data like this. And then we're set. Now you see that we already have 3 objects appearing. In fact, we can just supply this card. I'll soon show you. I don't want to do a lot of steps at once. Just bear in mind that we created this card function. So we renamed this card function because originally it was get card template, right? And here we just supplied get card template as a function. So for the sake of the explanation, let's just keep this get card template. This was the original one. And this time we're returning JSX, this React type of solution. Now, the markup can be rendered, but not with inner HTML, but with React DOM. So we have to do React DOM.render. We have the markup here, and we just need this document.querySelector here. Done. And there you go. After the changes, you have the three components. So all we did, we took this get card template, we removed the backticks from here, because if we had backticks, you know, like not here but here, if we had the backticks, then we would have an issue. So the issue would be that we would just render text, and this text is not too welcome. So we remove the backticks, we return proper JSX, and then this markup equals card.map or carddata.map didn't really change at all. So you see that the three cards are rendered without any problems. Front side, back side, everything is properly rendered. The only change that I would propose, and I already started changing this, is that this is basically a React component. So once again, you have a function, you have some props, and with the proper naming, it would work like, we can just name this as an uppercase card component. And instead of the get card template, we can just use card. So it's like card data, map the data to actual card components. Or if you want to make it clear, you can just write props, card, props. This creates a card. But we can also write it in a different way. And I'm gonna show you that. So first of all, we have a card component like this here, but this doesn't add the questions and answers. We can just supply all the props as a JavaScript expression if you know how to do the spread operator, props. This would create the keys and the values and everything else. It's kind of a cool feature. So this is something you see in React code quite often. So this way we have the card. If this is confusing, then don't write this. Just accept that if you supply card, then it will just refer to this function that creates the React component. You put the props in, and then you return some JSX. That is just a sequence of react.createElement calls nested. Let's still change the card here to props, and props, and props here. So now I think that we got the basics done. We almost got the basics done actually, because we just have some very, very small nuances that we need. Because these props cannot contain any keys. So there are some keys that are reserved JavaScript keywords. If you check, I will start typing some JavaScript keywords. I'll break the code too, but it doesn't matter. If, while, do, for, class, and whatever else you could think of, in, and so on. So whatever you see as yellow here, they count as JavaScript keywords. And well, at least on line 16, because card doesn't count as a JavaScript keyword. It's just CodePen highlights it that way. The problem is that with props, we describe them as attributes. There is a for attribute in labels, and there is a class attribute whenever we add the class name, for example here. So we cannot do this, that we copy this class and we paste it somewhere inside, for example here. Because this class is a reserved keyword in JavaScript. Notice that this class is gonna become, so if I added class, it's gonna become a class key here, and this is not fine because it's a reserved keyword. So in React, whenever you wanted to add the class, you have to add class name. And whenever you wanted to add for, you have to add HTML4 with capital F. Okay? So this is the only main change that you need to take care of whenever describing JSX. So it's very important to note that you have these small changes. So instead of class, you have class name. And if you add the label, for example in a for, then you have to have HTML4 and whatever, like username or something. And then it would work. So this is the essence of reserved keyword, that you cannot just use a reserved keyword at once. You have to do something with it and use this HTML for this label. And let's add the label here. So username, for example, if it was a form. In fact, let's put it elsewhere because it's kind of disturbing. You could also add this here somewhere, like after the markup, or inside as another list item. Username and input type equals text, ID equals username, and /li. So this, and also class name equals space. For example, I'll add some space around the class name quite soon. So we have this third list item and we want to render the solution. So we have a username. You could have some colon inside the list item. We have some input field, and this is one of our list items and also closed. Now you can see that in each and every card we have a username, and when we click on the username, then we also go to the element. Now this is wrong actually, because the ID cannot be the same. So it just cannot be the same for each and every item. So for this reason, we oftentimes do something unique for both the for attribute and the ID. We can just add the props.backside here for distinguishing between the IDs, assuming that the answers are unique. So props.backside. So when we have the front side, you see that when we click here, the input field is focused, and then so we have username, and we could just supply this this props.backside in here as the value of the ID. So instead of the username, we just supply the props.backside, and then when we click here, here, and here, you see that the focus is working because this props.backside connects the for attribute and the ID are connected in HTML this way. So it's kind of a hack, but it's still working. All right, let's test the class. So we have this space class. If we add the dot space and padding 10 pixels, you see that there is more space around this. So in translation, the HTML4 will become a 4. You can see it here. Label 4 equals 72 and ID equals 72 as well. And the class name became a class in the insertion. So this is just something small so that you remember that you cannot just write class and cannot just write for, because for is a reserved keyword for loops, and class is a reserved keyword for classes, which you will use quite soon in components as well. So we have class name HTML4. We'll just delete this list item because you don't need it anymore. So we're basically almost done. Almost done. Let's just render these different cards. So we technically don't need this markup here. We could also add some heading. So for example, we can display these cards here, and we can just and it just works like this. So now that we have managed to clean up the code a bit, we have managed to learn quite a lot about the basics of React. So you see that we have these small functional components here, like card, and these cards can transform this data to working markup. And now you know how React works under the hood as well, that these are basically react.createElement calls. And with that, we have learned the basics of React, so it may be the proper time to just start coding in Visual Studio Code. We have successfully experimented with the basics of React already. So this means that you can now create React at least functional components. We will talk about class-based components a bit later. And you can also compose components and render components in the DOM. So I think that we know enough, like just enough, to be able to start writing some basic React code. And usually React development doesn't happen in codesandbox.io or in CodePen. So these two tools are mainly for experimentation. The real deal happens in your integrated development environment or in your code editor, depending on like what you prefer. Most people prefer Visual Studio Code according to many surveys. So if you go to Google Trends, if you go to State of JS 2019 or 20, I'm not sure exactly which is the latest, but consistently Visual Studio Code ranks the highest as the best code editor that software developers tend to use. So we have this IDE set up, and you see that whenever you get started with Visual Studio Code, then you have all these like show all commands, go to file, find in files, and so on. The most important thing that we need is the terminal. So at the bottom you have this toggle terminal that you just press, and then you can select the terminal that you would like to use. Here we're using this terminal called git bash. If you would like to know more about this terminal, I have actually a video on YouTube where you can check out how to set yourself up with this and also how to do GitHub with Visual Studio Code. So it's a 2-hour long course. So Git and GitHub 2-hour course and portfolio site. The thumbnail might have changed, but at least you know that it's this video. You click it and you check it out at the beginning. How Visual Studio Code was set up with git bash. So on Windows it's straightforward, because that's where you have the git bash. On Linux and Mac it's a bit different because you have a good enough terminal anyway. So if you're a Linux user or a Mac user, you just use the simple terminal, and more or less we're gonna do the same things. So let's open the terminal with Control and this apostrophe. The key combination might change for you, so it depends on what computer you have. And there you go. At the bottom you see this terminal. So once again, if you don't understand this git bash, so gitforwindows.org, then go to my other video where you see Git and GitHub in 2 hours. If you use Mac or Linux, then you have a similar terminal anyway, and it will just be the default terminal that you see. For Windows, you might need to change the default shell, like you have this select default shell, and you see that I have 4 shells: command prompt PowerShell, this WSL bash, and git bash. So I'm using right now the git bash, so this bash.exe, and this is basically the shell that works for me the best because it's a bit like Linux, a bit like Mac. Alright, so we have the create React app setup that we need to do, because basically what create React app does is that it abstracts everything from us. We don't have to take care of the application setup, you just take a command and that's it. So that you can install create React app properly, you have to install Node.js and npm. So that's gonna be important. Check out Node.js and npm. So you go to nodejs.org first. So let's see, you go to Node and download whatever you need to download in there based on your operating system. So the LTS is gonna be good, and then you also need to install and or update npm. So that's gonna be straightforward installation, so you might have done many installations before. So after you're done, the next thing is, if you have to install in Node, which I don't, because you know, I have Node version 12.16.1. In fact, I have a very recent Node. But then you would have to type either sudo or not sudo. It's up to your system. npm install global node. And N stands for node, G stands for or global. So that's what you would have to do. I don't, because I have Node installed. And then installing npm install -g npm. That would be the next thing. And then comes the create React app setup. So to set up create React app, it's relatively straightforward because it's on Facebook's site. You have all the instructions on create React apps GitHub. So this is the create React app project, or you go to createreactapp.dev, so create-react-app.dev, and there you can see everything, even the get started and setup. So the reason why you need a relatively late npm is this npx command, which can execute an npm package remotely. And this means that we don't have to download the create React app, we can just generate an application without doing anything with the package itself. Earlier we had to download this create React app package. So we're gonna now enter this npx create React app, and we'll call it a name. So npx create React app, and instead of my app, I'll just add the cards. Let's do cards. This is gonna be the name of the application, and that's all we need to add. It will take minutes once again, so sometimes it's 10 minutes, sometimes it's 2-3 minutes. It depends on your computer, the network, and so on. So you see it's fetching things, and it's gonna operate for a while like this. So I'm gonna just stop the video now and come back to you once the installation is finished. Now the installation is complete. It took really a lot of time. So, you know, during a recording like this, you see all these things were going on. So we added some things, resolving packages, fetching packages. Then there were all these packages installed in 475 seconds and a bit more. And then there were some more packages installed and so on. So you see, it's really a lengthy process, but once you get started with it, create React app comes with a lot of benefits that are worth exploring. So you see that this cards app got created, and this cards app, you already have a readme file. This is a default readme file on how to start the application. You see that you have quite a few different options. So you have yarn start, yarn test, yarn build, and yarn eject. Don't use the eject because it would just detach your application from the create React app ecosystem. So you should just operate with the start, test, and build, and that should be enough, at least for now. So if you check out the documentation of create React app, you can see a lot of different good advice. So this is create React app here. You see the installation, you see the dev dependencies, everything else, how easy it is to maintain, and how easy it is to use. So you just go to the get started, and then all we need afterwards is to move into this app folder that we just created and type npm start. So this is exactly what I'm gonna do. So cd stands for change directory, cards. We're inside the cards. You see this master. If you check my GitHub video, GitHub video, then you know that this is a branch. So this is the master branch. So we even have a git. So we are on branch master. You see there are no changes to be committed and so on. So we have this cards app on Git right now. But now we're gonna do npm start. This is an npm script. that Create React App comes with, and you will see that we already have a React app running in the background once it gets started, and it basically installs this app.js, and it also gives you an index.html. So you have an index.html in the public folder somewhere, or it's being prepared. Yeah, it's here, index.html in the public folder. And inside the index.html, if you go to the body, you see this div id equals root. That looks familiar actually, because if you remember in codesandbox.io, we had the exact same structure. In fact, when you develop in Code Sandbox, it uses a create React app application more or less. So you have the same app.js structure, the same index.html structure. So for experimentation, it's not a bad idea to use Code Sandbox. Obviously, with Create React App, it's a bit more complex because you have some local Create React App styles like this applink, react.js org, and so on. This might be unique to Create React App. But anyway, you see that npm start here, cards version 0.1, it's starting, and Create React App comes with a development server as well. And this development server is kind of interesting because if you check, I'll keep this this development server running on the top right, and I'll start experimenting with the code. So it's gonna start quite soon, and afterwards, if I change anything in the code and save the changes, it will automatically reload in the browser as well. So you can now see that the application got loaded. We have the React logo, edit source / app.js, and save to reload. So it's even gamified on some level because it tells us exactly what to do. So let's see this edit, this app.js. We'll have, for example, cards app. So I'm saving this to see what happens. So I save the changes. I'm doing nothing. You see that some things are happening in the background, and there you go, cards app. It changed almost instantly. Of course, you can change the logo. You can change anything you want inside. So now this is the app. We can have a look at our applications. So here we have codesandbox.io, and if you check out codesandbox.io, basically here we also have this app.js. It's the same structure in source, and here we have the app that we developed, and this app.js goes to an index.js this time, where we import the app and render the app in here. And there is a public folder, just like in Create React App, which has an index.html. So it basically imitates the structure of Create React App. Here you have a div id equals root at the bottom on line 30, and the rest is basically the same. So it's a very similar type of structure. So this is why it's gonna be already familiar to you if you check the first part of this tutorial. Alright, getting back to the application, so now we have the app, and our next task is gonna be just to provide the CSS and JavaScript that we already wrote. So if you remember, after this app logo, basically we can add our own styles for the cards, for the flashcards. And I can simply pull it in from the other screen. So this was in our code originally, this unordered list and this space for the CSS. And for the JavaScript file, we had a component. So we also had this app.js. Here I'm moving it here. So remember, we had this card data, and we had the card component, and we have the React DOM.render to render these cards. So now we're not going to use the React DOM.render because we already have a renderer in this Create React App, because here we have the app.js and the index.js as well. Now inside you see the same thing, react.strict mode, and inside that we have the app. The React DOM.render is happening here. React.strict mode basically gives you more error messages and a more strict way of development than without strict mode. So this is something very good for development purposes. Now we still have our code, and we need to create a file inside source, which is gonna be called, so new file, it's gonna be called card.js. We can put it here, or we can also put the card.js inside a folder called components. Because what is card.js? It's a component. And we can even separate them by a folder. So for example, card, there you go. And then inside components.card, we can just move card.js. And after the move, we can just paste the data and everything else that we had originally. So you have the card data here and the card component here. All right, so we have this card component already established. Now we need to use the module syntax of ES6 to make this work and include it in the app. So we have export default card. We need to write export default card in here to make it work and save. There is one more thing, which is you see this UL and dot space, these CSS. Given that now we are working with a larger scale React application, we need to work on this. So instead of adding it to the app.css, I would highly recommend adding it to the card style. So inside the card, we can create a new file, and it's going to be card.css. So these are the styles belonging to just the card. And instead of the unordered list, style, we could just add the class equals card. So this is the style that we're gonna use in the card.css. Instead of ul, we'll just write .card. Because this way, if you have another unordered list in the application, these styles won't interfere with other things. Okay, I might also need to press Shift Tab to indent properly, and now Tab, because this style is inside, so the indentation level is good, but the close braces should be here, just aligned with the selector. Okay, now we have the card and the styles. The styles have to be imported though, and this is the beauty of the ES6 module syntax. With Babel, you can import CSS /card.css. You can do that without a problem, and then it's gonna be a part of the JavaScript bundle. This is how our Babel is set up under the hood. So it's not something that you have to configure. It's already given to you via the Create React app. Create React app is therefore amazing. It does a lot of things for us. Configuring all these things is possible. It will just take a lot of time and effort, and sometimes even research. Maybe I'll create another video on manually configuring either a Bootstrap app or a React app. That might be helpful. So you see that now we have this card bundle. So in order to make this work in some way, we might need to go back to app.js, and here, similarly to these imports, where you see that we imported SVGs, which is basically the React logo. You can import images, you can import apps, and we imported the React. We can also import components. So here we say import, and we need to add the path to the React component. So ./components/card/card. And we don't have to add the extension. By default, it's just a .js file. Let's see, there is a problem. React must be in scope when using JSX. Yes, exactly. The problem here is that we didn't import React in card.js. And look at this here. The same errors showed up. Failed to compile, and then you have the error here. This is why React is very user-friendly when it comes to, or very developer-friendly when it comes to making changes. So here, before this import card CSS, I can also add import React from React. That's it. So you see that the errors are gone and the cards are here. But in reality, nothing happened in the app, because even though we imported the card component, we haven't instantiated it in any ways. And this is because we haven't used this data to create real cards. So I'm gonna move this card data. We don't really need this card data here. And I'm gonna move this to somewhere else in the app where we're gonna just set things up. So app.js, before the function app, I will just add these card data. And if you remember, we had this react.dom.render card data.map card. So this was basically what helped us render the 3 cards, because we had the card data and we mapped it with the card constructor. Let's see if this is working here. So below the learned React, or instead of the learned React, I'm just gonna delete this. So you see that the learned React link is gone. We just have the cards app. So now here we can just create an expression with these braces, just like this logo, and we can paste this card data.map card. Now failed to load because card is not defined. Here we need to specify what we import. So import card from these components. Yes, it was a mistake, because when you import components, this is the proper format. You name it, you name your component, it's card, and you specify the path without the JS extension. And then reloading the page. And after the reload, you see that the 3 cards got inserted in the code. So reload was done automatically, and now we have the 3 cards. They don't look that good, and they are not in alignment with the styles that we have, but at least you see that it's working. We have our 3 components, and they are working like charm. So you have the card data.map card, and for the sake of simplicity, we could also create variables, because if you added all this logic inside the render, sooner or later you would have a very hard time reading what is really going on. So the best practice for this is creating a variable, a constant, so const cards, so cards template equals, and then inside here you can write card data.map, and then here I would say card text, and the return value is gonna be basically card, and well, these are the props to be exact. And if you remember, the suggestion that I gave you before was to add ... props to enumerate all the props. This is one option. But there is another option, and I'm gonna write this down in the verbose way. So the verbose way is gonna be that I'm gonna add braces around the return value and add a return statement. So with that, I didn't change anything at all. So far, it's like when you see these props, then return this value. And to make it easier to understand, I will just use and explain destructuring. So inside the props, we have front side and back side. So we have const front side equals props.frontside. Const backside equals props.backside, like this. So you can just add front side equals front side and backside equals backside. What's the advantage of this? Well, obviously, if you if you define these props, then the code self-documents itself. So you know that we are talking about these two props, and then if you go to the card to debug what is going on or check what is going on, then you will see like front side, back side. But obviously we're doing a bit too much, so 1, 2, 3, 4, 5 lines in total. This might be an overkill just for this card component, while instead of these lines we could have just written cards and it would work in the same way. You see it's still working, so maybe just writing card would be enough. It is worth pausing for a moment and understanding this part and how this part can be written in a completely different way. So this is our current result, and the end result should be, I'll show you, card data.map props, and here we have card dot props. This is the end result, and it's super important to understand every little step about what is going on and why it's written this way. So first of all, the first thing that we need to understand is destructuring. So whenever we have props, we just create an object like this. So I'm just copying this object, and I'm going to experiment in Chrome Developer Tools. So right click and inspect, and after inspecting you will get access to Chrome Developer Tools. There you go. You see that we managed to shrink the other part. And moving to the console, you have access to a Chrome Developer Tool console. So obviously with all the errors and everything else, I want to go back to the console. Please give me the console. Thank you. So sometimes I need to wait for a moment for the developer tools to appear. So it's unfortunately not always fully smooth. So var, and in the console, this is just a small hack for you. I always use var, so no lets, no consts. Because if I use let a, for example, and let a equals 5, and if I close it and I create, for example, var a equals 7, then it complains because I already defined the identifier a as a let or a const. This is why I usually use var, because otherwise I would have to work in these braces every single time and I would forget what happened before, or I would have to refresh the page and clear the errors again. So this is just some small hack. That's why you'll see me use vars quite often in consoles. So var props equals this. Okay, so we created the props, and whenever you say either const, let, or var, that for example var front side equals props, then let's see what happens. So first of all, if I run this, then front side is taken out from the props. At least this value is put into the front side. The way how this is interpreted is very interesting. So the first thing that I need to let you know is that this is a property shorthand notation. So in reality, it works like front side colon front side. So whenever you just see this front side, is the same as writing this. This is the property shorthand notation, where front side is the key and this front side, the blue front side, is the value. Now let's see the right hand side, these braces. And after checking the right hand side, maybe I'll put it on the same line just so that you see this. You see a very similar structure. So front side, a colon, and here a variable, and here some text. And yes, we do have a backside as well, but we cannot find this backside on the left hand side structure. So during destructuring, we just get rid of everything on the right side that is not explicitly queried on the left hand side. So we can safely delete this backside rabbit. And afterwards, let's examine the structure. The keys are the same. The braces are the same. So it's a very easy explanation to just say whatever is the same on the left and on the right, just delete it. So we'll delete this, and this, and this, and this. And we're left with front side equals rabbit times 8. Alright, so this is how we do the destructuring. So that's for the front side. We can also do var front side back side equals props. And then you will see that the front side is still rabbit times 8 and back side is still rabbit. How is this working? It's the same concept. So we check out the right hand side. We also complete colon front side and colon back side. There you go. So now what is at the top this time is gonna be compared to what is at the bottom. So we have the first object and the second object. You see that whatever is before the equation sign is comparable to whatever is after it. So now we have a comparison between like the front side and rabbit times 8. So here the value rabbit times 8 is put in front side and the value rabbit is put in back side. And the beauty of destructuring is that the two are done simultaneously. So it's like saying var and front side equals this rabbit times 8 colon backside equals rabbit. So this backside equals this. And then we're set. So this is destructuring. And you see that whenever we have props, we can also write this. So if we can write this instead of props, then if you see props here, then you can also write the front side back side here. I'll put it in parentheses because we cannot use braces here. Because braces mean both blocks and functions and objects. So it's better to put the props into parentheses and just write front side, back side. And then if we do this, we can get rid of these two lines. You see? Because we already took front side and back side out from props. So if you use front side, back side, then technically you don't even need these braces anymore and the return value. Because you can just use this is the input and give me a card component with this front side, back side. And this is gonna be the return value. If you save it, it's gonna work. Now, we also have this ... props solution, this one. So let's examine that. Whenever we have props like this, we can enumerate its values. So if we have, for example, an object, for example, you have key colon value, you press comma, and you can mix in the keys and values of the props like this. This is the ... props. It spreads all the keys and values in the object. So we have key value, front side rabbit times 8, back side rabbit. What is even more interesting is that you have props like this. If I say var props2 equals ... props like this, then you see that you also have props2. And if you change props2 dot front side to new, then props2 is gonna have the new in the front side, but props will keep the rabbit times 8 in the front side. So effectively doing this is the same as cloning the original props and creating new values. cloning is an important concept of functional programming. And in functional programming, you have this concept of immutability, that you cannot change what you already have. Instead of changing the props, you create a new variable, which could be, in this case, props2, and you change that. So you make changes to some other variable instead of continuously mutating or changing. So mutation and change is used interchangeably. So instead of mutating the original props. This concept is important in React in general because in many cases we prefer this concept of immutability, that we are not changing values. Actually, if you use Redux with React, you will have to rely on this, and you will see this ... spreading quite often. This triple dots or ellipses, the spread operator, confuses a lot of people actually, because originally in the 2015 version of JavaScript it was only used on arrays. So it was like, for example, you have an array equals 1, 2, 5, and if we added ... array ... array, then we would mix these values in the array consecutively. So this was the role of the spread operator back in the days. But this is also working for objects. So if you prefer that this format, then you can also do it in a way that you have this front side, back side here. So this is an object, and you add the spread operator in front of it. I said spread operator, not the apply. So dot, no, dot, and dot, yeah. So this is a spread operator. Maybe putting a parenthesis would help, not sure. It is just for illustration purposes. And given this is an expression, we have to put it as an expression like this. I know it's a bit confusing with the braces and everything else. So here we are enumerating this front side, back side as properties of the card. And now we can just move back the original props. So we have the front side, back side here and here as well. And we'll just make it props. So props here and props here. And in fact, we can get rid of the parentheses. So props and props. And we got back the other format. But as I said, it's enough to just write the card constructor. Just apply the card functional component constructor on the mapping. And then you're set. The card data.map card. And here, we don't have to think about what this means. We just use cards template, so that we have a descriptive variable and we're set. So we're saving changes. You see that the page is reloaded, and after the reload we still have the front side and the back side properly added. Okay, now we have learned quite a lot already, so we now know how to create components. Just look at the card.js. How to create projects in Visual Studio Code, how to write JSX, so proper JSX with these ULs, LIs, and so on, how to insert JavaScript expressions inside the JSX, how to render a React application in the React DOM.render, and this is just a simple component, how to import a component, and how to nest components inside other components. This is one way to nest a component inside another. Just for clarification, let's create a title, because we have this header, app header, that's fine. Actually, the card template should not be inside the header, it should be outside the header. And let's extract this header component to another one. So instead of card, we can create a new folder called header or app header. maybe I could rename it to app header, and we're gonna create a new file, app header.js. And it's the same spiel, import React from React, and function app header, and then we paste whatever we have in the app.js. So we don't need this header. Save, and we add this to the app header. So we need to make some indentation, and in fact this cards app, it works like this too. You still have the logo, you still have the app header. One more thing, maybe that this app header, app logo, whatever else, this CSS is something that could be moved up as well, like app logo, app header. These things belong to the app header, so why not just add the CSS file as well? So import and /app header.css. So saving this and creating the CSS file. So app header.css, it's here. Now we have the CSS file, and we can just copy paste the CSS from the app.css. So app header is gonna be moved to the other CSS file, that's for sure. App logo spin, that's also a header type of functionality with these keyframes. Let's see what else. Is app link and the app header or elsewhere? I'm closing some of the files. You have app header, app logo, and basically these are our files. So in app header.css we have these already. App link is a generic style. The app logo goes to the app header. So this media query goes here. And this app logo as well. So we're just left with the app and the app link in the main app, and the rest of the files, the rest of the CSS rules are here. This is important because if you have these styles where they belong, then it's gonna be very easy to maintain your code. So you see app logo next to each other, all the app logo content, and then the app header at the top. So this means that now we have the app header CSS where it belongs, and you have the app header component. Now we need to export. So previously we wrote export default app header, but we don't have to do that. We can also export default here. So we're saving changes. And in the app.js, we have to import the app header. So import app header from /components. So components, you can just press tab and autocomplete, app header /app header. There you go. And now we can simply use this app header as a component to nest the app header here with a slash and save. Let's see the errors. So the first problem is that we have this logo svg, which is an unused variable here. We need to move this from the app to the app header because we're using it here. So import logo, you see that the source equals logo. So we need to move this image here. The second problem here is that we should not have any unused expressions. So actually we have multiple problems because here we don't have a return value. I'm gonna just change this function app header to export default const app header equals, and then I'm gonna just write an arrow function like this. And instead of the parentheses, we can just write, or instead of the braces, we can just write a parentheses. And then we have this app header like this. And export default app header will be exported. Logo.svg is has a different path. So we need to go to the logo SVG on top level. So we have to move out // logo.svg. And now we got our React app back. And you see we have the cards app. Everything stays the same with the header. And we have the cards at the bottom because now remember that when we in the app we took the cards template out from the header. So now it's in the main area with this front side, back side. So with all these changes, we now have a simple app with its own header that we can customize, style in any way we want. So let's go back to the app header.css and check this min height. This 100 VH is not too helpful. Let's see what happens if we just remove this min height. Because clearly we don't need that much height. You see it working like this a bit better because we have a bit more space for our actual app. And obviously we will change the header because it's not about this React app. We should do our own thing and not just the React app. So I'm removing this min height. It's not serving any purpose at this stage. Let's clean up this header a bit. And with that, we will continue learning about how to pass props to, for example, the header component. So with app header title equals flashcards. This is gonna be the prop that we're gonna use inside the app header to render changes. So when we go to app header, here we need to write props. And inside, we could clean things up a bit, but before that, let me just connect this with, instead of cards app, we'll just write props dot, what was it? I forgot it already, title. So this is gonna be our title inside. And after the changes, you can see that the cards app will soon change to flashcards. So now the title changed to flashcards. Actually, it would make sense cleaning things up because this logo doesn't really serve a purpose, although it could work. So we have this header, app header, and we could just create a proper logo. So display flex direction could be just row, and instead of the 40 vmin, let's just do something a lot smaller. So it's like 5 should be enough. And then you can see that we have the logo here. We decreased the size from 40 to 5. You have the flashcards title. Now the flashcards title, the app header, let's just keep this. And also align items. We could change, or justify content. We can change the justify content to, for example, flex start, so that we move everything to the left. And then we could add some padding or margin. So for example, we could have padding. The top and bottom padding should be something like whatever, 1 vmin. And the left and right padding should be something like 4 vmin, so that you have the proper values set up. And now you can see that there is some space around this React logo. And actually changing this 5 vmin to 10 would make sense, maybe, or 8. Let's do 8. So now the logo is a bit larger than the text and it looks okay. Maybe the right padding could be just 2 vmin, the bottom 1 vmin, and the left 4 vmin. And then this way we're positioning the logo in such a way that it looks a bit more balanced. So now we have the flashcards app. We could change the logo a bit later. Right now we are using the React logo. And you see that that we could pass props to the app header and we could also render it. Let's just practice the destructuring trick that we just learned. So it was title, like this. And we can just render the title here. And done. We can write a bit less this way. Our next step now with the flashcard application is to just check the responsibilities, because if you go to app.js, you see that we're rendering a list of cards. And even though it's not a complicated responsibility to render these templates, the cards templates, it's still, we could improve it and we could just create a card list component. So basically it's a list of cards and just render a card list like this. I'll show you. So card list like this, so that we can describe the cards properly and we can add more functionality to the cards later. So this is what we're gonna do, and this is more or less a repetition of what we have been doing, but there are gonna be small differences. So component, we're creating a new folder, card list, so that we can place our cards in here. So new file, card list.js, and here we have our card list component. Import react from react, and then you just need to place this logic that we have here, the cards template and so on, inside. So let's see, we'll create a function card list, because it's gonna be a functional component just like before. As I said, there are class-based components, but you see that we haven't needed class-based components yet. We will learn them, but you know, so far we're more than fine with functional components. So these card lists have props, and inside this function we can just do the same mapping. So we have the cards template, card data.map card, and this is what we can basically return. So return card data.map card. And here this card data doesn't exist, so we could just supply it inside the props like this. So instead of props we would just have card data, and then using the same destructuring assignment we just get the card data as the props. And one reason why I did this is to show you how to submit an array like this card data inside as props. Because as soon as we import this card list to our application, we will see how to create it as a component. So we write export default card list, and we also have to import the card. So import card from /card/card. So we have to move one folder up from the card list to components, and then we have to move inside card, and inside the card we just need the card.js file without the extension. So we're importing that component inside so that we can render it, and then at the end we export the card list. Moving back to the app, we now have a card list, and instead of the card we can just import a card list like this. So card list / card list, and after we are done with the card list import, we can just use the card list template card list to render the list, and we have to provide the props for it, the card data equals, and then just supply these card data here with this. So now we are set with the card data. Let's see what's wrong. In app.js card is not defined, of course, because we need to delete this line. we don't need the card data.map card because it's the responsibility of the card list now. And now things are working fine. So if you check the app, it's already rendered, but we can render it once more. You can see that it's still working properly. And now, if we wanted to render multiple card lists, we would be able to do so. So instead of this card data, we could just add something like front side 1, back side 2. And then you would have an other card list. Inside, we have to add an object, of course. Oops. So we're placing these values in here. And after the re-rendering, you can see that this new card got created. And we created 2 card lists, basically. So this is great because now we can create multiple lists of cards. And maybe we could also create a board where we display these cards in different swim lanes or in some other layouts, whatever makes sense. So now you see that the responsibilities got abstracted. And inside the card list, there is this problem that React is defined, but it's never used. So technically, if we comment this out, let's see if it's still working, because as you can see, first you have failed to compile, compile with warning, compile successfully. It never hurts to import React in an application like this, because technically, whenever we use any components, then technically we use React. So I would not worry about importing React to this file, even if it compiles successfully without the import React, because later we will update this code anyway. So far things are working out well. We managed to create multiple card lists, multiple cards, and so on. Maybe adding some CSS to the card list would make sense. Card list.css. I keep these sections relatively short because this is not a CSS course, but we're building apps anyway, so it makes some sense of spending some time to design something that looks more or less appealing. So first of all, notice that with the card list, we could create a swim lane or something, because here the card list doesn't have a component, it just renders some cards next to each other. So instead of this return card data map, we could return proper markup. So first we add parentheses around the card data map, and then we insert them as JavaScript expressions inside the React. And I'll just add the div class equals card list swim lane. So this is going to be our class, and let's not forget that here we have to write class name instead of class, because in React class is a reserved JavaScript keyword, so we have to use class name instead. So now we have this card list swim lane, and we can do some magic with it in the CSS file. So here we have the card list swim lane. Let's see that thanks to the div, you see that now different card lists are on different lines, because the div is a block element in general. And with these block divs, you have these options of displaying everything in one full line. In fact, it's not an option, it's default behavior for divs. So if I added border 1 pixel solid black, then you would see where the divs are positioned. Of course, only after importing the CSS. So import ./cardlist.css. You always have to make sure that it's imported. And afterwards, once we compile the files, the CSS should also appear. And there you go. Whenever positioning layout and elements, it's often useful to just create a border around the components that you want to position. And you see that when you have block level divs, they occupy the full width. So let's change the divs layout. So display property is going to be flex. And For the dimensions, we could use something like a fixed width, for example 80 pixels, and then we could add some margin. So 10 pixels is going to be the vertical margin, the top and bottom margin, and auto is the left-right margin so that we center our swim lanes. If we save this, let's see what they look like. Yeah, I wanted 80% and not 80 pixels. Sorry about that. So 80%. And now it's properly done. And you can see that even here there is a small problem, that even though we can adjust the dimensions, but as soon as we get like a really short screen, then the cards go out from their intended container. So you see that here the cards can get out from their container. This can be fixed. For example, let's suppose that our mobile first view should be something like 400 pixels, and then we will adjust things later. So now we have 400 pixels, that's the default, and whatever we have afterwards, it's gonna be centered. So we have left margin, right margin, and then we will create some media queries. So with this at media only screen and min width, and here we can add something like 640 pixels, and then inside this media query you could have this quart list swim lane declaration as well. And the only thing that changes, that instead of this width 400, you could add something like width 600. So I'll show you what it looks like. I'll create the developer tool so that we can move around. So I'm moving a bit left. You see that in very small screen sizes, there is gonna be scrolling happening for the whole page, like this. Now, if the screen size is a bit larger, then you see that we're increasing the size, but it's still 400 pixels, and now it changed, you see? So as soon as we reach the 640 pixels, the width changed accordingly. So this is usually a very good way of positioning and creating breakpoints. And notice that I first did the small screen width, and only then did I add the larger one. This is intentional because it's always easier to adjust from smaller screen size to larger than from larger to smaller. This is because if you have more space, more real estate, then you can obviously make use of it better than if you cram your page on a large screen size with a lot of stuff, and then you have to squeeze it into an even smaller screen. So this is why using min width instead of max width makes a lot of sense. Now comes the next part, so it might make sense designing the cards as well accordingly. First of all, you see that these cards are left aligned, fully left aligned. There is another flexbox setting in the swim lanes. It's called justify content, and it's space around. And after we change this, you see that the cards are spaced around properly, quite evenly. The only problem is that the card dimensions differ from card to card. So why not just create some card CSS changes where we fix the card width. We have 100%, so 27% should be fine. Or let's say, like, first let's try 20% and let's see what happens. So if we fix them to 20%, then they are gonna be obviously a lot smaller. You see that 1 out of 5 units are in there, and now we have uniform width. But then the problem is that here we have the front side and here we have the back side, and it looks kind of weird that it doesn't really fit. But it's not a problem, it depends on space size, because as soon as I make this page wider like this, then the breakpoint will kick in. As soon as it's like more narrow, you see that it's even worse. So it depends. It really depends on our settings. Maybe we could even scale on larger screen sizes on the card list. So instead of 600 pixels, we could just add, let's see, so 400 out of 640 is basically a ratio console. So let's calculate 400 divided by 640. You see it's like 62.5%. We can create a seamless experience, a seamless transition experience, if, let's say, I created a width of 62.5%. And this would mean to us that as soon as we make the width larger, then everything will scale according to proportions. So you see it's like bit larger, and then the card width will continuously increase. So you see now it's like almost full width, and it's always gonna be like 27 or whatever percent of the full card size. And maybe we just need the sweet spot, so maybe adding like 22% makes sense. And then we will have this swim lane implemented properly. Alright, so now we have the 3 cards, and we have at least some styles. So it's not finished yet, it's just initially we will see how this is supposed to work. Flexbox has another feature called flex wrap. Flex wrap will add the possibility of going to multiple lines. So if I had more card data, so if I added 3 more of these, I just repeat the same questions, then you can see how 6 cards are displayed on 2 lines. So there you go, now we have 6 cards and they are spaced inside our flexbox properly. So now we have quite a few cards, and we've taken care of the styling of this card. Now let's make just one change on the card. So we have this card.js file, and you can see that we designed it in such a way that we display both the front side and the back side. This shouldn't necessarily happen. So what should happen is that we have the front side and the back side, front side and back side, and well, the card component should determine which one to display. So we'll change this card to a div instead of a UL. And initially we're just gonna include the front side. So I'm just gonna delete everything else, and here I'm gonna add a front class to display the front side. This is one option. The other option is, and that would make a bit more sense, div class equals, and I'm gonna add a card underscore front. So this class is like a block element type of class. This is the block, the card block, and the front is an element inside the card block. So we're gonna add this div inside, and we will also add the same for the back side. So this is gonna be the back side here. And given that we have the front side, back side now destructured, we can just add the front side here, and we can just add the back side here, and this is gonna be the card underscore back. And we'll also add the hidden class to the second one. This will mean to us a bit later that we're gonna hide one of the classes or one of the divs out of the 2. So if we save the changes, you will see that the cards are still working. We have the 2 divs displayed, both the front side and the back side. So it's still working as expected, but of course we need to change the card CSS a bit. So you have the card, which is still properly styled. Now instead of the space, which I think we can just delete the space now. It doesn't belong to the card because Flexbox is taking care of everything. Now we can add the card __ front. This is gonna be the front side, and we can style it in some way if we wanted to. So for example, we could change the font size or the font, and also we will add the card __ back styles here, and we also have a hidden. So let's just add the hidden in here. So card __ front hidden, and card __ back also dot hidden. So there you go, we only have the front side now, and now the next task is gonna be to implement the click handler. So let's see how event handling is working in React functional components. So now we have properly corrected these divs to class name from class. You can see that here is the card. We check the front side and the back side as well. And now we have a proper card component. Obviously before that we just had the props here, and if we had the props, then you have to write props.frontside and props.backside. So this is how we get the card displayed. Alright, then let's revert back. So we can remove the props if we destructure with the front side and the back side, and this is where we can continue introducing something to make sure that from the front side we can go to the back side. So this is gonna be a click handler. We have to be able to handle clicks and possibly some other types of events that are happening. And this is an important concept because in React there is one-way data flow happening. So one-way data flow means that we're not touching the DOM ourselves directly. We're just describing how the DOM should render, the document object model should render, and then we'll let React take care of the rest. So this is how we're gonna approach these things. That we have a concept called the state, and what happens during the rendering is the following. We have some state change. React detects this state change, so React renders the DOM. And then afterwards there is a user event, for example a click, and inside that click there is a state change. So for example, I'll display it like this. So this is the type of feedback that is happening, and with the user event we can just make sure that whenever the user event changes the state, React detects it and it renders a DOM. From the event handling, so here we have for example an event handler. So from the event handling we are not manipulating document nodes at all. There is absolutely no manipulation. Instead we have to use something that we call the state. So these are going to be our state variables that are going to be defined quite soon, and then we'll have some event handlers. So for the sake of this example, let's create an event handler here. In React we have to call this onClick if we're talking about a click event. You can see onClick capture, on double click, and many others. So if you just write on, you see that we can abort, detect animations, blurring, which is focusing out from the element when you press the tab, for example. You have click, cut, drag start, drag and drop. A lot of different events can be handled in React. We're gonna just use onClick this time, and inside this onClick attribute value, this is a prop just like any other property. Now here we can add a function name, for example handleClick. And in the event handler, you can just write function handleClick, and inside we have some implementation, so processing the event and possibly changing state. So you know, for example, if you had a form, then you would have an event object and you would write event.prevent default action, so event.prevent default, to prevent the default action of submitting the form. Oftentimes when you press enter, for example, in a text field, it would submit the form automatically, and then people are wondering why is the page reloaded if I didn't ask it to be reloaded. So these things can happen inside the event handler like this. But this is not enough, because we also need to change the state. And to change the state, we have to describe the state. So it's evident that we have a front side and a back side, and initially we'd like to display the front side. So if you have a const, we have to display the front side, and we have to find a way to change the front side with change face, for example. We can name these in any way we want to. And in React, we have to put them in an array. Front side change face equals react.useState. And then we have some initial value, for example, true. Because the front side is gonna be a Boolean variable. It can be true or false. Actually, instead of front side, I'll just write isFront, because it makes more sense. Whenever we write is, we indicate that we're talking about a Boolean variable. So this is the isFront and the change face. And now for the return value, to describe it properly, we have to add the class list. So const front class list equals, and then we're gonna just process it. So we have a cart front here, and with a plus sign we can just create a conditional. So isFront question mark, and then you would not add anything because you don't need the hidden class. But if it's not the front side, then you would add the hidden class, making sure that you add the space in front of it, because after the cart front we need a space. Well, technically you can also add the space here, but I'll just process it this way with the isFront. We need to do the same with the back. So const back class list equals card back, and then plus isFront question mark, and then we have the hidden class if the front is showing up, otherwise we have an empty string. And then we can obviously use the two classes or class lists. So here front class list, and here back class list. This is just a small change so that we keep exactly one of the elements hidden, and you can see that the isFront is already used. So thanks to the isFront, we can describe what needs to be rendered by React whenever it runs the rendering. Because whenever React renders, this function is called, and then we have this front class list, back class list that is taking care of everything. Now in the handleClick, we still need to change the face. And this change face happens by calling the change face as a function. This second argument is a function. So this is a getter. This gets you the value of whether we are on the front side or on the back side. And the change face changes the value from front to back or from back to front. So we have change face, and here we need to add the old value. So whichever it was, old value, and this is a function inside as well, so we just negate what it was originally with the exclamation mark. You know, exclamation mark true becomes false, exclamation mark false becomes true. This is just simple negation. So we're just create this not old value like this. So this is the change phase, and this just changes the isFront from true to false or from false to true, depending on where we are. If you don't understand this fully because of the arrow function, I can write this in an easier way. So for example, var flip. So this flip is gonna be something where we have the old value, and then we return the not old value. This is the same thing. So actually not var flip but function flip. This is the same thing as writing this old value not old value. So if I added here flip, then you would have the exact same result. This is the same as this, flipping the card. But let's just keep the arrow function because it's neat and concise. Alright, now we have a handle click, we have the state description, and we have something that uses the state in the markup. And now notice that in the click handler, we're changing the face. So this means that whenever the user clicks, we prepare the state variables, and then React will take care of the rendering. So this is the same situation. Imagine that the user clicks, we're here. Then an event handler starts processing the situation. It's here, handle click. Then this event handler changes the state. So here we have the change phase. This state variable is called, which is a function changing the value of isFront. After the state is changed, React automatically detects that there was a change. So when React renders the DOM, it automatically detects the change of the isFront, and then it assembles the DOM, where obviously the DOM has a representation that depends on the state variable, and re-renders it according to its differential rendering algorithm, which is very efficient, so it only re-renders the DOM if there is something to change. If there is nothing to change, for example, I created a counter variable, so const, for example, count, set count equals react.useState 0. I could do this very easily. Then, and let's say instead of the change phase, I just increase the count. So set count, and then count plus 1. So this would count the number of clicks, and it would go to like 1, 2, 3, 4, and so on. But given that this set count is not at all in the description of what is to be rendered, React doesn't re-render the DOM. So React only re-renders if there is something to re-render. For example, in the isFront, you see that the hidden class is toggled and flipped from one div to another, and then React renders things automatically. This is the main power of React, by the way. So this is why React is so efficient, because you just describe what needs to be rendered and React takes care of the rest. There is no such thing as some spaghetti back and forth between like different event handlers and different DOM manipulations, where at the end you don't even know where your changes are. So it's very important that we only have access to the state from the event handlers and not to the DOM. Okay, so we made these changes. I'll save, and well, the React app is gonna be rendered, and you can see that there is a mistake because both the front and the back got displayed. The flipping is working, but for some reason the backside is not hidden. Let's see why. So we have the back class list. If we have the isFront, yes, we forgot the space. Maybe it's better to add a space right here, because then we won't forget it, and just adding a space doesn't hurt the class list. Now you see that it's front side, back side, so just front, just back. So we have the different cards already. Let's change the styles so that we have different colors for card front and card back. So first of all, the background colors are gonna be moved here to the front and the back. You can select another color, which is not the C0, 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 but something else. We'll use something light yellow, so FFFF, full red, full green, and let's see, a bit less of a blue. So this would give us some yellow. And we could do the same with some light green colors, where we would have CCFFCC, for example. So we're reducing the red and the green, and the blue will stay. So these are gonna be the card front and card back colors. Now we can fix the width of and the height of the cards. So the width is already fixed. Let's make the height, for example, 50 pixels. And we could also make the width fixed. So instead of the 22%, we can just say that we're gonna add 125 pixel width cards, and then we'll just let Flexbox figure out the positioning. So it doesn't have to scale with percentages, it can also be pixels. And with that, for all the card front and card back, so card front and card back, you can add the width 100%, and we could also set the line height equal the original height that we specified. So equals height of the container. So if you do this, the following will happen. You see the light green color, and it's fully there, and we have a vertical centering. If we add it 100% here, let's see what would happen. It would not give you the proper values because it doesn't work in a way that you have the full height maxed out. So I would just normally keep the 50 pixels. So it may make sense adding a custom variable, which is done like this. We just have this root pseudo class, and inside the root we could add 2 horizontal lines, and we would have card height like this. We can create any variable names, and then we will just add the 50 pixels like this. And then whenever you need to use this card height, you just write a var and card height. There you go. Here and here. And then you don't have this problem that you have to match the two values. You just have the height specified here and here. And it's gonna be the same. Let's see how this works. So you see that in theory nothing should change. And you see that the cards are reloading and it's still working properly. So you have front side, back side, and now the width and the height are also fixed. Obviously, if you had a different type of application, it should be wider than this. We will soon rewrite our functional component, a card component, to a class-based component. So this means to you that you will soon use a very easy to misunderstand ES6 feature called ES6 classes. And for that, I thought I would introduce these classes to you just by playing with it. And this will help you understand what is coming next, because obviously classes are not the easiest things in the world. If you want more information and more exercises on classes, I have my book ES6 in Practice, and I made the class syntax video accompanying the book available to you online, so you can check it out. It's on my YouTube channel, Class Syntax in ES6, and you can learn everything, the ins and outs of classes. So suppose that we have a class. The class is a reserved keyword in JavaScript. We talked about this. This is why whenever we add the class to a div, for example, we have to write class name in React. The property name is class name. So if class is a reserved keyword, this means that we can use it for something. And this is to create some blueprints. So classes are basically blueprints of things that we describe in real life. Think of it as, for example, class bank account, or class person, or class whatever else. So for example, React is also a class. It describes a component, a generic component that can render itself, and that has a constructor, and that has some other features like state. You saw components already written in a functional way. The class-based way is the exact same thing. So to learn this by example, let's create something that we can understand very easily. For example, shape. A shape can be like a circle, a rectangle, a square, a rhombus, basically anything. And you know, whenever we talk about shape, we could also talk about, let's say, fields or land that we purchase, right? Because it's usually rectangular, but not always. So who knows? We could have some complex shapes as well. So class shape, and if we add a class shape like this, then we can describe quite a lot of things inside what a shape should look like in general. We're not creating any shapes yet, we just describe how shapes behave in real life. Or we could also add animals, for example, and then we would have, let's say, rabbits, dogs, whatever else. And if we say, for example, rabbit, then we're not referring to any concrete animal or any concrete rabbit with a personality and some other features. We're just referring to the species. So this is what classes are for. And inside a class, we have a constructor. And inside the constructor, we have the parameters that describe what the shape could be. So we could add a name or a color or whatever else to it. So I'll just add the name. And inside a class, we have a concept of the variable this. You see that this is written with purple. This means that it's reserved for some purpose other than just writing a random variable. So if I wrote a variable like whatever name, you see that it's white, and that this is purple to indicate that it should be used inside the class in a specific way. And this stores the properties and operations of the concrete objects that we create out of the class. So shape is the class, is the blueprint describing what concrete objects should look like. And the concrete objects are, for example, let's talk about rabbits. For example, you have one of them called Beanie, the other one called whatever else. So the name is gonna be the property of the concrete person, the concrete rabbit. And at the same time, the class describes the rabbits on abstract blueprint level. So when you say this.name equals name, it means that JavaScript, please take this name property that I supplied to you and save it in your state space. So from now on, this shape is gonna be referred to as by its name. So for example, my rectangle. We supply a my rectangle to the shape constructor. It's gonna be here, and we save it inside this.name. That's it. So class shape constructor this.name equals name. Now we can have other methods inside. So we can write, for example, toString, and let's suppose that we're creating something like return, and we'll use a template literal with the backticks just below your escape key in English keyboards, and inside we can squeeze in the name, and I will also add something a bit later called getArea. You don't have to have this getArea here because we are not really supplying the area data for the shape, because we don't even know what kind of shape we're talking about. On shape level, all we know that it has a name, and we will provide these details later that will help us calculate the getArea. So that will come a bit later. But let's just focus on the name. So focusing on the name is gonna be sufficient for, so for example, shape colon to reason about shapes. So if I wanted to create a shape, then I would say var let or const. I can just write const my shape. So this is the concrete shape. For example, my parcel equals new shape, and then we give it a name. So whatever parcel, let's name this Malta, for example. Alright, so we have my parcel, and you see that if we visit this my parcel, it has the name, and inside it has this thing called the proto, and this proto has a constructor that we created and this toString. This is the prototype of the shape, and afterwards, if I add my parcel dot and call the toString, then you see that this shape is invoked. Now, of course, I made a mistake because instead of name, I should have referred to it as this.name. So I'll go back and write this.name, and you will see that after the creation, so const my parcel equals new shape. Well, of course, now I need to give it a different name. So maybe I'll just reload the whole page. So we have the shape, my parcel equals new shape. Maybe I'll give it a var name so that I can reuse this my parcel later. Now, if I add my parcel like this, you see the name, and in the prototype you have the two methods that we defined, the constructor and the toString. The constructor is invoked when you created this new. So the new keyword creates a new object out of the shape class. So read it like this: tell me the blueprint, create a new object out of it, and supply these parameters that you'll be able to read in the constructor. And this will invoke the constructor of the shape and instantiate the shape. It will create a new object. So this is what we're talking about here. And now we have the my parcel, and we can call the toString, for example. And then you have shape colon Malta. So it's working like this. By the way, just some side information, that if you have like some text and if you inserted my parcel here, JavaScript works in a strange way. Well, actually it's not that strange because other languages work in the same way, that this toString method is invoked whenever you need to convert this value to a string. So you see it's working text shape Malta because the shape Malta got inserted into the text. But that's not the point that we need. Rather, the point is that we can use classes like this to define the generic behaviors of objects that we create out of these classes. Why is this gonna be important? Well, simple, React is gonna be a class quite soon. So let's get back to the shape first, and let's see how to create some other shapes, like some concrete shapes, for example, rectangle. We have to write the extends keyword, and it extends shape. So with this, we write that a rectangle is a shape and something else. So rectangle is a shape, circle is a shape, whatever else is a shape. So we could also add class circle extends shape. All right. So now we have a rectangle and circle. Obviously, in the constructor, we can supply parameters like name, width, height. So now that we have these things supplied, we can call the super to access the constructor of the parent. Because if a rectangle is a shape, then we need to invoke the constructor of the parent class. This is why we have the super here. So the super, we can supply the name. This will take care of saving the name inside the shape. So it's basically a chain where you have the concrete object, for example, my parcel or my rectangle, that we create like, so var my rectangle equals new rectangle, and then you have the name, and so my rectangle, the width and the height. So you have the concrete rectangle, that the instance, it has a prototype which is defined by this class, and this has a proto that's defined by the shape. So it's a hierarchical relationship in this sense, and whatever you define in the state, like this dot width equals width and this dot height equals height, these things that you define are gonna be accessible inside the my rectangle. And now let's add the area, this dot get area, and let's see how to provide that. So get area is gonna be a method that returns this dot width multiplied by this dot height. So that's the get area. And this can also be accessed from the shape, because whatever we save under the this value is gonna be accessed. Now, if we create a shape, obviously this will not work because the shape doesn't have a get area method. But as soon as we extend it with something concrete, then it's gonna work. Think of this get area as basically React rendering. So you need to define some way to render your React component, because without that it's not gonna work. But you're not creating React components like I'll show you at the top. So when you have React, you're not creating them like this, like React, but you create your own component. So for example, card. And the same thing is happening. You're not gonna create shapes. It doesn't make sense to instantiate the shape. You're creating something concrete, like a rectangle. And this rectangle has a name. This has a width, like 5, and this is a height, like 2. With the React analogy. Of course, this is just JSX. This is just syntactic sugar that is provided by Babel React, but it's the same concept basically. The rectangle is a class, and it has properties, and we deal with these properties in the constructor. So moving on, we also need to define the circle. In fact, you can define it yourself. Just create a radius instead of the width and the height, and the area is radius times pi, math.pi to be exact. So if you would like to do that, just stop the video and implement the changes, and I will do it myself here. So constructor name radius, and Here we need to call super name, and this dot radius equals radius, and we have the get area method where we have return this dot radius power 2, so it's like this dot radius times this dot radius. You just write it like this, times math.py. You see that it's a constant, so it's working like this. Technically, in the class syntax, you could also write it like this, like get area, but we're not gonna deal with it. It would just be accessible as a property area like this, and it can be defined as a getter, but I'm not gonna do this because of the React analogy. So in React, we will also have, for example, render methods and some other things. In fact, you can think of this toString as a renderer and this get area as a property inside. So now we have a rectangle. So you see that the shape is defined here, the rectangle is defined here. We can instantiate the rectangle. When we do that, we first call the shape constructor that saves the name, then we save the width and the height, and we make the get area method available. So when we create my rectangle, then you see that we have a name, a width, and a height. In the proto, we have a constructor and the get area. And after checking that, this also has a proto that has a constructor, the shape constructor, and the toString. So this is the structure that we just created using this class syntax. So this is the my rectangle. We can of course create a my circle equals new circle, and then my circle, and the radius, it can be like 10. And then we have a circle as well. Same structure. Here we have a radius instead of the width and the height, but in the proto we have the exact same structure. And you see that it's code reuse basically, so I don't have to implement the toString again and the get area and the whatever else. No, we don't need to do that. It's created once, and we can, if we have 1,000 components, then we reuse it 1,000 times. This is what's happening with React as well. The basic React code, we're not rewriting React every single time we create a component, so this class syntax makes a lot of sense actually. And then just think about it, like at the bottom we can just write a template literal like this, and we can add some, for example, div /div is like simple template, and inside this div we can just insert the my rectangle, and inside this div we can insert the my circle, and this automatically calls the toString method. And when we check the toString method, what is happening? For example, in case of the my rectangle, you see that my rectangle has a name, a width, and a height. That's it. So the toString method is not found. So in this case, we go to the proto, and in the proto we cannot see anything. So we have a constructor and a toString. So this toString is found and this toString is accessed. If we didn't have the toString, by the way, we would go to the proto, and in the proto we would have a default toString implementation, which would most likely create something like object. I'll show this to you as well. So for example, here we could write just an empty array, just for the sake of showing that toString is working. So let's suppose that we're evaluating this thing, and then we have my rectangle area 10, my circle area this larger amount, and well, the empty array is not really created properly. So let's just create a new object. So for example, var dummy object equals this empty object. And if we check the dummy object at the bottom, you see that it's an empty object, it has a proto, and this proto has a toString. So now we will have the expectation that if we write the dummy object, then something will happen. And there you go. This is the default toString implementation. So if we didn't have a toString ourselves, we would have seen object. So alright, that's the class syntax basically. So hopefully it was more or less understandable. So it's like we have a component here. It's like react.component to be exact, react.component. We take this component out from React. So var component equals React. So think of this as the react.component, which you will see quite soon. And then rectangle, it's like the cart. This could be like your cart component, which extends component. So this is how you should think about these classes, that we're creating blueprints for our components. And then with the card, once again, you can just instantiate it with JSX. So instead of writing new card and then name with height, you can just write it in JSX like this, card, and then name equals something, width equals something else, and height equals something else. So that's it. This is how React works under the hood, and with that we can continue and jump in to the React tutorial. It is now time to continue with some lifecycle methods. So now that you know how to do class-based components here in the cart2 component, we will now figure out how to do certain things such as loading data from the API and some other operations that happen during the component's lifecycle. So think about this. For example, in this Flashcards app, you see that we have these different data. But where are these data coming from? So these data are originally created here as a constant in the main app. So this means that we were basically hard coding some data in the application's code, and well, this is not too useful in general. We could also hard code some other flashcards here as parameters. So this is basically an array of objects, but that's not too useful either. So you see that, for example, if we delete this second card list and we save the changes, then you will remove the second part with this after the React app reloads. But it's not too convenient because you would prefer driving these data from online, from the internet. And this is where lifecycle methods will come really handy, because we can load data from an API, an application programming interface, for instance, and populate these cards with some data. So you see, for example, here, if you call restcountries.eu/rest/v2/all, then you get a list of countries. And here you can see this is JSON, it's JavaScript object notation. And this API can be retrieved from the internet. And here you can see, for example, that there is this country called American Samoa, and it has a capital Pago. Interesting. So you have all these countries. I think you have more than 200. And for example, it would be great to create a flashcard application where you have the countries on the front side and their capital cities on the back side, to see whether you know their capitals, you know their countries, and so on. So this is what we're gonna do now using this REST countries API. So I'm gonna remove this API from the screen, and I'll illustrate the 3 lifecycle methods that we can use in any components. So here we have an app. And basically we can also use these lifecycle methods inside the card list. So let's change this app to a class-based component. It will work like class app extends react.component. This is the way to create a React component. We can also import component from here, component, in a destructured way, and then we can just remove the React dot. And inside this class, we have to have a render method, of course, and this render method would return the markup. So this is the fastest way to change a functional component to a class-based component whenever it does nothing else but just rendering some data. So now that we have a class-based component, we can add some lifecycle methods. But before that, let's just save the changes and let's see if we made any mistakes. No, the code is still working, and you saw that it was reloading automatically, so everything is still fine. We're using a simple class-based components. I've talked quite a lot about these lifecycle methods, so let's see what they are. The first lifecycle method that we will learn is called component did mount. Component did mount. There you go. It's even in the autocomplete. This method is called when the component, first mounts to the DOM. This is where we can just create things like data loading from APIs. APIs stand for application programming interfaces. So this is one thing, and it's important not to do, so do not load data inside the constructor. Load data in the component did mount. So this is super important, that you have to use the component did mount to load data whenever your app gets created. So when do we create the app? It's simple. During the beginning, when we first go to this react dom.render and we create an instance from this app class. So this is when we do the component did mount. Then you have a second lifecycle method called component did update. We call this method whenever the component is updated. And by the way, we have two parameters inside, the previous state, or previous props first, previous props, and previous state. So we have these two parameters. Whenever either the props or the state or both got updated, then this method is called. And this lifecycle method can be used to do data loading, for example, update. So for instance, you got some data that you would like to display, and then in the state or in the props you got some results that instead of the first 5 you would like to display the second 5 or the third 5. So this is good for component did update. And then you have a third lifecycle method called component will unmount. So this is the third one, and this is used for cleanup. So the cleanup before the component is destroyed. Typically we have this component will unmount just before deleting a component. So it's like sometimes we have some resources that we claimed. For example, imagine that you're holding some important data that's like 1 megabyte long, and it might be time to just release that data so that our application can use that chunk of memory for something else. In JavaScript, we also have this memory allocation issues in complex applications where you would get hold of, let's say, a large amount of data, for example 1 megabyte in an array of objects, like that REST API call that you saw here. And if you have too many references in the application, then you will have a major problem, like a major problem with the loading with the memory consumption, because you have to free some of these references to avoid memory leak. So this happens sometimes. So we will work with these three lifecycle methods. There are other lifecycle methods as well in React, at least in the current version, but these lifecycle methods will not be that useful and they will be deprecated anyway sooner or later. One of them is called component will mount. So notice the component did mount. It's like this is after the mounting is complete, and the component will mount happens just before the mounting of the component. So for example, here on index.js, you see just before mounting the app to the DOM and the virtual DOM of React, just before that, we would call this component will mount. This method is unsafe, just like the component will receive props. So there is another lifecycle method called component will receive props. We're not using any of these lifecycle methods, at least in my tutorials. Then we also have lifecycle methods like should component update, where we can just determine if the component is supposed to be updated or not. So you get, for example, so here I'm gonna create this should component update, and inside this you will have the next props and the next state. So you get the next state, for example, here, and based on the next props and the next state, you can determine if the render method should be called on that component or not. So this is a condition posed on whether we should re-render the component or not. This is a semi-dangerous operation if you don't know what you're doing, but if you have a resource-intensive application, for example, a day trading stock market app where every millisecond counts and you have to see immediate updates, then maybe, just maybe, it pays off taking more control over the rendering and just ignoring some parts of the application when it needs to be rendered that don't contribute to the results or the stock traders. So this could happen, that sometimes you need the should component update. We're not dealing with it, so I'm deleting this lifecycle method. Then you have the other lifecycle method, component will update. So notice that we're using the component did update, so it's like after the update. This is when we're loading the data, not before but after. And then there are some other methods like get derived state from props and get snapshot before update. So there are quite a lot. So if you type here get, you see even the get snapshot before update is there. Get derived state from props, that also exists, although it's not recognized right now by Visual Studio Code. So we have all these lifecycle methods, but technically if you learn just these two, the component did mount and component did update, you should be fine, because the idea why we were doing these lifecycle methods is that we can just load data. So let's console log component did mount, and this will just send some messages to the console, so we're not loading anything. Here component did update. And let's check what is going on. So we're saving the changes, and we have the reloaded application here. And with right click and inspect, we should get a Chrome Developer Tools in action, so that we can see when these component did mount, component did update console logs occur. So unfortunately I got the Developer Tools detached, so I'm just mounting it to the, or docking it to the bottom of this window. And here you see the flashcards. We also have this warning, this key warning that we're gonna fix sometime soon when rendering multiple elements. But let's ignore this and let's just reload the application and let's check the console logs. So you can see in the different levels errors. We can hide the errors, we can hide the warnings and the infos. Actually the infos we should keep, and we should hide the verbose too. and here you can see the component did mount. With this clear console or Control R, we can just clean the console, and we can also restart. So let's see, navigated, component did mount, so it's happening. And you see, whenever we click, we're not updating the app component because we're just updating the internal display of other components. Here, the main app component doesn't receive new props and doesn't receive new state either. So here, no update happens, only the component did mount was called. Let's see, for example, the component did mount, component did update on individual cards. Here, we can just add these methods inside as well. So in the component did mount, component did update, maybe I'll indent them properly with tabulation. And here, so that we know what kind of component we're talking about, let's get the this.props.frontside at least displayed in the component did mount and in the component did update. So with that, we will know what got loaded. And you can see that all of these cards mount to the DOM one by one, and you see their front sides respectively. Given that we have these like cards twice, the 9 times 8, 2 to the power of 8 and rabbit times 8, these components all mount to the console. So this is kind of cool. Now let me clear the console and let me start changing the front side to the back side. You see that whichever card I click, it updates. So the component did update is called. Here as well, the rabbit times 8 gets updated. Now I'm gonna update the 2 to the power of 8. You see, it's updated once, twice, 3 times, 4 times. So this is how we can see what got updated and when. Alright, so this is the component did mount and component did update. And we could also check the component will unmount lifecycle method if we had a way to remove this card from the collection. So that would also be possible. But we're not doing it right now. We were just checking the utility of this component did mount and component did update inside the card. So now it's the time to use this component did mount and component did update, or rather just the component did mount lifecycle method on the app itself to load some data. And this data is gonna be the source for the card data. So now we're gonna load all the countries in the world as flashcards, with the front side being the country and the back side being the capital city of the country. So this will be kind of interesting. Let's see. So component did mount. After mounting the component, we can create some fetch API. So it's like we can fetch API call. So we can add an API URL here, equals, and this API URL is gonna be this restcountries.eu. So this is just a constant. We can use this as a class property, so you can use the equation sign and everything else here. You don't even need a comma afterwards. You just create a class property. And then we add fetch API URL. This is the fetch API that fetches some data. It's kind of easy to show you how to fetch data. We can just go back to the developer tools. So fetch API works like this. So you have some URL that I have to copy paste, of course, like this. And here we're using a promise. If you need some updates on what promises are, then go to zsoltnoy.eu or to my YouTube channel and check out my video on promises. So there is some ES6 promise syntax video already released, because this is an important JavaScript concept. So we have the fetch and we have a .then afterwards. Promises are things that we promise right now, that for example this fetch is gonna be done sometime in the future, but we cannot guarantee that it's gonna happen right now. So it's like the eventual result. It's like, you know, for example, when you were a kid, maybe your parents promised you some stuff, that you're gonna get some chocolate, you'll go to the zoo or whatever else. And then when the promise succeeds, then, you know, you're taken to the zoo, for example, then we have a callback, and in this success callback, we're gonna just be happy and resolve a fulfilled promise. So here we've received some data, and we have to convert this data to JSON. So this is the .then part. And then once we convert this to JSON, we can console log this data, for example. And then we're done. So let's see what happens. In this case, we retrieve 250 countries. And you see that thanks to the JSON parsing, you have all these countries here. So for example, if you want to know what the capital city of Austria is, then you go inside Austria, and there is some capital somewhere, Vienna, yes. So it's Wien or Vienna, that's Austria's capital. It's also called Österreich or Österreich or whatever else. So you have like other spelling, other country names, and so on. So it's kind of cool that you have access to everything in here. So all the data. And it's also cool that you have a lot of data indeed, but let's focus. So we don't need all these data in here. You have the name and you have the capital. Name and capital are the only things that are interesting to us. So let's transform the data accordingly. So after the console log, or instead of the console log, we can just get the countries and just display the country and the capital. We can do this by defining a function, for example. So function get name and capital. And inside this function, you can supply the country and return just the name and the capital. So return name colon country dot name and capital colon country dot capital. So remember that in the API we had to supply this REST API here, and you have a name, the country name, and you have the capital. So we're just interested in these two keys and nothing else. So we are returning these values in this inner function, and then given that we have access to all the countries here, we have countries.map get name and capital. So after mapping, mapping just executes this inner function on each and every value, each and every country, and we can just console log the result. So there you go. I might write this here, and then after running this, we have a pending promise. It's taking some time, and after the retrieval, you see that we console logged 250 elements. Yeah, it took quite a lot of time to retrieve the data, and there you go. You only have country names and capitals. Now we're just one step away from the truth, which is, let's use this as a front side and this capital as the back side. So now it was immediate, and you can see that now we'll have front side here, back side here. We are very close to actually creating carts. So we can just take this fetch and place it inside this component did mount of the app. There you go. Well, maybe it would help if we indented this properly so that you have everything in place. And instead of this URL, we can just use the API URL so that it's easier. I'm not saving yet because you might have trouble understanding what this map does. So let me illustrate this map for you so that you will not lose track of, oh, what is this map? It's kind of difficult. If you have an array, for example, const values equals 1, 2, 5, for example, and if you have, let's say, a function square, for example, equals the input is a and the result is a times a. Alright, so we're just square every single value. You could also write a to the power of 2. It's the same thing basically, because the double asterisk is the power operator. It's like a to the power of 2. If you want to get the result of applying square of 1, square of 2, and square of 5, so this value is 1, 4, 25, then all you need to write is values.map square. This square is applied on each and every value one by one. This is what the map does. So it maps each and every element of an array to another value, which is now the square of the values. In JavaScript, we typically do these mappings to generate either React components or simple DOM nodes. So we have, for example, value, that's the input, and then we get some DOM nodes, whatever they are. So for example, div, and then the value, and /div. There you go. And this will give us 3 divs, the first one, the second one, and the third one. And if you really wanted to make markup out of this without React, then you would just join them like this. And there you go, you have the 3 divs combined. So this is why we have mapping in JavaScript, and this is a very clean solution, because otherwise, just think about it. So in this solution, here in this get name and capital, what would we have had to write inside? So instead of these, we could have written something like this. So for let I equal 0, I is less than countries.length plus I, and then inside that we would continue doing this one by one. So here we have some const cards equals empty array, and then we would just do cards.push, and here we would push just one element. So we would have front side country.name and, well, backside country.capital. So it's like you would write the same thing, but we still need to know what country is, because we haven't defined a country. So it's like you would write let country equal countries.of I, like this, because here we're iterating and getting each and every possible index out of the countries array. So this would work as well instead of the other one. I will show you quickly. So we could have written something like this, and of course the console log is still needed. So I will still add the console log at the end. So console log cards, could do that, but it's kind of a bit more complicated. It takes a bit more time, so some time until we get the result. We got the same result basically, so Angola, Luanda, and so on. So you see, you can also do iterative solutions, just like here with a for loop, for instance, or you can do recursive. It doesn't really matter how you solve this. What's important is that you get something done. So we have this fetch API here, and after the fetching is done, then we get some data in here, but notice that we prefer not console logging, but re-rendering afterwards, right? But the issue is that once we receive the data, this countries.map, whatever it is, let's call this cards, so const cards. What can we do with this data? That's the question. What can we do? Cannot really go and call render, or we cannot really add this as props to card data. This is not working out. What we need to do is we need to create state in the application. So we will have state equals empty array, and we need to set the state. So here we will add this.state initially, and here we need to set the state to the cards. So this.set state, and well, instead of the state is normally an object, so let's not forget that, cards, and this is a proper state. So here we have to write this.state.cards in the card list, and here we need to set the state to cards. So here we just type cards. Technically this cards is the same as cards : cards, but due to the property shorthand notation, this is the exact same thing in JavaScript as just writing cards like this. I intentionally named this variable as cards so that they match, or this variable because I created this 1 second. So this way we managed to fetch the data and we place these cards on the card list. So let's save the changes and let's see what is going on. API URL is not defined. Why is that? This is because here we forgot to add the this dot. So it's this is a property of the app component, so we need to add the this dot, and now we are set. In fact, we could create this API URL as a prop, and in the index.js we could add this as a property. So for example, API URL or API URL like this equals, and then just supply the API URL, and this way we could even use multiple APIs. Let's make this change, it's not even hard. So we have API URL here, we are supplying it to the app as props, and maybe we have multiple apps. So in app.js, instead of this API URL, we could use this.props.api URL like this. And then we're set with the rendering. And you can see that after all this, we have quite a lot of cards to render. So you see we have all the countries. And if you are interested in the capital of Spain, there you go, Madrid. Now you see that some rendering is not working as well as we wanted to, because some countries are quite long in their names. So it's a CSS type of issue, for example here, that we display these cards properly. So we could just fix the CSS accordingly, make them larger, and so on. So that's something that we're gonna do quite soon. But it's kind of cool that, see, it's already, we did this component did mount. It was that easy to create a fetch and then get all the cards implemented. So let's quickly fix the CSS so that we don't suffer from these long cards. It's a card.css problem. In the card.css we have some width, which could be a bit wider actually, so it's like 225 pixels is kind of good. Font size, we can fix it to something smaller, so font size like 14 pixels, that's good. Not sure what the current font size is, so maybe I just espionage it a bit. The computed styles, and inside the computed styles you can just filter for font, and the font size is currently 16. You can just make it smaller and make the page is wider, for example 225 pixels, that could do, and we'll see maybe it's good enough for the purpose of these cards. You see that there are some very long ones, for example this United States minor, outlying, and so on. So ultimately what would really help is to make the cards larger. So instead of the 50 pixels height and the 225 width, we could just get away with like 175 width, and the height could be something like not 50 pixels, but let's say 100 pixels. Let's see that. And now it works for many of the cards. It's still not ideal in case of some of the cards. Maybe because the second row is not really taken into consideration, because the line height is supposed to be card height divided by 2. So card height is gonna be this, and the card line height is gonna be like 50 pixels. Let's do that. And instead of the card height, we're gonna use card line height. This way we have a bit different solution, but really it boils down to what kind of cards we want to create, because maybe just leaving everything in on one line would help. So we would just fix the card height and the line height to 50 pixels or like 60, doesn't really matter, and here the width will stay 175. Instead of the line height, we keep the card height, and instead of this display that you have an overflow, you could just add overflow hidden, and then you don't have a second row or anything. If it doesn't fit, like Moldova Republic of, or here Korea Democratic People's something, then it doesn't matter. Then we just keep whatever is on the card. We understand South Georgia and this is gonna be a bit negligent, but still, like, what can we do? Now we will just keep these small cards in the Flashcard app. Alright, so now we have all these changes implemented, and we managed to create a component did mount. We had a bug though that is worth fixing. You can see that before we implemented this list loading from the component did mount, or during the implementation, we noticed that there was some errors. So you remember that we did this component did mount for each and every country. Well, there are quite a lot of countries to scroll. And at the very top, there was this error here that we have been ignoring for a while. It says, warning, each child in a list should have a unique key prop. And this is what has been missing so far. So the situation is that in React, whenever we have a list of items, list of components, there is a mandatory key property that has to be added to the cards. Because remember, in React, you give the control away from yourself to React when it comes to rendering these cards. So React determines when these cards need to be updated, rendered, refreshed, and so on. So for React to know when to render something and when not to render something, they need to get a hold of each and every element that you have. And they implement it by using this key prop that we have to add to each and every list item of a list. So for example, if you go to the elements, you see that we have our app. And inside our app, we have the card list swim lane. And inside the card list swim lane, we have each and every card. This is where we need to add the keys. And we need to generate something unique that's unique to the card itself. We could technically use the names, of course, but there is a more sophisticated way of adding these keys to the cards, which we will implement right now. So let's get back to the Visual Studio Code. So we create the cards inside the card list component. We're going to load the card list component first. And you see that this is where the cards themselves are created. So this card and the props. And the props come from these card data. We're going to squeeze the ID in these props so that we can supply it to the cards. Now, how can we create something unique? There are many different options, many different alternatives to do that, because the card data is coming from the app itself. So you see that you have some front side, back side. So this was the original card data that we had hard coded. And then in the last section, we just created this component didMount that set this card data state to countries. So you have the front side, you have the back side, and in theory, each and every card is supposed to be unique. And this is going to be sufficient for using them as keys, in theory. But in practice, it can happen that later, let's say we create a new card with a front side and with a back side. So for example, let's say, when was the War of 1812? And then you write 1815. Not as if it didn't happen to me during high school years, right? Like there was a test, I got this, when was the War of 1812, right? As a question. And I was like, there must be a trick in here. So I was overcomplicating this back in the days because I didn't even anticipate this nonsense question. Anyway, imagine that you make a mistake by creating a card. And then you have to delete the card and recreate the card with the same front side, but the different backside. So front side, when was the War of 1812, and backside 1812. So if you do this, it does pay off creating a different ID or different key to the card that has the exact same front side. So for this, it would be better if we used some ID generator for creating these keys. And this is exactly what we're gonna do. We're gonna use a component called UUID. So it's actually not a React component, but it's an npm package. So here you have this UUID. It implements random IDs, at least in case of the v4. There is this standard called request for comment 4122. If you're into networking, by the way, in general, then you will have to read a lot of these RFCs. I'm right now in the business of developing a React application, so this is gonna be sufficient. So import v4 as UUID v4 from UUID. This is what we're gonna have to do. And if we import this, then all we need to do is just create a new UUID v4 by calling this function. So that's all we need to do. And this will create a very long text. It's basically a hexadecimal number that has like really a lot of combinations. So it's like 3, 4, 5, 6, 7, 8, 12, 16, 20, and it's like 32 different characters are included. Now 16 to the power of 32, that's a very, very large number. So this means that the chance of a collision is so low that we will just go for this UUID, because there are so many different combinations. Each and every character can have 16 possible values, just think about it. And we will have like 250 cards, so collision chance is almost zero. But if you really wanted to go for zero collision, then you could just, well, or not zero, but very close to zero, then you could just make sure that your content is unique. So this means that you would create a representation of your content. So whatever is going to be displayed on the card, everything placed in one key, and then even if you render the exact same key, it would not really matter. Or exact same content, it would not really matter, because you know, what you have on the card should more or less be implied by the key, because, you know, as long as the content is unique per key, we're fine. So we'll have to implement this. So we're gonna create this UUID v4 or just v4 inside not the app but inside the card list, because this is a card list type of property. So this will go to the imports that we have. In fact, this is just a generic library, so we'll just import it here. In the meantime, I'll create a new shell with a plus. So I'm gonna create a PowerShell this time. So it seems like since I recorded the first part on shells, I changed it to PowerShell. I had a Python class not too long ago. Actually, I had to demo how to build a Django application with JavaScript functionality. So this is why you see right now the PowerShell and possibly some Python virtual environment inside. But it doesn't really matter. We're just waiting for the loading. And now loading is complete. All we need to do inside this React dev, so we're inside the React dev folder. I'll just double check that. Let's see. React dev /cards. So we'll have to go inside the cards, the PowerShell, cd cards. It's always important to know where we are. And we have to do npm install or npm I, and it's called UUID as far as I know, but we'll have to double check that. UUID, yes, npm install UUID. So npm I UUID will do. -- save. So we're gonna save this inside our package JSON as well, so that we have an exact version of the dependency. It's very important to encode the exact version of our dependencies in the package JSON, because there are always security vulnerabilities that can end up in the application if you just go with the latest version all the time. It is a big thing. So the only security that you can have on this in this UUID library is that you can see that 29 million people download it on a weekly basis, and there is a continuous uptrend since 2019. So this means that if there are so many people using this UUID library, chances are that they are not going to start stealing your sensitive data and transmitting it to some third party through Ajax or something. So this means to you that you can more or less not advise in general, so don't rely on this, but more or less it's more trustable. This UUID is more trustable than some random package that has like 10 downloads in total. And you can see that there are quite a lot of different things fetched while installing this UUID. And while UUID is being fetched, we can simply add the new ID as well. So here we need to add key equals, and then putting the UUID in braces would be correct. And these stand for just spreading the props as comma separated values. And inside these components, JSX makes it work that we can just spread the props like this. So now we have the key for the UUIDs and the card list. In the meantime, there is still the installation of the UUID v4 going on. This will help React determine whether a component should be re-rendered or not. Because if the keys match and there is nothing new happened to that specific component, then React might even cache the previous DOM node and just reuse it whatever the markup was originally on that specific node with that specific key with the UUID. So with this UUID, we're just busting this caching mechanism of not re-rendering some components whenever React thinks that there are no changes. So this way we can create unique keys to unique cards, and this way we can always make sure that the cards get re-rendered. Alright, let's just wait for the loading of this UUID v4. It's indeed taking quite a lot of time. Technically, we could get away without UUID v4 because we could have just written something like front side. So we have props.frontside. We'll just place it in here. So the key could be a backtick props.frontside dash and props.backside, like this. And this is just a simple template literal which makes the cards unique because both the front side and the back side are included. Technically we could make a hash out of it, like a hash number that is based on this front side, back side, and it's gonna be unique content as well, and possibly shorter because we saw that we have very long country names, for example. So let's just remove this UUID for now. Now you can see that the key was specified here and the card component. So these card components align like on top of each other. So these cards are siblings. And whatever is inside the card component, they don't matter from the perspective of React. So we don't really need this key for proper re-rendering reconciliation. So this means that, that we only need to add the keys here. In the card component itself, you can see that here we have the class name, the onClick on the card component. Here we don't need a key. So we can get away without adding a key to this div, even though in the actual markup, these divs will be the real siblings in the real DOM. So these will be the real siblings in the real DOM. We will still not need keys to them. The cards are the real siblings in React's interpretation because there is a real DOM with the divs and there is a virtual DOM with the card component. And for the key, we only need the virtual stuff. So let's see that if we reload this React app after saving, we're gonna check the errors only. So here we have only those errors that are there, and this key error message is gone. So once again, if I delete the key, so front side, back side, I'm just gonna delete it, save the changes, then you will see the error reappear. So it's a warning in the form of an error. That's why we display it in red, that you have to have the unique key. But as soon as you supply something unique, then you will get the response back without an error message. So there is one more thing actually that many people are tempted to use, just an index. Because, you know, in case of map, you can have an item and you can have an index. And you might think like, why not just use the index here? So we could just add the index here as a prop and don't even care about the rest. So you just have the index. Now, technically this will work. So technically you can see that the application is still rendered and we're not getting the error from this key. You see this runtime last error got submitted, but this other error is not there. But the problem is that this props and index depend on what we receive from the API, those 250 items, the cards. And imagine that we have a feature to add and delete items. So you add another card, delete a card, and so on. And then the indices will change. So for example, if we delete Afghanistan, then we remove the 0th index item from the list. And this will mean that the second card, this Aland Islands, will become the first card with the index 0. Now this is gonna be a big problem, because with the index 0, we already registered an item called Afghanistan. So this is not gonna work anymore if you have deletions. Same holds with insertions. Imagine that you insert another card in the middle, so for example in position 6, just before Andorra, and that would have the key 5, because we have like 0 is Afghanistan, then this is 1, 2, 3, 4, 5. Now instead of Andorra we would have another card in position or index 5. Then React would think that as soon as it sees the key 5, that we need to render the Andorra card. And then this would not work. So this is why you need something unique in the key. And you also need to make sure that it's not only unique currently, but throughout the whole life cycle of the application. So from mounting till detachment, the keys are gonna be unique. This is why it's not that easy to create IDs or keys to these sibling elements. And this is the reason why I recommended using this UUID v4. So using the v4 UUID v4 function is also a perfect match for a key. So instead of the index, add this UUID v4 call, which returns a string in general, so we don't really need these template literals and the insertions, so I will delete that. So these 3 characters, and I'll save the changes. So let's now see the v4 UUID solution. So you can see that here the key is UUID v4, and as you can see, the cards are rendered. Now let's check the console once again for errors, and let me show you that I'm not cheating, of course. And you see that the key error is not there anymore. So this means that the UUID v4 just does the trick. Now, even though I refresh the page and you cannot see the error, there is obviously a question of where can I see this UUID v4? Because obviously you go to the elements, you see the app header, and so on, and you see all these cards, but the UUID v4 is nowhere to be found. Why is that? Well, it's because here you only see the real DOM. And I've been mentioning this React virtual DOM for a while, and you have never seen this virtual DOM in action in reality, and this is the only place where you would access the UUIDs, and it's not happening right now. So what can we do to see that? The easiest way to see this virtual DOM in action is to install something called the React Developer Tools. It's a Google Chrome extension, so you can see that it's in the Chrome Web Store, and there are more than 2 million users, by the way. And this will show you the virtual DOM. So you see that there is a DevTools in here, and here you see this app header, to-do text input, and so on, in case of a to-do app. This is what we're gonna add, and we have to add it as a Chrome extension, so you just click the blue button, add the extension, and after the installation is done, you will be able to see this UUID as well that got created. So you see that the React Developer Tools has been added to Chrome, it's on the top right, and you'll be able to use this Chrome extension now. So let's turn it on. Let's reload the page. You can see this dev tool in action. First of all, it figured out that we're using the development build of React and not the production version, so it's already quite smart. And after restarting the dev tool, so you have to close it and open it again. After restarting it, you will see on here the components and the profiler. Let's see the components. And there you go. Card2 key equals this. So here we have the UUID accessible. So you see the card list JS source rendered by card list app, and you have quite a lot of different properties available, and you can even click and you can see that, for example, we're talking about this card. You can see its props, its state, rendered by, and source. So quite a lot of things. You can also copy paste, and this is a big help because here you can see your whole application structure. You can even navigate it, and here you can see all the UUIDs, everything. Now, if I changed this UUID v4 to back to, for example, some props.frontside plus props.backside, I could use that. So let's save the changes, and it's going to reload the page. Then you can see that the keys are going to be, for example, Albania Tirana. There you go. So this is going to be our unique key for the cards. but we're fine with UUID, so let's not destroy what has been working in the industry for a very long time. So we're just gonna use the UUID v4, and then we're set. We have the keys included, and with just a hover you can see the complete 32 or 30 character long UUID. So this will just do it. Let's see the console once more. We still have this message port closed before a response was received. Error. You don't have to worry about this. The most important thing is that the key error is gone. And at the same time, we also managed to install this React Dev tool. So once again, you can see the components here. You can even see the props, the card data for all the 250 elements. And well, besides that, you can also you can suspend this component, for instance. And you can also do logging. You can view the source code of this element, so you can see what's going on inside the render and so on. So navigation wise, you also have quite a lot of options. And then profiling, for example, you start the profile, and let's reload the page. Profiling also works, so you can also create some information on how your application is running. So for example, I flip the cards and I stop the profiling, and then you can see what happened, what got rendered, how much time rendering is taking, and so on. So React DevTools is another useful tool to develop software, but right now we're just focusing on visualizing the UUID, so that you can see what kind of props, what kind of state, and so on we have. You might remember that not too long ago we created this component didMount function, or method to be exact, because this is a member function of the app class. Now, this is the main reason why we have to make app a class component. So normally this was supposed to be a functional component, just like any other components that we have in React. Given that the lifecycle methods only work in case of class-based components, this is why we had the app as a class-based component. But as you might already suspect, we can also create these lifecycle methods in functional components. Now, technically, it's not lifecycle methods like component didMount and so on, or component didUpdate, component will unmount, but it's a React hook, just like the useState hook. So this is what we're going to introduce now, and I'm going to just create a function. So just like in the previous situation when we had like app and app2, I'm going to create an app, which is going to be function app, and we're going to just return the markup like this, which doesn't really change except for the this.state.cards, which we will have to model in some ways, because initially we have the cards. So here we're going to do the same const cards set cards equals, and then we will have to add the useState. So next to the component we could get the useState as well from React. So why not use the useState? Once again, it's react.useState, but we can destructure React so that we take the useState out of it. So now we have the cards modeled as a state variable, and we can just add these cards. Now this is great, but it's not enough, because we also have to get this name and capital cities using the fetch API this time. So we're missing the execution of this fetching. And we don't have a component didMount either. So instead of the component did mount, we have something in React that we call use effect. Use effect has the following syntax. We write use effect, or react.useEffect to be exact. So first of all, we have to import it, and it's going to be a function, just like the use state. We have use effect. You see that it's even available in here because React Visual Studio Code IntelliSense understands that this is what we need, the use effect. So use effect has a function callback. And this function callback is called. So function callback is called in the exact same situations when those three lifecycle methods are called. So right after the component did mount, and the component did update, and the component will unmount. And now you may ask that if this function callback is called in each and every situation, then what can we do? Like, how can we differentiate between these three cases? Because here we have the number 1, number 2, number 3. And this use effect seems to be like 3 in 1 so far. This use effect hook seems to be a bit strange. Now, what can we do? And the answer is that we can simply model the state, and we can differentiate between the three by making sure that we keep the state updated and know where we are in the life cycle. So for instance, we know that the first time this use effect is called, this is gonna be a mount call. In each subsequent call, so whenever we are done with the first call, it's either an update or an unmount operation. But in case of the unmount operation, we don't care about the state anymore. So it doesn't even matter if we're gonna unmount or if we're updating, because technically we don't need much cleanup anyway. As long as we can formulate our state changes in such a way that we still change the states even if we are about to unmount, and we do the cleanup after ourselves properly each and every time when we update, then it won't matter that we do an update or an unmount. So this is gonna be the same situation. So all we need to do in case of a differentiation is to figure out that in this function, are we doing mounting, mount call for example, or if it's not a mount call, then it's an update call, update or unmount call. This will be handled in the else. And given that we already have some states, we know which is which. So for example, suppose that we always have at least one card, then if we say cards.length is 0, then we are on the mount call, and then we have to load the Ajax call. So for example, like this, we're fetching the same data, and notice that it doesn't even matter here anymore whether we're on a mount call or we deleted all our cards, because our action is going to be the exact same thing. This use effect basically makes React developers think in a way that it doesn't matter anymore whether we're mounting or whether we're in the same state as if we were mounting. So now we're concentrating more on application logic with use effect and not on where we are in the life cycle. This is key, because as soon as you experience this paradigm shift, you will write applications that will work regardless of where we are or what our components are doing. This is one solution. So if we're mounting, we're doing this. Otherwise, we're doing nothing because our implementation for component did update was nothing. So this is our implementation for this code segment. Now, If you have a generic situation and you want to differentiate between case 1 and case 2, then you would create a const is mount call, for example, and set mount call equals useState, and initially it's gonna be true, because first we're gonna do the mount call, right? And then you'll go to the mount call, so is mount call. Then you'll do your component did mount actions, and then you'll set the mount call state to false. And with this setting this mount call state to false, this is the last time that you could access this if branch. And if you're done with this, then you will only do the component did update or will unmount. This is the difference, and this is how you can create a generic use effect call and differentiate between the mount and the update or unmount. But basically we don't need this, so I'll just revert the code to the previous setting. So when you have the cars.length equals 0, so we're deleting the second state as well. And well, we needed the cars.length equals 0, and inside this cars.length we're pasting this fetching. So with the use effect and the cars.length equals 0, we're creating this JSON that loads the names, country names, and capital cities, and then we return the results. So we're gonna save the changes. Notice that we're naming this function an app, so we're exporting the app, while we renamed the original class-based component here to app2. So now we're only using the functional component. You can see that at the bottom you have some unused variables. Here card doesn't matter because there as well we had card and card2, and I think card2 was the class-based component. Maybe just for the sake of understanding where we are, so card class-based, card underscore class-based, and you have card underscore functional, and we'll just export the card underscore functional this time, okay? So that you'll see a fully functional solution. Both the card-based and the functional is gonna work, and you can see that now it's missing the card underscore card-based or class-based because we're not using that. And in the app as well we can do this, so function app underscore functional. This is with useState and useEffect. And the other one is with class-based, so app underscore class-based. And obviously we're just exporting the app underscore functional. So we can revert between the two words, it's not a big deal. This time we're using the functional component and useEffect. Now we still have some other variables besides the class-based and functional. So card data is not used, it's fine, because with our default hard-coded card data, instead of that, we were using our countries and cities, capital cities. But we have this set cards. This set cards is currently an unused variable, and you can also see that it's darker. This signals that we forgot something. Namely, that we had this set state in class-based components. And you remember that in case of hooks, React hooks, when we have the useState hook, we need to use the set cards instead of the this.set state. So we'll use set cards, and we're not calling this with the cards key, so we're not using an object and cards colon cards like in the this.set state, but here we're storing the array directly. So we're just creating these cards, and that's it. So now we managed to change this, and we're just using this setter. And you see that this error is now gone because we are using the set cards properly. So React useState hook setter method. Let's see if our application is working. You know, there could always be an error. So cannot read property props of undefined. That's an error already. So API URL was a prop. Yes, because originally, if you remember, we created this index.html with an API URL, and we don't have the props anymore. So we have to give this to the functional component. This is something that I forgot. And here we have the props. And instead of this.props.api URL, we just have props.api URL. Yes, in general, whenever you see this dot, so if you see any this dot inside the functional component, this is a warning that you need to make a change. So saving changes, and you see that how easy, how smooth React development is, because the error message exactly told you where the problem lies. So now we have the countries, cities, they are loaded thanks to the use effect hook, and everything is working as expected. So we have both the functional component and the class-based component solution, they are both working, and we can mix and match the two. So it doesn't even have to be functional in both cases, because the two are basically almost equivalent. From the perspective of writing this code, they are the same. So you see that the flashcard app is now working better. So we have seen how to load cards from an API, and basically we have a full-fledged application with the exception of adding cards and deleting cards and possibly modifying its contents. But for now we're just gonna focus on implementing adding and deleting. Now if you want to add cards, you can see that for example here we're missing a form where we would be able to add the front side and the back side. That would be required for a full-fledged application, right? Also, these styles don't look that good, so we might do something with them because it's still missing. You know, whenever you create an application, at least going the extra mile in terms of styling is always desirable. So let's open the app.js file, and well, I'm gonna make some room for the app.js. So let's open this. And here you can see we have a functional and a card-based component. We're still developing the two in parallel so that I can show you how the two components compare with each other. So let's see what to do. First of all, we need to import a new component. Ezt kivágjuk. So we would like to add the form. Where can we add the form? Here we have the render. Inside the render, you have a header and a card list. Now, if you wanted to add the new form, it would make sense adding it in between the header and the list. Let's call it cards form. So that's gonna be our new component. Obviously, same holds for the functional component. So sooner or later, I'm gonna just delete one of them because now there is not much to take away from the class-based and functional components. With use effect, we can now load data from the API, and we don't need the component did mount lifecycle method anyway, so you still have it for comparison but not for long. Also the default values, I mean, they are unused right now. You can see that their color is not flashing as blue, as light blue as the other variables, but for now they don't hurt. Maybe we will reuse them later. But what's important is we will need to import this new component, import cards form, so that's gonna be the component name. And where are we gonna create it? Well, from /components /cards form /cards form. I'm just using the exact same pattern as before, and for that we will need to create a cards form folder here in components, so new folder, and it's going to be called cards form. And inside the cards form folder, you might want to create a cardsform.js file. So this is going to be our new JavaScript file, and well, it's going to be a completely new component. So let's see what we have to do to create this component. First of all, we need to import React from React. You might know this already. This is usual. And it might make sense adding a CSS to the cart form, because this form is going to be a component. So components have styles that are included. So new file, carts form.css. All right. So carts form.js, carts form CSS. We're going to add import carts form.css. Obviously in quotes, I forgot that. And now it's working. Notice that the React is not used yet, but as soon as we create function carts form props and we return some markup where we use some JSX, so form and /form, the React flashes, because as soon as we write this JSX, we basically use react.createElement, if you remember. And if you use React, then this React is not an unused variable anymore. So we're using this variable here. We're going to return a form. Let's see what we'll need to define the form. It usually has some action. It doesn't matter what it is because we will cancel it quite soon. So I'll just add the hash mark. Maybe I'll need to change the keyboard layout as usual. So hash mark. And it's worth canceling the submission action. We can do it with an onSubmit equals handle submit. Handle submit. And let's see what we can do with this handle submit. We can create a function handle submit, and this has an event. I just abbreviate it with E. E stands for event. And we have to prevent the default action of submitting the form. If we don't do this, the form is going to be submitted as soon as a submit button is clicked. So for example, if I added input type equals submit, this is a submit button, value equals, for example, submit card, and we'll add some class, like class name equals submit button. Then you will see in the rendered application, once we save both files, so both the app and the cards form, that submitting the form won't do anything because of the prevent default. So loading the React app. Oh, and we have to export the cards form, obviously. So export default cards form. So that's missing, but not anymore. So we are waiting for live reload to activate itself, and there is still a problem. The problem is because we forgot the dot slash in the cards form.css, and after loading the page with live reload, now you can see that we have the submit card, and we also loaded all the countries just like before. Now if I press the submit card, nothing is happening, you see? So the reason why nothing is happening is exactly this line, this prevent default. So if I comment this out and live reload takes place, we're waiting for live reload to happen. After the live reload, we're gonna press submit card. So we're pressing submit card now, and you can see that we redirected to this hash mark and the page got reloaded. This is because the default action of pressing the submit button is to submit the form. When we submit the form, we redirect to the action, which is a hash mark here. So React redirects us to this question mark hash mark. Now, this is because there is this query string routing enabled in React, so that whatever we do, we only place the action after the query string. So this is important because it doesn't affect the server-side routing. So for example, if you change a URL to something else, then it would normally affect the server-side routing as well. So first the server would figure out what kind of page to display, and with that we might navigate away from our React application thanks to the server. You can write this server-side routing, for example, in Django or in other server-side frameworks, and this would interact with React. Especially if you deploy your application to GitHub pages, for example, which you can do. This routing is going to be very important, that we don't interact with the router without this query string or hash route, because otherwise the React page would just not work, because GitHub Pages has its router, so you know that's important that we don't interfere with it. All right, getting back to the application, we have our submit button already. Maybe here in the form we might want to add the class like form container, so that later the styling is gonna work fine. And now I'm gonna create two input fields. So first, let's wrap them in labels, and inside the this is gonna be the front side. So this is inside the label, and there is an input. It's gonna be type equals text, and placeholder equals front side. So it's the same information as the label text. And well, let's add the class JS front side. Not sure if you'll need it, possibly yes. So that's the front side, and we'll need the same thing for the back side, except that we will need everything that's like label and input field, and we'll just replace front with back. So back side here, here, and also here. So this is gonna be backside as well. And now we're set. So we have the front side, we have the back side. Maybe let's add some handles. So for example, this is gonna be text field input, but you see it's kind of long already. So in this case, we can just reformat our input field such that these attributes are below each other. Same holds here, the other input field as well. It can also be reformatted. So we have the class name, and this way we can add the text field input without compromising readability. So we have front side, back side, all the classes are there. Maybe adding some classes to the label. So class name equals text field container, that could help, because we will soon style all these labels and input fields and so on. And I think we're set, we're more or less set. And we also have the event handler. So this is great because we already set up the event handling. Whenever we submit the form, we're gonna read the values of the input fields. It's input, by the way, not input, before starting the rendering and everything. And now let's see what the form looks like. We have the front side, the back side, also the input fields, they also work, and the submission. And the submission doesn't do anything. So you see that the text is still there, it's not cleared. And well, we have the labels, and the submit card doesn't submit anything, doesn't do anything. All right, it may be time to open up the CSS file, the cardsform.css, and start designing these cards. So you can see that we have a form container. This is the top level form. So dot form container. Let's see what we can do with it, because right now it doesn't look that good. You see that there is no space around it. There is absolutely nothing. And whenever you design, the best thing to do is to design for small screen sizes first. You remember that the minimum width that we have is 400 pixels. So here you have, if it's too small, this page, and it's less than 400 pixels, in that case there is going to be horizontal scrolling. So maybe I can show this to you by docking the developer tools to the right. So you see that if we have less than 400 pixels available, then there is an override, and then we're gonna go to 400 pixels at least, and afterwards the sizes change. So this is gonna be something that's gonna be helpful, which means that even in the worst case or the smallest case, we will have to design our form such that this minimum 400 pixels is respected. Otherwise you would have some weird form design here. So this means that I'm gonna just fix the width of the form to 360 pixels, something smaller. Maybe add some margin. So for the top and the bottom margin is gonna be 20 pixels, The left and the right is going to be auto so that I can center the form. And well, we're going to have a border, 3 pixels, double dark green, that should do. Double border, let's see what it looks like. In the meantime, in the background, you see that now we managed to design this form. It's properly centered and it looks alright so far. This double border is kind of good also for the cards. Later I might reuse it because it's basically good for a card. And then let's add some padding as well. If we have margin, we also have padding, 20 pixels. So the idea was that 360 pixels is the width, and we have 20 pixels more for the left and the right padding. Well, give and take 1 pixel, because here you see that we also have border around. Or actually it's 3 pixels, so the border is a bit thicker than the swim lane, the container of these cards. Alright, so this is the form container. Next up, we could do something with the input fields and the labels. Let's see the classes, the corresponding classes. We have, for example, the text field container, that's the label. So let's continue with the labels. So text field container, we can make the width 360 pixels too. The height could be something smaller, like 40 pixels. Line height, so that we center it vertically, 30 pixels. Font size, let's make it 20 pixels, and we're gonna add some margin to it. So margin 10 pixels to the top and bottom and 0 to the left and the right. So let's see after the changes what happens. Reloading is done, not much so far, just the front side, back side is here. But the issue is that these elements, these containers are not positioned properly. So maybe making this a flex box. So display flex, and then wrapping them. So flex wrap, wrap. And we're just gonna have one element in each row of the flex box. So that's gonna be simple. And well, let's say that's gonna do it. So after reloading, you see that the front side and the back side are spaced out properly. And then we have the submit card on the left. Now comes the input field. So we're gonna check the cards of the or the styles of the input field, the class handle, text field input. So let's add text field input, and we're gonna have to add some background color. Background color colon. So let's do control space here, and here you can see that you can select any color, or you can also do the RGB or RGBA. So if we do RGBA, for example, and we hover over this red, then we can start checking what kind of colors we want. So for example, some greenish, some very light greenish color, this will do. And possibly the opacity as well. So if you did it RGBA, not just RGB, then it would work better. These parentheses are unfortunately there because of the code generation. So RGBA, and there we need to add some opacity, like 0.75 will do like 3/4 of opacity. Then the background is gonna change in the text fields, you see. So now we have this semi-opacity or semi-opaque RGB, and if you change the red, the green, the blue, so for example it's 203, like 236, I'm just making some small changes. Let me show you what the changes are. Then you have some different tone, like just like minimal changes. Okay, so we have the background color set. We can also change the color to something dark, like let's say 323232 is gonna be good. See, it's kind of a dark gray color, and it's kind of cramped. The text is kind of cramped, so we can add some line height to it. For example, 30 pixels. let's increase the font size. If there the font size was larger, like 20 pixels or something like that, yeah, 20. Here we could have 18, but we could also have 20, it doesn't really matter. We'll add some more padding. This is important because of the left and the right, so left and right padding are not influenced by line height. So you see that now everything is a bit larger. And after the padding, we could add some border, 3 pixels. Well, we can use different types of borders. You see inset, for example, or we have this ridge. And well, some green would do, or lime. Yeah, lime green, that's good. So 3 pixels, ridge and lime green. And let's make the border a bit rounded. So we'll add border radius 3 pixels. Let's see the results. Great, so we have some sort of a border. Cool looking for the text field. And maybe we could do something with the hover state as well, so that once we move the mouse cursor over the input field, then it changes color, changes some other features. So we still have text field input, and with colon hover, we can add the mouse over effect. So it's all about checking what we need to change. So for example, background color and color could change a bit. Or actually we could make the border a bit lighter or the other border a bit darker. And the rest can stay. So border radius is the same. It's important that when we add hover states, we should not change the dimensions of the component unless we add an effect, some sort of an effect. Because if you change the dimensions, then it will start moving up and down or left and right whenever we put the mouse cursor over the component. We don't want that, it looks like a glitch. So let's do something with these different colors. Maybe it would make sense making a change to the opacity. So let's see what happens if we change just the original one. So instead of lime green, you would have something else. So let's see, different greens, something darker. Yeah, that's good. So that's a different type of green, and then we have the background color, and technically we don't even need the color, so we can just get rid of it because we will still need to type something darker there. So we have the hover state. You see that everything is a bit darker, and once we move the mouse cursor over it, then we have the lighter color. And the reason why I did it this way, so I darkened the original state, is easy. We don't want this any lighter, because if we do this even lighter, then it might not be pleasing to the eye. Let's style the submit button as well. So that's our submit. It also has a class name. So .submit button. And we will have to do some things with the submit button too, so that it doesn't look like the default button style. So first of all, the font size is small. We'll make it the same as the font size of the text field, like inside. Line height as well, so that they match. And we'll add some padding. Or let's make it 10. Color. Let's see the color. So we don't need any transparency, so we'll just do RGB. So we're gonna delete this. But we can make some changes, so we can increase, for example, the greenness. Let's add some font weight. And let's see what it looks like. So it's very hard to see it right now because you don't have a background color. Let's use some background color that we already have, for example this lime green. So background color lime green, and now you can see, yeah, that's kind of okay. The font weight is a bit too much. I'll decrease it, for example 500. Yeah, maybe it looks a bit better. Then we'll make it rounded, so border radius 10 pixels, some text shadow, 1 pixel green, so that we have it on the bottom right. Yeah, this is a bit more button-like this time. And we might need to add some padding, especially on the left and the right. So padding, the top and bottom, let it be just 7 pixels, the left and right 15 pixels. Cursor, pointer, it's important. Yeah, more button shaped. Maybe the letters, especially with this text shadow, are a bit too cramped. So adding some letter spacing, just 1 pixel will do. There is just one thing I don't like, this is this distance between the colon and the input field. So adding some margin to the text field input would make sense. So margin, and we're just gonna add 0 top margin, and we're gonna add 0 top margin and 8 pixels right and left margin. Let's see how this influences the styles. So saving changes, and the page got reloaded with some better margins. So you see that we're basically set. With the submit button, we can now move forward. And also, if the screen size was larger, our design would still hold, it just stays in the middle. So even on full screen, see, the design stays in the middle. If we had more forms, then we could make some changes. Okay, so now we have some better styles. Let's continue with styling these cards as well, because they are quite simplistic and also sometimes incorrect. Just notice that in Congo, for example, democratic, and then there is some other text that we are not displaying right now. So we're gonna make some changes to the styling here. So after the form styling, we would like to see something better for the cards as well. So now we're gonna load the card component. As usual, we're gonna start with smaller screen sizes so that it works also for mobile, in case someone visited this app on mobile. By the way, it's also possible to do mobile development in React by using React Native. The difference is that instead of React DOM, you include another library. So let's see the cards. So we need to open the card.js and card CSS. There you go. So we have the card CSS here. You see that we have one variable. Technically we could have done variables in the forms as well. I just avoided it. Possibly I didn't even think of it. But as soon as you create larger applications, these variables are really helpful. So one example for creating good variables is that imagine that you have some card height that's already there. Why don't we have the card width? We'll see that a bit later. Whatever it is right now doesn't matter. I just add some dummy values. So afterwards we could have, for example, a font size in the card. And this is important because once you change the variables, if you include multiple variables in the CSS, you don't have, first of all, you don't have to look for them, and second, after the change, everything will stay consistent. So that's one change that I would like to introduce, that I'll add at least these 3 variables for illustration. The other one is that here we have this card, and now I'm mainly gonna take care of the functional component. So from now on, I'll stop supporting the class-based component. Maybe I'll delete it altogether. At this point, it's not too helpful. I'm just commenting it out, and this is gonna be our main card component from now on. So it's gonna be the export default card, or we can just put the export default after above it, like in front of the function. So we have these cards. There is an issue, there is a problem, which is that the structure doesn't make much sense like this. Because here in the card, we don't have any visibility of what's going on. You see that we have a default card class name, but the card cannot see if we are on the front side or on the back side, because the front class list and back class list with this hidden and the card front card back is only added to the children. And this is a problem, because if we want to color the cards like green or yellow, then we have to know it on container level and not on the content level inside, because we cannot vertically center the content and squeeze the content with proper line height. This was basically one problem when we had multiple columns. Let me delete the overflow. So there was an overflow hidden here. If we delete the overflow, then you see that in case of some cards, not all cards, but some cards, we will run into issues. And these issues are here, for example, on front side, that you can see the second row, and the line height was influenced for the whole card. So it's not a brilliant idea to style both the front side and the back side to be full height, and then just squeeze everything in, because then we would need to add another container inside this container, just for the text, so that we can squeeze the text inside. We can avoid this by adding proper classes. We could add, for example, a card class list. So const card class list equals, we'll use our usual template literal, we'll add the card class here, and our usual expression is front, question mark, and if it's front, then we'll add card, for example, __ front. Otherwise, we'll add the card __ back. This will be helpful because then we'll detach these front and back classes from the front card list and back card list. And here we can uniformly treat it card __ text here and here. And then this will be a sane change, because now the coloring information and everything else is gonna be linked to the container div. So this is gonna be the card class list. And let's see what else do we need. So we have the front class list here, the back class list here, front side, back side, that should be alright. So there we don't really make many changes. Just the separation is important, that the front or back is a property of the container, not a property of the child component. It's interesting that it's still rendering something, even though we will need drastic changes in the CSS. So let's see what kind of changes we need. First of all, I kind of liked this double border. So this 3 pixel double, that was a great border. And let's see, some sort of a green. Yeah, is there something like dark green? So dark green was the color I think that we used before. So these double borders will look good. And now we're gonna remove the inline block on the cards. Whatever we can remove, we'll remove. So for example, list style type, it's here by accident because now it's not even a list, it's now a div. But you know, we didn't validate CSS in any ways, it was just there. For the width, we could use the variable, so var card width. And let's create some proper width, so larger width could do fine. So let's do, for example, 225 for the width. And we can have a larger height as well. I mean, 225 and 50, it's not too much. 125 would possibly look better. So width 225, height 125, we'll see. Adding some border radius could also work. Double the border. So let's see what the changes look like. Done. So the double border looks okay. Maybe we'll make it a bit more card-like by adding a radius only to 2 of the borders, not all 4. So this means that this is squared, and these 2 are rounded. We can also do that with border radius. Then we have the margin 10 pixels that will keep, also the padding. The width is already there. We also have a font size, so card font size or font size. This is gonna be a variable. And then we'll keep the cursor pointer, the user select none, that's also important. And there is just one thing missing, because to make these cards a bit more realistic, we could add some shadows. So box shadow, 0, 5 pixels, 10 pixels, 0, that could work. And some gray color, so RGBA, for example, 25, 25, 25, 0.2, that should do the trick. And you see that now these cards look a bit more three-dimensional with this background. It's as if it was a real card. All we did was just adding a shadow. We can also add some shadows for hover styles, so card colon hover, we were missing this. And we can modify these box shadow styles here. So instead of 0.2, we can add a bit larger, like 0.4. Let's see what happens if we add this after reloading. So you see that the highlighted card looks a bit better. Now comes the change that instead of card front and card back, we now have card underscore underscore text, if I'm not mistaken. Yeah, card underscore underscore text. We'll add card underscore underscore text. And we'll also add some padding at the bottom. And the line height is gonna be not the card height, but the font size. The padding is top and bottom, so right and left padding, we're not gonna add anything. With that, we have some smaller cards. So you see that now we're taking control over the text as well. So the card text, we have the width, the line height, everything set up. And if we want to vertically center these components, let them be one line or two lines, we can also do it. So here in the card, we can add display flex and align items center. With that, everything is centered vertically, at least. If we scroll down, here you can see United States minor outlying islands. And it doesn't even have a capital city, it seems, so it's empty here. Great. Let's make some changes to the container. Here you see that we still have 2 cards like this, 3 cards like this. We can also make some changes to the card list CSS so that we have a bit more space. Here in the swim lane, width, we can make it a bit larger, like 80%. Let's see what happens then. We got back the 4 cards. And also it's a bit cramped, so we could add some padding as well. So here after the margin, we'll add a top and bottom padding at least, so 30 pixels and 0. Done. So this was a small exercise on styling, because in React we also need to do some styling work sometimes, or we use a component library where all the styles are prefixed. That could also work. That's also an interesting topic, maybe a topic of another video or the in-depth course. And well, until we do that, now we are fine with the current values, so the current styles. We have cards, they can be multi-line, and everything is centered. The only thing I'm missing actually is, you see here in the Congo, for example, that we could add some padding inside. So also horizontal padding inside the card text. So we're going back to the card.css. Oh, the font size, there was an error here, so now it's corrected. And let's see the card text. Maybe adding a full padding, so not just top top and bottom, but also left and right could do. Because you can see that here Congo Democratic Republic of the, it's now styled a bit better, and we're not writing to the very end of the card. Alright, we're set with the styling. It's good enough for now. Let's continue with introducing a React concept called controlled components. Controlled components give us the promise that at any point in time, the state of the component maps whatever we enter in the input field. So we can enter this at any time, like we can enter text at any time, and the state is gonna map it. We can also query the state this way, and regardless of whether we change the text or we change the state, the other is gonna be updated. So controlled components can be controlled by the outside by changing the state of the application. They can be controlled by the user, they can be controlled by the parent component, they can be controlled in many different ways. So these multiple indirections, so these multiple paths of controlling both the component's value and the state synchronized, make sure that we will never detach the component state from what you can see on screen, while not compromising the functionality of the input field. So this means that the user can still continue entering, manipulating things. Let's see what this looks like in practice. Controlled component. So we will need the card form here. And given that we have two fields, one for the front side, one for the back side, the best way to handle this is to add states. So const front side set front side equals, and here we have a use state, so we can add comma use state as import, and now I'm gonna write use state and initially empty string, because initially we don't have any values that we display on the input field. Same holds for the backside, const backside set backside equals use state empty string. Notice that in case of use state, so React use state hook, we can have multiple hooks. It's better to have multiple hooks oftentimes than just having a use state. So we could have done const state set state equals use state an object like this, and then we have the front side, which is an empty string, and the back side, which is also an empty string. So we could have done that, but the problem with this is that this set state reminds us of the set state of the class components, and then as soon as we do something like set state, and let's do backside empty string, this would be the default. You know, when we have class components, we would just write this dot set state. In functional components, we have access to the set state, so no problem with that. So the problem with this is that it won't work in the same way how we imagined it to work in case of set state. I will illustrate this with an example. So first of all, let me finish the original thought process, and let's not interfere with this set state. This will come later. For now, let's accept that we separate the variables, and for different state variables, primitive values, so atomic values, we have different use state calls. We will see the dangers of having the same use state call soon. Just for the sake of the controlled component, let's alert some message. So we'll alert the front side and the back side in JavaScript, so that we know what's going on whenever we press the submit button. So for the text, In order to make this a controlled component, we can add the value to be front side here and the value to be back side here. Backside. This means that initially the value is gonna be empty, but if I enter something else here, for example flash, let's see what happens. We're saving changes and we'll wait for the live reload to kick in. You can see that the initial value became flash. And we cannot even change this value for now. And we cannot change the front side either. And also if we submit, then we only see the flash because this is empty. So now that we changed the value, front side and back side, this will continuously be front side and back side. This looks dangerous, but only until we add something else. So we need to add the change handler to the input fields on change equals, and then we have handle front side change, and we can handle the back side change as well on change equals handle backside change. Let's save changes. You can see that we have to create the functions first. So first function handle front side change, and we have an event here. These are inner functions, these are all accessible, and we can call the set front side setter. And whenever we don't use the old state, so normally we have old state and then the new state as a function of the old state. But whenever we don't need the use state, we can also add the simple value. We don't have to add an arrow function or any function to set the front side. So now we need to get the value. It's going to be event.target.value. There you go. Set front side event target value, or even better, event.current target.value. And the same holds for the backside. Function handle backside change. The rest is gonna be the same, except for this front. This will become back. And we have event.current.target.value. So this setter is gonna make sure that we can edit our flashcards. Oh, and we can also remove this flash, but I haven't saved this, so flash is still gonna be displayed here, but you see that we can now edit FLA, and you see that the change, once we submit the cards, the state can be retrieved using the submit card button. There is one small glitch that it allows empty submission. We can prevent that very easily by adding a required attribute, required here and also here on the other input. That's done, and we also saved this empty string. So reloading the changes, and you see that we can still submit. But as soon as we empty the front side, there is a validation. That's default HTML5 validation with this default tooltip. If we empty the backside, the same thing happens. Fill out this field, done. So we have everything set up for the controlled component, and it's working as expected. I only owe you explaining why we had this front side backside in two and not just one state variable. So let's also update this other state variable, and let's see what happens. So I'm gonna replace these states with just one state and stat state. And here it's gonna be very similar because it's gonna be state.frontSide. So this is gonna be very similar to what we had in class-based component. It's just not this.state.frontSide or this.state.backside, but state.backside. And instead of the set frontside or set backside, we have set state. And we're gonna do the same thing as what we did before in class-based components for set state. Whatever needs to change, for example, backside, colon, event.current.target.value, we're gonna change it. So Here, remember that in case of class-based components, we had to only enumerate the keys that changed. So I'll add an alert here because we're soon gonna figure out what the problem is with this set state. And here the front side as well. Front side event.current targeted value. This is also gonna be erroneous, but no problem about it for now. So front side, back side is not defined. And lines 19 and 32. No, lines 15. So instead of front side, now we have state.frontside and state.backside. So this is the rewriting if we had just one state and not two. Save. And now the React app is gonna reload. And let's suppose that we add first, second, and now submit the card. Undefined second, interesting. Let's remove something from first. Now we have first and undefined. What is going on? Let's remove something else, undefined SE. So it seems like whenever we make a change to either the front side or the back side, the other is gonna become undefined. And this is the problem, because this object is gonna set the full value of the state to that object. So technically we're gonna have if we change the backside, for example, by default the front side is gonna be undefined because it's gonna be removed from this object after the set state. Whichever key we ignored is gonna become undefined. And it makes sense because set state here doesn't work in the same way how the set state of the class components work, because there it was enough to specify a subset of all the values, but here it's not gonna be enough anymore. We'll have to specify everything, all the state variables. So technically we could get away with adding the backside and this dot state dot backside, or without this, because we're not in a class component this time. So backside state.backside, we could do that. And after the reload, see that we do something with the front side and the backside. And given that we edited the backside last, the front side got deleted. But if I add an X to the front side, you see that the DFD comes back because we included it in the front side object. Now, this is great, but the only problem is that what happens if we have 10 different state variables? Now, in this case, we can do the spread operator, state, comma, and then we spread everything. And it's important to put the state in front so that we can override it later with the front side or with the back side. Let's see how this works. Reloading, and I'll add a G and an H here. You see that everything is working. A D here, still working. I'll add 2 H's. So this seems to be working, but make sure that you add the state in front. Okay, this was the small issue about using the state in the same way how we would use in the class-based component. It's kind of problematic here, you see. So you have to always take care of mixing in the state. And for this reason, we're going to revert the change. So let's see how many things. Yes, state, that was not needed. And what else was not needed? Yeah. Here we had the uncommenting, and I think here this was still, yeah, adding the required field. So I'm gonna delete the state and just stick to this front side, back side separate state variables. Let's take a last look at our application, and you can see that they are still working. Now loading sometimes takes time, like this time, but it's gonna be soon there. Next up, we're gonna add a new card whenever we press the submit card. So right now we just have the pop-up with the alert window or the alert operation. In the next section, we're gonna add the proper card and maintain the main app state with it. We have seen before that if we store our global state in the app, and this is what we did because we fetched the countries in the app and stored them in the state variable with cards, or in the functional component you had the cards, set cards, and this is the same state declaration, then it was very easy to move downwards and push the state downwards. Because, for example, we had this card list component here, and we put the card data inside this prop. So if you want to add some state variables to your children, then you can pass them as props. It's easy because whenever your state changes, as your global app component state changes, then as you go downwards to your children, they get re-rendered as well. So you render yourself and your children are re-rendered too whenever the state changes. And React's differential rendering algorithm makes sure that we only re-render the components that have to be rendered because of either state change or prop change. So when we change the props, the component also gets re-rendered. Unless we prevent it with a lifecycle method, but that's another story. We're not getting there because now we will not prevent re-rendering. It doesn't make sense in this situation. But there is a problem that it's very easy to push state downwards. How can we lift state upwards? The child component should not have any knowledge of its parent, because the parent controls the child, but the child doesn't even know what kind of parent it has. It makes sense because you can embed a React component in multiple contexts. You don't have to have a card inside a card list. You can render a card in here as well. So you can do card front side equals, and then whatever first, backside equals back. So you see here the parent is gonna be the app and not the card list. Although it's not working because card is not defined here, you would have to import it, so why not? I mean, just for the sake of this experiment, you see that we're importing card. And one more change, that it's better if we import it at the top, maybe even before the card form. So let's see what this looks like. Unless we have other errors, which can be because I might have forgotten something, can't resolve. Oh yeah, card list slash card, so we have to go back up and delete the list. Live recording. So now the app is rendered. And you can see the first, and it's working. It's a full-fledged card. You don't have to put it inside a card list. It just works by itself. So this means that by definition, the component itself, let it be a card, let it be something else, shouldn't know about its parent. Why would the component know? It can be used in different contexts. So how can we make sure that we can lift the state up to the parent? Because if we add a card, a new card, then we have to get back to the app to modify the card's state of the main app. So to do this, we will need to define a new function in here, and we will define the add item functionality here. This makes perfect sense, by the way, because this is where the add item functionality can be performed. Otherwise, we would not have access to the whole state. Well, we could have access to the state and the card list, but still the state is coming from the app. So this is where we have to import it. And what do we need for an app item or add item? Front side and the back side. So that's it. Let's see what we need. We need to call this set cards. For this set cards, we can call a function previous cards, an arrow, and here we're gonna have an arrow with the new object that we create, front side, back side, and the remaining cards, so previous cards, like this. Formatting helps a bit, so if it's a bit hard to read this, then this is the input and this is the output. and this is the set cards. We're setting the cards by adding the new card to the very top. This should make sense. But now we have a problem. Not only that we were negligent enough to keep importing the card, while we shouldn't anymore because we're not using the card, but the real problem is, how do we use this add item? What do we do? Because we would have to call this add item exactly in the event handler of the cards form instead of this alert. But this add item function is not there. It's here in the app.js. So what is going on? What can we do? And now comes the trick. The trick is that we have to pass this function as a prop downwards, and then we will call this function in its proper place inside the child component. And this function is going to be a function defined inside the parent component. This doesn't violate the what a child should know principle. So we can still add this add item in here in the card. Well, actually it's not in the card list, but in the card form. So add item equals add item, because that's where the submit button is. We will do something with the card list later when we will delete cards. So that's gonna come, but for now we'll add it to the card form. So this means that we have to go back to the card form, and now in the card form we have the add item, and you can see that we have access to all the props. So this means that instead of the alert, now we have access to props.addItem. It's already there because we included it. And then we have front side, back side, semicolon. Let's see if this is working. So we're saving changes. And that's it, basically, beyond any errors that I could have committed. Actually nothing. And that's all we need. So we had front, we had back, submit, and there you go, new card. Now there is only one problem though, because we can add another front and back, and now we have two fronts and two backs. So we need to do something about this. Does the cards form know about what to do? Well, obviously no, because the cards form doesn't have access to the main state of the app. So we have to do it inside the add item. And here we need to add some conditionals. So for example, we can use the find method. The find method works as follows. Imagine that we have different elements. So we have an array. I'm gonna open a new console window and demonstrate what the find is doing, because we haven't talked about the find, the map, filter, and so on. Actually, we have talked about the map, but not the filter and find. So imagine that we have an array of numbers, like 3, 4, 5, it's better. And if you add array.filter, and we're gonna filter, for example, the ones that are greater than or equal to 2. So you have the input, you can call it num, as in number, and num greater than or equal to 2. So you see that this is the input, this is the output. The output is always a boolean in case of filter. And this boolean can be true or false. This means that if this boolean is true, we keep the value, otherwise we drop it. And then we collect the values for which this output is true and return it in an array. So greater than or equal to 2, it's these 4 numbers. If we had less than 2, then we have just this number, or less than 4, then we have more numbers. Once again, the arrow function is not mandatory. You can write function num and then open brace and return is the same thing. So if we did that, we would have the same solution. Okay, that's filter. So you see that we have multiple solutions here. What happens if you change this to find? Let's see. Then we get only one solution. And what happens if we don't find anything? Then the return value is undefined. So you see that the return value is undefined if we don't find anything, but for filter, the return value is empty array. So this means that we can simply use the find, and it's better to use the find because as soon as we use the find, for example, we find the first element, the 1, and we exit the whole find. So we have find, and that's what we will need to do. We have the cards, that's in our state, and we have to find a card that has the same front side, card.frontSide, as the one passed to the function. If we have this, then it means that that we should not add the card, and we have to present some alert message. So we can do it with type of this cards.find not equal to undefined. I'll explain this in a second. So when this is not equal to undefined, this value, the type of it, then we can just do an alert. The front side has to be unique. Card was not added. That's it. So this is the code, and here notice this expression, type of not equal to undefined. Maybe it would be easier for the explanation to add the const same front side card equals this cards.find, or rather card with same front side. And I'm gonna use this variable so that you see exactly the type of operator in action. Type of card with same front side, not undefined. If we go back here, you say, for example, var first card equals undefined, like first card not equals undefined, but equals, for example, empty object. So type of first card, it's gonna be an object. It's not empty, it's an object. This is what we will find normally. But if the type of, for example, second card, if you check that, it's gonna be undefined. It's not undefined as a value, but undefined as a string. That's why I added undefined as a string here. And also notice that second card was not even declared. So if I add type of, and something I have definitely not declared before, that also works with the type of. This is why I normally use the type of operator, because it's bulletproof, it doesn't show any errors. As long as we know what we're doing, it's good. Otherwise, sometimes using the error is better. So now, if we have the same front and back, then we're catching the error. Let's test this. So let's see, for example, if I add Albania. So Albania, and then some backside. You see that the front side has to be unique. Card was not added. But if we add front and back, it's gonna work because we reloaded the page, so we didn't save this front side, back side. Great. So now we have front, back, they are separate, and it's now working. It's a little inconvenient that the front side and back side are not cleared. So we can do that too in the form. After the submission, we can call set front side empty string and set backside empty string. Remember the principle of controlled components. Whenever we change the state, the component obeys, and it also changes its appearance or rendered values. So front, back, We're adding in the new card just like before, and you see that now the card is empty, and you can also see it from the state that it was empty. It would be great to delete this card because this is complete nonsense, but we're not there yet. So you see front, back, and the DS. So that was it for the add item. Next up, we're gonna delete items. So we're missing the delete item anyway. It's time to implement it. In the last section we saw that there are some cards that we would prefer deleting. For example, if you made a mistake, right now it's not possible to delete the card. So this is what we will do now. For the deletion, let's do some cleanup, because you can see the add item here. We checked if there is another card that had the same font side as now. This is working, this is fine, but I think that we can do a bit better, especially considering that we can add the card, for example, front back, then we can delete it, and then we can re-add it afterwards. Possibly in a way that we can add a front, and instead of the back, we can add something else. Of course, I cannot add the card now because the front side is the same, and this is exactly the problem, that if the front side is the same as before, then it would be better if we received a different UUID for it. Or just imagine that we had two cards with the same front side. Right now it's a constraint that it's not possible, but we can never be sure that one day we will develop the application in a different way, and then the UUIDs won't really work, or the front side as key for the deletion wouldn't really work. So we will rather use the UUIDs in a slightly different way. So let's go back to the app.js. Let's do some cleanup. Actually, this card data is bothering me a bit. Now, we will not use it in the future anyway because we now have APIs, so we don't need to hard code it. Or we can just start with an empty state because now we can add cards, so there is no problem with having to use a default value. So the UUID creation is possibly a misplaced functionality, because on one level you have the key and the UUID, but on another hand it would also be great to identify with a UUID on top level, on state level. So we could remove this UUID import from here, and instead of this UUID import we could add a props.id as the key here. So instead of UUID v4 you would add props.id like this, because we're gonna create an ID field as well to the state on top level. So now we're gonna use this ID to locate cards instead of the previous ones. So this is the main change in the card list. Of course it will break the application, but we have a long way to go. So I'm gonna add the UUID on top level, and let's see what kind of changes we need afterwards. Wherever you have this front side and back side, basically you need to add an ID as well. So here you have comma and ID, UUID v4, and now you have the UUID. We will need this later as well, because this is just a copy-pasted version of the other solution here. So you will need this return front side back side in here. Oh yeah, we also need the get name and capital function pasted like this. So function get name and capital, and this is where we're gonna use the get name and capital, so that's set. And now in the new item as well, so we have the new item here. We had front side and back side, that's already there. Maybe adding this open bracket here would make more sense. We have the previous cards, and we also need to close Great. So instead of this front side and back side, we will need the new item, including the UUID. So, oh, actually, it would work like this. So let me just revert it. So here, set cards. Before the set cards, we can add a new item constant. New item equals brace, and then we have front side, back side, and ID, and here the UUID v4. So we have these items, and then we can just replace this front side, back side with the new item, so that it's a bit shorter. You can also write it in just one line. It might be a bit helpful for readability's sake. Let's save changes. And now we have the ID passed, because whenever we add the cards, we pass the ID with it. So we have the ID inside, and technically the UUID should be working. So after saving changes, I'm not sure if the page got reloaded already. Now it got reloaded. Let's see if we have errors. No errors. And let's see the developer tools as well for components. So remember the React developer tools that we installed not too long ago. We have the cards here, and it has a backside prop, a frontside prop, and a UUID prop. Let's remember that 2C20 is a UUID for the second prop. So let's see the app functional component. It also has state, and now inside the state we have the ID as well added. If we add the new component, now the first card is gonna be this new one, and it does have an ID as well because it was generated. So this was just some small change, nothing really major, and I'm gonna use this UUID property on top level for the deletion. So that's why we did this. So now the next task is to take care of the delete item. It's the same spiel, function delete item, and now we're gonna request an ID, because if we have an ID, then we can set the cards just like before. So remember that we had the cards and set cards state, and this is the setter of the state, and here we have previous cards. And now we'll use the filter method. So remember that filter just keeps whenever the output is true, or the value of the function is true, inside previous cards.filter, and here we need to pass a function that checks for each and every card if the ID of the card is different than the ID passed to the delete item. So we'll keep all the cards that have a different UUID than the one that we want to delete. And this way we'll include everything we want to keep, and we'll delete the one card that we want to delete. This is the main idea. And technically we'll always call this with an ID that exists in the cards, but if it didn't exist, then it would just include all cards. So if I add the delete item with an invalid ID, no problem, we would just keep all the cards. That would work as well. It's that simple. The deletion is that simple, and we will need to pass this delete item prop, delete item, here with the delete item functionality, so that the child can call it with the proper ID. That's all the responsibility of the child. We give it the delete item, and then the child will call it. So let's go to the card list, because now we're on the card list. You can see that we have card data. After the card data, we need to add the delete item. This is going to be the function, and we need to pass it to the card. So we have the key with the props.id, and we have the delete item equals, and still delete item. I know it's kind of cumbersome to keep on passing these props. It's also called prop drilling, by the way, that we drill down and we need to nominate these, like delete item on this component, pass it to your child. You get your delete item, pass it to your child. And this can become really long. The same problem happened in another library called Backbone.js, by the way. It's the same thing reinvented over and over again. And there are solutions to this. In React, one solution would be the context API, another solution would be Redux, like using Redux. There are many other solutions as well. And we're not dealing with it here because for now, the objective of this tutorial is that you get started with simple components in an understandable way. But of course, later and also in the course that I'm preparing right now, so sign up for it on joltnoy.eu. It's gonna be something that we'll cover, so everything like context API, Redux, and so on. So the website is joltnoy.eu, by the way. It's put it in your browser and you can sign up there, and I'll notify you once the course is ready, or maybe it's already ready, who knows. So it's definitely worth checking out the advanced concepts and everything else, but only after you got started and you know the basics. So, and that you can obviously get it from this video. We have the delete item now passed to the child, and now we need to go to the card, the individual card. Where is it? Here. And this is our card component. We have front side, back side. We also need two more things. One is that we now pass the ID as a prop because we included it on top level. We're receiving it in the prop. It was enumerated. And we also need the delete item. So whenever we delete a card, and we will soon figure out how to solve this, then we will know that we need to call this delete item with the ID. In theory, the parent could do it as well, to include the ID in the delete item function, but we're not there yet. So we have a href equals JavaScript void 0. This is just some trick so that we're not routing anywhere else. This is a no operation. It's not rocket science. So if you go to console and you write void 0, it's nothing. Void is also so void 0 like this. It's also undefined. It's just a notation so that we hack the href of the anchor, because if we didn't have an href it would be invalid, so we're finding a way to not make it invalid. And then we'll add an X. This is gonna be placed on the top right, and if we click the X, then we'll delete the card. That's the idea. We will need some styling, so let's add a class name to it, card delete, and we'll need an onClick. OnClick, it would be funny. OnClick equals handle delete. So we're done with href class name onClick. Remember, if the line is too long, you can reformat it like this. And we're set with the X. What is the problem? Handle delete is not defined. Of course not, because we haven't created the function. We have handle click, and now we'll have function handle delete. It's so easy, the handle delete. All we need to call is delete item and ID. And we have the ID, we have the delete item. So the functionality part is done. We just need the styling part. So saving changes. And reloading the component. The X is looking kind of ugly, but it doesn't matter, the functionality is there and we can test it. Look at this, Afghanistan is deleted. And now we have front and back. Let's add front and back. It's here. You can delete it, done. Let's add front and back again. Done. Let's try to add front and back. It's not working because we already have a front and back, but we can delete this one. we can delete this country, this country, this country, and the order stays the same, everything else stays the same. It doesn't matter if we delete it from the front or from the back, it works regardless. So now that we have the functionality, let's work a bit on the styles. We want this X on the top right with some slightly better styles. It doesn't have to be perfect, it just has to do the job. So the style sheets are gonna be in the card component. So it's the same card. You just open the card.css and let's work on this card. So we'll need to work on the X, the card underscore underscore delete. We'll put it under the card. So card delete. By the way, this is a block element modifier class notation. The card is the block and the delete is an element inside the block. We don't have modifiers, it's just block element this time, because this is not a CSS architecture class. If you want that, I have a course on SitePoint on CSS architecture. So card underscore underscore delete. First bothering thing is the decoration. You can see it at the very bottom. We'll do text decoration none, and then the color, the usual dark green should be fine. I'm not doing special extremely good styling, it's just something that works. Font weight bold, so that it's a more like a stronger X. Let's do some fixed width, height 25 pixels, and we're gonna position it on the top right. That's why I'm adding the width and the height already. The font size should be something smaller, and let's say the line height is 25 pixels so that it's centered. Technically it would be better if we had an even number, so let's do 70 pixels, and then it's gonna be the same number at the top and at the bottom. And we're gonna do position absolute. Most people have a problem with position absolute because they miss the fact that you need to add position relative. I'll show you what happens if I don't add this position relative. Let's save. Oh, actually, before saving, we need to specify the top. Given it's top right, we need to specify the right. And maybe adding some margin would help, so that it's not exactly glued to the right, top right. And maybe adding some padding would also help. Because if we add some padding, we could add the border on hover. So we have card delete hover. I know I'm a bit ahead of myself. If you add the border, 1 pixel solid dark green, and here we add the padding of 0. It's gonna be good because the border is gonna be 1 pixel wide and the padding here is 1 pixel. So here the border is 0 and here the padding is 0 and the other one is 1 pixel. So we're not gonna have any flickering when we hover the mouse over the X. So let's save changes. You see that now this X is on the right and we can hover and the border is there. It's still not on top right though. So we still need to work on that. And by the way, position absolute here, that was a mistake. So maybe that's why we had the problem. Yeah, now it's correct. Now it's correct. So we have the position on the top right. And let me show you what happens if I comment out the position relative of the parent. All the X's go to the top right because the positioning is relative to the top level element, which is basically the whole screen. So it's now, if we add the position relative, it's gonna become relative to the container, which is the card. So you see that it's on the top right and we have the border around it. It doesn't look that good yet. We can work a bit on the hover styles. So we can add some box shadow just like here. We're copying the box shadow. We get inspired by that one. Not here, but in the delete as well. So delete hover. We're adding a box shadow and maybe increase this to 0.5. Let's see what happens then. We're gonna add the box shadow. Anyway, we'll see it soon. I'll add the background color to it and hover white, and maybe a more significant color like red will do. We have the border. Adding a border radius would help, because it's kind of weird that we have this X. See the shadow, it's looking good. Rounding this X would help as well. So after the border, we'll add border radius. We'll add something big. So now it's gonna be circular. Okay, that's fine. So we click it, and then we're deleting the value. So with that, we're done with the deletion. I think that we have everything we need to add, delete cards, front side, back side, components are communicating. So if you've gone this far, great job. We will soon host this application on GitHub pages, by the way, so stay tuned for that. Just one thing that could be corrected in this card.js file, namely that normally we don't really use anchors in React, because there is React router, there is a link, which is a React component. We're not really dealing with it here. Normally we use just buttons and don't rely on form submissions, and if you want to reroute, we just use React router. So that would be the main idea. That's a bit more advanced topic. Here we're just building a flashcard app, so I didn't make use of it. But normally, instead of anchors, we can use div source spans. Doesn't really matter what we use here. And then we can get rid of the href. If we didn't get rid of the href, then it would be better to just create something either relative or something that's not JavaScript, because these JavaScript hrefs will be removed for anchors in future React versions. That's the most important thing, and that's the main takeaway of this extension that I'm recording. So with the span, it's supposed to work as well, and if you reload the page, then you will see that the result is still gonna work as expected. You can see the app loading up, the X is still on the top right and it's still clickable, so nothing really changed. The app is still working. So we could do a lot of things with this React app, this flashcards. So for example, we could randomize the order of these cards. We can select a finite number of cards, for example 10 or 20, or we could do many other things, including different use cases, not just capital cities, or we could save things to the local storage or to a database or create our own API. So a lot of things are available. Instead, I'm gonna deploy this React application to a github.io page. So you can see this is not my official blog, by the way. My official blog is zsoltnagy.eu. This was my blog from 2015, as you can see, and I even ported these blog posts because they were basically markdown posts, so it was kind of easy to load it to a markdown reader and in my new blog. So you see that this is a blog, and I don't really want to get rid of it because it's still driving some traffic. Not much, but at least some. So how can we deploy a React application to a domain, a github.io domain that is already taken under, for example, /flashcards or something. So /flashcards, like this, or flash-cards. And this is what we're gonna do. And you might be able to see from here that I have done this before. So, for example, there is this Bootstrap Webpack. I'm not sure if it's still online. No, it's not right now. But there have been multiple cases when I did upload some things. For example, this Giphy project might be still there. Yeah, this is some simple Giphy project. So that's also uploaded. And we'll be able to upload our React app to this github.io page flashcards. So right now you can see that the 404 page is gonna be the one that's gonna be displayed as soon as github.io manages to handle that. Until then, we will prepare our application to be uploaded there. So for that, I will open the terminal. So for me, it's Control and the single quote, but you see it in the new terminal, or Control Shift single quote, that also works. So this is the node, and I'm gonna create a new terminal. Who knows what else I was doing in the other terminals, because I'm also teaching quite often, and some terminals might still be needed in the Visual Studio Code as I move back and forth. So we will need to install GitHub Pages. npm install ghpages -- save dev. ghpages is gonna be the npm package that's gonna help you deploy GitHub Pages. If you need sudo privileges, then write sudo in front of it. Oh, and by the way, I need to stop this. So I'll write Ctrl+C because it's installing it at the wrong folder. We need to go inside the project folder to make this effective. So let's go inside cd cards, because you can see that the React app is now here. It's a branch. I'm using the React app branch for development for now. npm install ghpages save dev. I could have just pressed up twice, the up key, but this way it's working too. And with the save dev, you will see that it's gonna be included in the package.json. Right now, in the dev dependencies, so you just only have regular dependencies, but no dev dependencies. That will soon change, because we're saving this ghpages npm package inside the dev dependencies. And then we will use ghpages to deploy stuff. While it's loading, I can configure the package.json. So we need a package.json change, a new field. So let's add a home page. It's gonna be home page. And this home page has to be a string, http Zsolt, so my GitHub username, .github.io / and here there is gonna be the repository name. So whatever we're gonna create, so Flashcards, for example, this is gonna be the repository name, and comma afterwards. Second, we need to add the deploy script. The deploy script is here, deploy : and here we are executing ghpages, which we are installing right now, -d, and build. You will also need a pre-deploy script, pre-deploy, with npm run build. This is also going to be important because we need to build the application before deploying it. I noticed one more thing, that it's that the repository name is React Flashcards. I'm going to make the change there too. And now that we have the setup, all we need to do is write npm run deploy. You see that the pre-deploy script is executed, the npm run build, then the React scripts build, because the build task is this React scripts build. And after the build is completed, then the ghpages is gonna be executed. We're creating the optimized production build, and now comes the ghpages deployment. You see it's assumed that it's hosted at React Flashcards inside my page, my GitHub.io page to be exact. And we're done. The page is published. Sometimes we'll have to wait a couple of seconds. Where is the flashcards? It's not the one. It's React Flashcards that has to be hosted. It's still not found. Be patient. While loading the application, I'm gonna show you what's going on. So I'm right now on master, the master branch, and we can also go to ghpages. So on GH pages, this is another branch. This is where the deployment is. And you see that everything got deployed 2 minutes ago. So it was just now the deployment. There were some static files, favicon, the index.html, everything is in there. And if you open the index.html, you see that everything got minified in a bundle, in a proper bundle. And even the JavaScript got uglified. Everything is in one line. So this is indeed a production build. And this is what's hosted. Because this GH pages branch was generated by the GH pages npm package that we ran, this utility. And now, if you refresh, we also have the flashcards, the front side, back side, and the cards appear as well. So everything is working as expected. We can also add the front, back, just like before. And you can see the back side. And look at this. We successfully hosted a flashcard on github.io for free, because you don't need to pay hosting costs. You don't need to pay to host your repository. You don't need to pay anything. You can start developing your React apps for free. You can host them on your portfolio page. And everything is working smoothly. You see, if I went back to my main page, which is my Jekyll blog, by the way, I could place a link in here to my portfolio item, the React app. So this is what you can do as well yourself without setting up a server, without paying for domain hosting, anything else. Today. You can do this today. So this is very encouraging, hopefully. Obviously, you can make some changes to the app so that it's completely yours. Not necessarily this app, but create your own idea or clone, for example, Twitter, Facebook, whatever. Well, not the whole Facebook, but just some parts of Twitter, for instance. You could do that. Or some app that you're using, for example, Kanban Flow, Trello, some running app that also works, for example, Strava. You can do a lot of things. You might be using a lot of different apps. Just make sure that that the app is not too heavy on graphics. It should be more heavy on simple things. And if you want to make it look better than this app, then use a component library. For example, I recommend Material UI. It's even better than Bootstrap together with React. And then you can do a lot of other things as well. This was the React application. We could continue, so we could do a lot of other things with this. So for example, the state management is not ideal because we are drilling with the props a bit too much. We could create a version with a context API. We could add a React router. And by the way, talking about React router, it's not that easy to host a React router application on GitHub pages. You need to do something special and enable the hash routing. So hash routing would work like this after the hash mark, because otherwise the router of GitHub pages would take over and it would not work. Okay, so make sure that you remember that once you go to the React router. In the final course version, for which you can sign up on my website zsoltnai.eu, by filling out the form here. Right now it says JavaScript, but it will be React as well a bit later. So you fill this out and you will get notified once the React course is out. So that's the next thing. If you watch this video later, then you will be notified in the notes section of this video. So there are a lot of things to learn, obviously. There is gonna be the new version of React where some things are gonna change. Obviously, React is doing its best to be as backward compatible as possible. There is also Redux. That is not a bad idea to use. There are some types of apps where Redux helps you structure your application. There is React Router. There are some component libraries, styled components, and a lot of other topics. So if you want to be advanced in React, then check out the course. Otherwise, you can get started with just this knowledge. This is enough to build your first applications and to host them online. So it's more than enough. You don't need anything else. You really don't need anything else to get started. So I encourage you to create portfolio items, because people will hire you more easily if they know that you can get things done. This was the React tutorial. I hope you liked it. If yes, smash the like button below the video. And if you're interested in another tutorial on another topic, for example, then let me know what you're interested in the comments below, and there is a chance that the next video is gonna be about your request. Congratulations, you made it to the very end. How was that? I hope that you really improved your skills during this 7 hours course, and you also built an application. So there are a couple of things. First of all, if you built an application and you're hosting it on GitHub pages, comment in the description below. I would like to see the applications that you built, and this means that some of you will be able to win my advanced React course. This makes sense because, if you build an application first and you reached a certain level, you might want to go to the next step. And if you want to go to the next step, then share your application with me, and I will select 5 people who will be able to participate in my advanced React course as well. So let's see how to move forward. So the path towards React mastery. If you have seen some React documentation or React videos, you see that there are some concepts that we just couldn't cover in this depth because this course was, of course, made for beginners. So this means to you that some concepts might be useful to you. For example, the context API, which will eliminate prop drilling. So you don't need to pass your top level state as props to the subcomponents and the subcomponent of the subcomponents. You can just use a context, and with the context you will be able to represent your state and manage it and provide the state wherever it needs to be provided. So this is a great update. Then we will have Redux. Redux is a full framework, state management framework built on top of React, or basically it's something that that complements React to make it a full-fledged framework, and this could also be a path to learn. Not everyone likes Redux, not everyone uses Redux, and not every application is meant to be written in Redux, but it's also good to know regardless. Then you could learn how to write your own hooks, how to use the React router, and warning sign, important, React router. Hosting on GitHub pages is relatively hard if you have a React router and your router configuration is not good, because GitHub pages has its own routing. And if the URL is modified by React, then GitHub pages' router will take over and you won't be able to navigate in your application. So that needs some extra configuration. Make sure that you use hash routing. So that's one thing. And then we haven't touched on using component libraries, so you had to settle for my styles. And I'm not a designer, I'm not a styling expert, I just use whatever makes sense. So the next step to improve the look and feel of your applications is to use a component library that looks good and preferably is written in React. So for this reason, Material UI would be a great choice. Then you could learn higher order components and portals. These are more advanced topics. And also you could build your own hooks. You could learn how to create prop types to define the types of your properties. It's not here, by the way, that besides prop types, you could also learn TypeScript. So that's the typed version of JavaScript that goes very well with React as well. So React plus TypeScript, a lot of people like that. And these are all improvement suggestions, that new techniques that you could learn. Then there is automated testing. So for example, Jest, or the previously React testing library, now it's just called testing library. Very interesting name, right? So there's a lot of fantasy. This is the testing library. So what else would it be? So regardless, automated testing is important, especially on production ready applications. So you could learn that, but think about it. If I showed you automated testing and started writing in, for example, even in test-driven way, then there is a chance that you would have been bored out of your mind, that, oh no, not again, we have to write the tests, right? And this wouldn't have been a 7-hour course, but possibly 10 or 11 or 12. So then there are some advanced things for performance optimizations, concurrence mode, and React 17. That's another story, like what comes in React 17 and in later versions. So there are many different improvements, and techniques that you can learn in the future, and also building different applications where we don't just have click handlers and submit handlers, but possibly there is an option to create something like Kanban flow or Trello, where you have boards and carts and you can drag and drop the carts. So that could also be great. Or a timer, and how to set the timer, how to set up a Pomodoro, for example, where you have 25 minutes of focused work on a card, and the countdown goes down, and as soon as you reach 0, for instance, then an alarm is coming to you, and we could even play some sounds. So there are a lot of different things that we can do in a React application that will come later, possibly not only in the course but also in some other videos that we will see. So once again, React course is coming. Sign up on my website zsoltnai.eu, link is in the description below, and this will mean to you that you will be able to continue learning React, the ins and outs of React. And that's it. So if you like this video, press the like button, or as Hulk would say, smash it. And this means that more people will see this course and more people will learn the basics of React. And this will also mean that there is gonna be a shortage of React developers anyway, like good, competent React developers. And for this reason, the more people know React, the better React will be, because if we find enough competent React developers also in the future, then this will mean that it will be worth for Facebook to continue giving updates to React. The ecosystem grows, and React will maintain its position of being the biggest JavaScript library for writing applications, web applications. So it's a journey worth taking. Thank you for being with me for so long, and I hope that you learned a lot, and see you in the next video.